Hello and welcome to Pre-Algebra Practice Set number 1. And in this video, we're going to look at some additional practice problems for our lesson on place value. So for the problems we're going to look at today, we want to state the place value for the underlying digit in each number. Let's look at our first problem. And we're going to start out with 5,089, and our underlying digit is this 0 here. So the easiest way to do this is to take this number and put it in our place value chart, and then we'll find the place value for the 0. So to use a place value chart, basically you take the rightmost digit of the number, which in this case is this 9 here, and you put it in the rightmost column of the place value chart. So the 9 goes into the ones place. Then as you move left in the number, you match that movement on the place value chart. So we move left one digit to 8, and then we move left one column to the tens. And we keep doing that. So the 0 goes in the hundreds, and then the 5 goes into the thousands. Now, we want to find the place value for the 0. The 0 is right here, so that's in the hundreds place. So the answer for this problem is that the 0 is in the hundreds place. Okay, for the next problem, we have 593,272. And again, we're looking for the place value for the underlying digit, and in this case, it's that 9 right there. So let's go ahead and take this number and put it into our place value chart. We start with the rightmost digit, which is this 2. We put it in the rightmost column, or the rightmost place of the place value chart, so the 2 goes into the ones place. And then we're moving left in the number, and we're matching that on the place value chart. So we have a 7 that's going in the tens place. We have a 2 that's going in the hundreds place. We have a 3 that's going in the thousands place. We have a 9 that's going in the 10,000s place. And then lastly, we have a 5 that's going in the 100,000s place. Now, the problem is asking us for the place value for the 9. So the 9 is right here, and that's in the 10,000s place. Okay, let's write that out. The 9 is in the 10,000s place. Okay, for the next one, we have 627,575,111. Again, we're looking for the place value for the underlying digit, which in this case is this 6 here. So let's go ahead and take our number and put it into the place value chart. So we start with the rightmost digit, which is this 1. We put it in the rightmost column, which is the ones. And then we just move left and we match that on the place value chart. So we're going to have a 1 that goes in the tens. And then we're also going to have a 1 that goes in the hundreds. Then we're going to have a 5 that goes in the thousands. We're going to have a 7 that goes in the 10,000s. We're going to have a 5 that goes in the 100,000s. We're going to have a 7 that goes into the millions. We're going to have a 2 that goes in the 10 millions. And then lastly, we're going to have a 6 that goes in the 100 millions place. Now, it's asking us for the place value of the 6. And as I just said, this 6 is in the 100 millions place. So let's go ahead and write that out. This is in the 100, okay, the 100 millions place. Okay, for this one we have 2,257,968, and we have this 8 that's underlined here. So this one's pretty easy. At this point, you probably know that the rightmost digit of a number is in the ones place. But we're going to go ahead and take this number and put it into the place value chart anyway, just to get some practice. So the rightmost digit, or the 8, goes into the rightmost column of the place value chart. So the 8 goes into the ones, and then we're just moving left. So the 6 goes into the tens, the 9 goes into the hundreds, the 7 goes into the thousands, the 5 goes into the 10,000s, this 2 goes into the 100,000s, and then this 2 goes into the millions. So we're looking for the place value of the 8, and that's real easy. It's in the rightmost column, or the ones place. So we'll put that this is in the ones place. Okay, for the next number, we have 6,751,031,927,151. So again, we want to find the place value for the underlying digit. And in this case, it's this 6 that's all the way to the left. Now, we'll take this number and we'll put it into the place value chart. Start with the rightmost digit, which is this 1. Put it in the rightmost column. So the 1 goes into the ones place. And we just move left in the number and we match that on the place value chart. So the 5 goes in the tens, the 1 here goes in the hundreds, the 7 here goes in the thousands, the 2 goes in the 10,000s, the 9 goes in the 100,000s, the 1 goes in the millions, the 3 goes in the 10 millions, the 0 goes in the 100 millions, this 1 goes in the billions, the 5 goes in the 10 billions, the 7 goes in the 100 billions, and then finally the 6 goes in the trillions. Now again, we're looking for the place value of the 6, and we just said that that's in the trillions place. So let's write that out. This is in the trillions place. Okay, so for the last couple of examples, we're not going to use a place value chart. So again, we want to state the place value for the underlying digit in each number. So we start out with 10,259,113. And we have two underlying digits. We have this 5 and this 0. So how are we going to do this without a place value chart? Well, if you watched the lesson, I kind of gave you a little trick for this. When you think about place value, pretty much anybody can remember that the rightmost digit of a number is in the ones place. So this is in the ones place. As you move to the left, okay, you multiply by 10. So going from this place to this place, I take 1, I multiply by 10, and I get 10. So the next place to the left is in the tens place. And I just keep doing that. 10 times 10 is 100. So the next place is the hundreds place. 100 times 10 is 1,000. So the next place over is the thousands place. Then I multiply 1,000 by 10, I get 10,000. So this is in the 10,000s place. Then 10,000 times 10 is 100,000. So this is in the 100,000s place. And then 100,000 times 10 is 1 million. So this is in the millions place. And then lastly, we multiply 1 million times 10 and we get 10 million. So this is in the 10 millions place. Okay. Now we're interested in the place value of the 5, which is in the 10,000s place. So the 5 is in the 10,000s place. And we're also interested in the place value of that 0 there, which is in the millions place. It's in the millions place. Okay, our last problem is 800,542,947. And we have 3 digits that are underlined here. We have this 4, we have this 5, and we have this 8. So again, we don't have a place value chart, but we're going to use our little trick. We're going to start at the rightmost digit of the number, which in this case is the 7, and we know that's in the ones. Now, as we move left, we multiply by 10. So 1 times 10 is 10. So the next digit is in the tens place. And then the next digit over is in the hundreds. And then this will be the thousands. Right? Just keep multiplying by 10. And then 1,000 times 10 is what? It's 10,000. So this will be the 10,000s place. And then this will be the 100,000s. This will be the millions. This will be the 10 millions. And then lastly, this will be the 100 millions. So again, the digits we're looking for the place value of the 4. And that's in the tens place. That's in the tens place. Then we're looking for the place value of this 5. And that is in the 100,000s place. So 100,000s place. And then lastly, we want the place value of the 8 there. And that is going to be in the 100 millions place. Okay, the 100 millions place. Hello and welcome to Pre-Algebra Test Section 1. And again, we're going to be looking at some problems that relate to our lesson on place value. So for the problems we're going to do today, we want to state the place value for the underlying digit in each number. So we're going to start out with part A. And for part A, we have the number 373. And we have the 7 here, the middle number that is underlined. So the way we're going to do this is we're going to take this number and we're going to put it in the place value chart. And to do that, we take the rightmost digit of the number, which is a 3, and we put it in the rightmost place or the rightmost column of the place value chart. So you'll have a 3 that goes into the ones place. And then we just move to the left in the number and we match that on the place value chart. So we take a 7 and we put it in the tens. Then lastly, we take this 3 and we put it in the hundreds. So it's asking for the place value of the 7, the middle number. And we can just look here on our chart and we can see that that's in the tens place. Okay, so the 7 is in the tens place. So for the next problem, it's part B. We're looking at 1094. And in this case, we have this 1 that is underlined. Now, again, we can feed this into the place value chart. We start with the rightmost digit of the number, which is a 4. We put in the rightmost column or the rightmost place of the place value chart. So the 4 goes into the ones place. Now we move to the left. We take the 9 and we put it in the tens place. We take the 0 and we put it in the hundreds place. And lastly, we take the 1 and we put it in the thousands place. Now we're looking for the place value of the 1. And again, as I just said, that's in the thousands place. So let's write that out. This is in the thousands place. Okay, for the final problem, we have 145,724. So again, let me erase this. We're looking for the place value of the underlined digit, which in this case is the 4. Most of you will know right off the bat that the rightmost digit is the ones, but we're going to feed it into this place value chart just to get some practice. So we'll take the rightmost digit of the 4, put it in the ones place. Then we'll move left. We'll take the 2 and we'll put it in the tens. We'll take the 7 and we'll put it in the hundreds. We'll take the 5 and put it in the thousands. We'll take the 4 and put it in the 10,000s. And lastly, we'll take this 1 and we'll put in the hundred thousands place. So again, the question that's asked of us is to find the place value of the 4, and that's in the ones place. So let's just go ahead and write that. So the 4 is in the ones place. Hello and welcome to Pre-Algebra Test Section 2. And again, we're going to be looking at some additional problems that deal with our lesson on place value. So for the problems today, we want to state the place value for the underlined digit in each number. So we're going to begin with part A, 595,039, where the 9 here is the underlined digit. Well, one way to deal with a problem like this is to use a place value chart. So we have one here. What we do is we just take the number and we fill the place value chart in. So you start with the rightmost digit of the number, which in this case is a 9, and we put it in the rightmost column or the rightmost place of the place value chart. So the 9 would just go in the ones place. Now you move left in the number and you match that movement on the place value chart. So you go 1 digit to the left, which is a 3, and you put that 1 place to the left on the place value chart. So the 3 is in the tens place. Then you keep going. The 0 will go in the hundreds place. The 5 will go in the thousands place. The 9 will go in the 10,000s place. And then lastly, the 5 will be in the 100,000s place. Now, the problem asks us for the place value of the underlined digit, which is the 9. So that's this 9 here, and that's in the ones place. So this is in the ones place. Okay, for part B, our second problem, we have 7,335,197, and now our underlined digit is this 3 here. You have to be careful because you have 2 3s side by side. Just know that's the leftmost 3. So we're going to use our place value chart again. Take your rightmost digit, or this 7, put it in the rightmost column, which is the ones column or the ones place. Then we're going to move left. So we're going to take the 9 and we're going to put it in the tens place. We're going to take the 1 and put it in the hundreds place. We're going to take the 5 and put it in the thousands place. We're going to take the 3 and put it in the 10,000s place. We're going to put the other 3, the 3 we're looking for, and put it in the 100,000s place. And then lastly, we're going to take the 7 and put it in the millions place. Now, as I just mentioned, we want this 3 right here. It's the leftmost 3, this one right here. So it's in the 100,000s place. Okay, let's write that out. This 3 is in the 100,000s place. Okay, for part C, our final problem, we have 153,215,613. And in this case, we're looking for this 5 here. That's our digit that's underlined. So again, we're just going to fill in the place value chart. So we'll start with the rightmost digit, or the 3. Put that in the rightmost column, what we know of as the ones place. Now we're going to move to the left. We'll take the 1 and put it in the tens place. We'll take the 6 and put it in the hundreds place. We'll take the 5 and put it in the thousands place. We'll take the 1 and put it in the 10,000s place. We'll take the 2 and put it in the 100,000s place. We'll take the 3 and put it in the millions place. We'll take the 5 and put it in the 10 millions place. And lastly, we'll take this 1 and put it in the 100 millions place. So we were looking for the place value again for this 5, and that is here. That's in the 10 millions place. Okay, so let's write that out. The 5 is in the 10 millions place. Hello and welcome to Pre-Algebra Test Section 3. And again, here we're going to look at some additional practice problems for the lesson on place value. So for the practice problems we look at today, we want to state the place value for the underlying digit in each number. So let's start out with part A here, where we have 793,227,521. So the underlying digit here is this 9. So we want to find the place value for that 9. And the way we're going to do it on this particular problem is we're going to use a place value chart. So to use it, we just take the number and we feed it into the place value chart. We start with the rightmost digit, which in this case is a 1, and we put it in the rightmost column. So we put it in the ones column, or you could say the ones place. Now as we move left in the number, we're going to match that movement in the place value chart. So we'll go to the 2, and so we'll put that in the next column to the left. So that's the tens column or the tens place. And then we just keep moving left. So we'll take the 5 and put it in the hundreds place. We'll take the 7 and put it in the thousands place. We'll take the 2 and put it in the 10,000s place. We'll take this 2 and put it in the 100,000s place. We'll take the 3 and put it in the millions place. We'll take the 9 and put it in the 10 millions place. And then lastly, we'll take the 7 and put it in the 100 millions place. Now, we're looking for the place value of this 9. And from the place value chart, we can see that the 9 is in the 10 millions place. Let's go ahead and write that out. The 9 is in the 10 millions place. Okay, for part B, we have 103,799, and our underlying digit here is a 7. Now you'll notice here that I don't have a place value chart, and that's because we want to practice getting place values without a place value chart. And the way that you do this is you use a little trick. Let's rewrite the number, 103,799. Now at this point, probably all of you know that the rightmost digit of a number is in the ones place. Now, as you move to the left, so as I move one place to the left, I simply multiply by 10. So if I started out in the ones, I can think of that as just 1. 1 times 10 is 10. So the next place to the left is the tens. And I keep doing that. As I move to the left, I multiply by 10. So 10 times 10 is 100. So the next place is the hundreds. And 100 times 10 is 1,000. So the next place is the thousands. 1,000 times 10 is 10,000. So the next place is the 10,000s. And then 10,000 times 10 is 100,000. So this 1, our final digit to the left, is in the 100,000s place. Okay, pretty simple stuff. Now we're looking for the place value of the 7. That's right here, and that's in the hundreds place. Okay, so our 7 is in the hundreds. Let me just arrow down. That's in the hundreds place. Okay, so for part C, we have 2,375,118, and the 7 here is underlined. And we don't have a place value chart, so again, we're going to use the same technique. And I'm just going to do it on the number that's already given. I'm not going to rewrite it. So the rightmost digit is in the ones place. And then as we move left, remember, we just multiply by 10. So 1 times 10 is 10. So the next place to the left is in the tens. 10 times 10 is 100. So this is the hundreds. 100 times 10 is 1,000. So this is the thousands. 1,000 times 10 is 10,000. So this is the 10,000s. 10,000 times 10 is 100,000. So this is the 100,000s. And then lastly, 100,000 times 10 is a million. So this is the millions. Okay. Now we're looking for the place value for the underlying digit, and that's the 7. And that is in the 10,000s place. So this is in the 10,000s place. Hello and welcome to Pre-Algebra Test Section 4. And again, in this video, we're going to look at some additional problems that deal with place value. So for the problems today, we want to state the place value for the underlying digit in each number. So for part A, our first problem, we have 6,331,227,513,214. And we're looking for the place value of this 3 here. That's what's underlined. And we're going to use our place value chart to find it. Now, to use the place value chart, we start at the rightmost digit, which in this case is a 4, and we put it in the rightmost column. Okay, so that's going to go in the ones column or the ones place. So the 4 goes here. And then we're just moving to the left in the number, and we're matching that movement on the place value chart. So the 1 goes here, the 2 goes here, and then so on and so forth. So we'll have a 3 here, a 1 here, a 5 here. We'll have a 7 here, a 2 here, a 2 here. And then we'll have a 1 here, a 3 here, a 3 here, and then finally a 6. So we're looking for the place value for this 3 here. So notice you have 2 3s side by side. You have a 3 and a 3. We want the right 3. So we want this one right here. And that's in the 10 billions place. So let's write that out. This 3 is in the 10 billions place. Okay, for part B, we have 877,531,000. And you'll notice that we don't have a place value chart here. So to find the place value of the underlying digit, this 7, we're going to use a little technique. Now, when you think about place values, essentially the first position or the rightmost position of a number is in the ones place. So just think of the number 1. As you move to the left 1 digit, you just multiply by 10. So 1 times 10 is 10. So the next place is the tens place. Now we keep doing that. 10 times 10 is 100. So the next position to the left is in the hundreds place. This continues. 100 times 10 is 1,000. So this is the thousands place. 1,000 times 10 is 10,000. So this is the 10,000s place. And then I'm just going to keep going. So 10,000 times 10 is 100,000. So this is the 100,000s place. And then this will be the millions place. This will be the 10 millions place. 10 millions place. And then lastly, this 8 will be in the 100 millions place. So now we know that the 7, which is our underlying digit, and it's the rightmost 7, is in the millions place. Okay, it's in the millions place. Let's just write that out. This 7 is in the millions place. Hello and welcome to Pre-Algebra Test Section 5. And again, we're going to be looking at some practice problems that deal with place value. So we want to state the place value for the underlying digit in each number. And let's scroll down and go to the first problem, which will be part A. We have 17,395,221,422. Now we don't have a place value chart, which is something we've used, but when you don't have one, you can kind of just use our little trick that we've been talking about in the lesson and our previous practice problems. Essentially, the rightmost digit of a number is in the ones place. So it's in the ones place. As you move a digit to the left, you're just multiplying the previous place by 10. So in other words, think about the ones place just with the number 1. If I multiply 1 times 10, I get 10. So the next place to the left is the tens place. Then just think about 10 times 10 will give me 100. So the next place to the left is the hundreds place. We just keep doing this. 100 times 10 is 1,000. So this is the thousands place. Then we get the 10,000s place. Then we get the 100,000s place. And then we get the millions place. The 10 millions place. The 100 millions place. This would be the billions place. And then finally we'd have the 10 billions place. Now, we want to find the place value for the underlying digit, which is this 2 right here. And that is in the hundred thousands place. So let's write that out. The 2 is in the hundred the hundred thousands place. Okay, for the final problem, part B, we have 8,1,343,879,424. So again, we're going to use our technique. Let's start at the rightmost digit, and this 4 here is in the ones. And as we move left, we're multiplying by 10. 1 times 10 is 10. So then we get the tens, then we're going to get the hundreds, then we're going to get the thousands, then we're going to get the 10,000s, then we're going to get the 100,000s. And again, keep multiplying by 10, so this will be the millions, then the 10 millions, then the 100 millions. And this will be the billions. This will be the 10 billions. And this will be the 100 billions. And then lastly, we'll have the trillions. Okay, so the place value for this 8 here is going to be the trillions place. So the 8 is in the trillions place. Hello and welcome to pre-algebra practice set number 2. And in this video, we're going to be looking at some additional practice problems for our lesson on expanded notation. So we'll start out with our first problem, and we want to write 735 in expanded notation. So 735. Just to kind of think about the place value for each digit here, the 5 is in the ones place, the 3 is in the tens place, and the 7 is in the hundreds place. So to write a number in expanded notation, we simply form the sum of each digit multiplied by its corresponding place value. So in other words, we'd start with the 7, the leftmost digit, and it's in the hundreds place. So the digit is a 7, and we multiply it by its corresponding place value. Again, it's in the hundreds place, so we'd have 7 times 100. Then plus, the 3 here is in the tens place. So the digit is a 3, and we're multiplying it by 10. Then plus, we have a 5 in the ones place, so 5 times 1. Okay, do a little multiplication here. 7 times 100 is 700. Plus 3 times 10, that's 30. And plus 5 times 1, that's 5. So as I told you in the lesson, expanded notation is just showing you the value of each digit in a number. This 7 here, because it's in the hundreds place, has a value of 700. Then this 3 here, because it's in the tens place, has a value of 30. And then the 5, because it's in the ones place, is still just a 5, right? 5 times 1 is just 5. So there's your number 735 written in expanded notation. It's 700 plus 30 plus 5. Okay, for the next problem, we want to write 20,761 in expanded notation. So 20,761, and let me just kind of label this. The 1 is in the ones place. The 6 is in the tens place. The 7 is in the hundreds place. The 0 is in the thousands place. And the 2 is in the 10,000s place. So to write this number in expanded notation, I'm going to start at the leftmost number, that 2. And I'm going to multiply it by its corresponding place value. So 2 times, it's in the 10,000s place, so 2 times 10,000. Then plus. Just move it to the right. I have a 0 in the thousands place. So the 0 is just a placeholder. So I can just skip that. I don't need to write it in. But just for this example, I'm just going to put 0 times, it's in the thousands place, so times 1,000. Okay, then plus, next we have a 7 in the hundreds place. So that's 7 times 100. Then plus, we have a 6 in the tens place, so 6 times 10. Then finally, plus 1 times 1, right? Because we have a 1 in the ones place. So do a little multiplication. 2 times 10,000 is 20,000. So 20,000. Plus 0 times 1,000 is 0. And as we'll go over in a future lesson, 0 times any number is always 0. So I could put 0 in here, but it's not necessary because adding 0 to a number doesn't change its value. So I'm just going to move on to this 7 times 100 here. So 7 times 100 is 700. And plus 6 times 10, that's 60. And plus 1 times 1, that's 1. So again, expanded notation has allowed us to see that this 2 is 20,000. This 7 is 700. This 6 is 60. And this 1 is just 1. And again, this 0 here, don't be confused by the 0 there. We have a 0 in the thousands place as a placeholder. Just think about the fact that if you have 20,761 and you didn't have something like 0 that could stand for saying, hey, I don't have anything in this place, but to the next place to the left I have a 2. Well, if I don't have anything there and I don't have anything like a placeholder, the number would collapse down and you would have something like 2,761, and you wouldn't be able to tell the difference between those two numbers. So that's why we have 0 in our number system, and I keep kind of mentioning that in every video so that hopefully you understand that. That 0 is very important because it's holding a space. Okay, it's holding a space so that that 2 can be in its proper position, which is in the 10,000s place, telling us we have 20,000 there. Okay, now we want to write 353,275 in expanded notation. So 353,275. So the 5's in the 1's place, the 7's in the 10's place, the 2 is in the 100's place, the 3 is in the thousands place, the 5 is in the 10,000's place, and the 3 is in the 100,000's place. And to save time, I'm just going to do the multiplication as I go. So I start at the leftmost digit, which is the 3, and I'm going to multiply it by its corresponding place value. So it's in the 100,000s place. 3 times 100,000 is 300,000. So 300,000. And plus, now I have a 5 in the 10,000s place. 5 times 10,000 is 50,000. And plus, I have a 3 in the thousands place. 3 times 1,000 is 3,000. And plus, I have a 2 in the hundreds place. 2 times 100 is 200. And plus, I have a 7 in the tens place. 7 times 10 is 70. And finally, 5 times 1 is just 5. So again, writing this number in expanded notation allows me to see the value of each digit. So this 3 has a value of 300,000. This 5 has a value of 50,000. This 3 has a value of 3,000. This 2 has a value of 200. This 7 has a value of 70. And then this 5 is still just a 5. Okay, for the last one, we want to write 703,271,050,146 in expanded notation. So lucky for us, this number has a lot of zeros. Otherwise, it would take a long time to write it in expanded notation. Now, I'm just going to rewrite this number here. 703,271,050,146. So we're going to start by multiplying the leftmost digit, which is that 7, by its corresponding place value. So it's in the 100 trillions place. 7 times 100 trillion is 700 trillion. So 700 trillion. Then plus. So next I have a 0 in the 10 trillions place. And I can skip that over because we're writing this in expanded notation. So I just move on to the 3 that is in the trillions place. So 3 times a trillion is 3 trillion. So 3 trillion. Then plus. I have a 2 in the 100 billions place. So that's 2 times 100 billion or 200 billion. 200 billion. And plus, I have a 7 in the 10 billions place. 7 times 10 billion is 70 billion. And plus, I have a 1 in the billions place. 1 times a billion is a billion. Then plus, I have a 0 in the 100 millions place, so I don't need to include that. Then I have a 5 in the 10 millions place. 5 times 10 million is 50 million. So 50 million. And then we kind of get a break because we have a 0 in the millions place. We have a 0 in the 100,000s place. We have a 0 in the 10 thousandths place, and a 0 in the thousandths place. So we can kind of skip over all those and just go to the 1 in the hundredths place. 1 times 100 is 100. Plus, we have a 4 in the tens place. 4 times 10 is 40. And then lastly, plus, we have a 6 in the ones place. 6 times 1 is 6. So 703,271,050,146, written in expanded notation, is 700 trillion. And that comes from this 7 here in the 100 trillions place. 7 times 100 trillion is 700 trillion. Plus 3 trillion. 3 trillion. That comes from this 3 here in the trillions place. 3 times a trillion is 3 trillion. Plus 200 billion. That comes from this 2 here in the 100 billions place. So 2 times 100 billion is 200 billion. Then plus 70 billion. That comes from this 7 here in the 10 billions place. 7 times 10 billion is 70 billion. Then plus we have 1 billion. That comes from a 1 in the billions place. 1 times a billion is a billion. Then plus 50 million. That comes from the 5 in the 10 millions place. 5 times 10 million is 50 million. Then we have plus 100. That comes from the 1 in the hundreds place. 1 times 100 is 100. Then plus 40. That comes from the 4 in the tens place. 4 times 10 is 40. Then finally plus 6. That comes from the 6 in the ones place. 6 times 1 is 6. Hello and welcome to Pre-Algebra Test Section 1 on expanded notation. So our problem is to write 75,274 in expanded notation. So let me just kind of label this number real quick. So the 4 is in the ones place. The 7 is in the tens place. The 2 is in the hundreds place. The 5 is in the thousands place. And finally the 7 is in the 10,000s place. So as I taught you in the lesson, to write a number in expanded notation, you form the sum of each digit multiplied by its corresponding place value. So I would start with the leftmost digit, which is this 7 here. So 75,274 is equal to this 7, that's our digit, multiplied by its corresponding place value. So it's in the 10,000s place, so times 10,000. Then plus. Next we have a 5 in the thousands place. So we would have 5 times 1,000. Then plus. Now we have a 2 in the hundreds place. So 2 times 100. Then plus. We have a 7 in the tens place. So 7 times 10. And finally plus 4 times 1. Right? We have a 4 in the ones place. Let's kind of clean this up. 7 times 10,000 is 70,000. Plus 5 times 1,000, that's 5,000. Plus 2 times 100, that's 200. Plus 7 times 10, that's 70. And then finally, plus 4 times 1, that's 4. So 75,274, written in expanded notation, is 70,000 plus 5,000 plus 200 plus 70 plus 4. And again, to kind of think about what this means, we're saying that the value of this digit 7 is 70,000. The value of this digit 5 is 5,000. The value of this digit 2 is 200. The value of this digit 7 is 70. And the value of the digit 4 is 4. Hello and welcome to Pre-Algebra Test Section 2 on expanded notation. So for this problem, we want to write 393,714 in expanded notation. So let me start by just labeling the digits of the number in terms of their place values. So the 4 is in the ones place, the 1 is in the tens place, the 7 is in the hundreds place, the 3 is in the thousands place, the 9 is in the 10,000s place, and then this 3 is in the 100,000s place. So I'm going to write this number, 393,714 is equal to, we're going to write the number in expanded notation. And to do that, we form the sum of each digit multiplied by its corresponding place value. So I'm going to start with the leftmost digit, which is this 3 here, and it's in the 100,000s place. So I would have 3 times 100,000. So 3 times 100,000 is 300,000. So I'm going to write 300,000 here. Then plus, next I have a 9 that is in the 10,000s place. So 9 times 10,000 is 90,000. Then plus, I have a 3 in the thousands place. 3 times 1,000 is 3,000. Then plus, I have a 7 in the hundreds place. 7 times 100 is 700. Then plus, I have a 1 in the tens place. 1 times 10 is 10. And finally, plus 4 in the ones place. 4 times 1 is 4. So 393,714 written in expanded notation is 300,000 plus 90,000 plus 3,000 plus 700 plus 10 plus 4. And again, what we're doing here is we're emphasizing place value. So this 3 here has a value of 300,000. This 9 has a value of 90,000. This 3 has a value of 3,000. This 7 has a value of 700. This 1 has a value of 10. And this 4 has a value of just 4. Hello and welcome to Pre-Algebra Test Section 3 on expanded notation. So our problem is to write 65,301,052 in expanded notation. So let's start by just rewriting the number 65,301,052. Now, to write a number in expanded notation, I form the sum of each digit multiplied by its corresponding place value. So starting at the leftmost digit in this number, the 6 is in the 10 millions place. So if I multiply 6 times 10 million, I would get 60 million. So 60 million. Then if I move to the right, this 5 is in the millions place. 5 times 1 million is 5 million. So plus 5 million. Plus, now I have a 3 in the 100,000s place. 3 times 100,000 is 300,000. And plus, I have a 0 here, so I can just skip that over. I have a 1 in the thousands place. 1 times 1,000 is 1,000. And plus, I have a 0 here, so I can skip that over. Then I have a 5 that's in the tens place. 5 times 10 is 50. And plus, finally I have a 2 in the ones place. 2 times 1 is 2. So my number, 65,301,052, written in expanded notation is 60 million plus 5 million plus 300,000 plus 1,000 plus 50 plus 2. And again, to kind of go through this, the 6 here is 60 million. The 5 here is 5 million. The 3 here is 300,000. The 1 is 1,000. The 5 is 50. And then the 2 is just a 2. Hello and welcome to Pre-Algebra Test Section 4 on expanded notation. So we want to write 71,005,391,204 in expanded notation. Let's start by rewriting this number. 71,005,391,204. So to write a number in expanded notation, we form the sum of each digit multiplied by its corresponding place value. So starting at the leftmost digit, this 7, we just multiply it by its corresponding place value. So the 7 is in the 10 billions place. So 7 times 10 billion is 70 billion. So let's write that. Okay, plus. Next, we have a 1 that's in the billions place. So 1 times 1 billion is 1 billion. Plus, we have a 0 here and a 0 here. So we can skip those when we're writing a number in expanded notation. Then we have a 5. Okay, the 5 is in the millions place. So 5 times 1 million is 5 million. And plus, next we have a 3 in the 100,000s place. 3 times 100,000 is 300,000. And plus, we have a 9 in the 10,000s place. 9 times 10,000 is 90,000. And plus, next we have a 1 in the thousands place. 1 times 1,000 is 1,000. And plus, next we have a 2 in the hundreds place. 2 times 100 is 200. We have a 0, so we can skip over that. Then we have a 4 in the ones place, so plus 4 times 1 or 4. So the number 71,005,391,204 written in expanded notation is 70 billion plus 1 billion plus 5 million plus 300,000 plus 90,000 plus 1,000 plus 200 plus 4. Hello and welcome to Pre-Algebra Test Section 5 on Expanded Notation. So our problem is to write 396,211,595,213 in expanded notation. So let's go ahead and write this number again. 396,211,595,213. Okay, so to write a number in expanded notation, we form the sum of each digit multiplied by its corresponding place value. So we're going to start at the leftmost digit, and that 3 is in the 100 billions place. So we would multiply 3 times 100 billion. That would give us 300 billion. So 300 billion. Then plus. We move to the next digit to the right. We have a 9 in the 10 billions place. 9 times 10 billion is 90 billion. So 90 billion. Then plus. Next we have a 6 in the billions place. So 6 times a billion would be 6 billion. And plus. We have a 2 in the 100 millions place. So 2 times 100 million is 200 million. And plus, we have a 1 in the 10 millions place. So 1 times 10 million is 10 million. And plus, we have a 1 in the millions place. 1 times a million is a million. Then plus, we have a 5 in the 100,000s place. 5 times 100,000 is 500,000. And plus, we have a 9 in the 10,000s place. 9 times 10,000 is 90,000. And plus, we have a 5 in the thousands place. 5 times 1,000 is 5,000. And plus, we have a 2 in the hundreds place. 2 times 100 is 200. And plus, we have a 1 in the tens place. 1 times 10 is 10. Then plus, finally, we have a 3 in the ones place. 3 times 1 is 3. So 396,211,595,213 written in expanded notation is 300 billion plus 90 billion plus 6 billion plus 200 million plus 10 million plus 1 million plus 500,000 plus 90,000 plus 5,000 plus 200 plus 10 plus 3. Hello, and welcome to Pre-Algebra Practice Set 3. In this video, we're going to look at some additional practice problems for the lesson that we did on inequalities and the number line. So for the problems we're going to look at today, we want to replace each question mark with the inequality symbol less than or greater than. So before I start, I just want you to remember from the lesson that the symbol is always going to point to the smaller number. So let's look at our first problem. We have 7 question mark 1. So let's take a look at the number line and see that 7 is here and 1 is here. Now in the lesson I told you that numbers increase moving from left to right. So if a number is to the right of another number, that means it's a larger number. So since 7 lies to the right of 1 on the number line, 7 is a larger number. So if we have 7 question mark 1, we want to point the symbol to the smaller number. This is the smaller number, so we're going to have a greater than symbol, right? A greater than symbol. So it'll be 7 is greater than 1. Again, we're pointing the symbol to the smaller number. Now, if we would have had the reverse, if we would have had 1 on the left and 7 on the right, we'd use a less than. We'd use a less than because the 1 is on the left now, and we point the symbol to the smaller number. Here we have 2 question mark 9. So on my number line, I see that 2 is here and 9 is here. 9 is to the right of 2, so 9 is the larger number. So if we want to point the symbol towards the smaller number, we want to point it towards 2. So that means we're going to use a less than, right? 2 is less than 9. Again, we're pointing the symbol towards the smaller number. And again, if the numbers were reversed to where 9 was on the left and 2 was on the right, then we'd be looking at using a greater than. Again, you're always using the symbol that points towards the smaller number. So in this case, we use the greater than because the symbol would then point to the 2. Okay, now we have 6 question mark 3. And looking at the number line, we have 6 here and we have 3 here. So everybody knows automatically that 6 is a larger number than 3. You have $6, you have more obviously than if you have $3. But again, just proving this point on the number line, 6 is larger than 3 because 6 lies to the right of 3 on the number line. And so when we look at these two numbers, we're going to put a greater than symbol in here because we want the symbol to point to the smaller number, and the smaller number is 3. Okay, here we have 1 question mark 0. So on the number line, we have 1 here and 0 here. So 1 is the larger number because 1 is to the right of 0 on the number line. So we have 1 and 0. And so where are we going to put our symbol? We want to point it to the smaller number. So we're going to point it to the 0. So that means we're going to use a greater than. Okay, we're going to use a greater than. 1 is greater than 0. Okay, we have 5 question mark 6. So here's 5 on the number line and here's 6. And so 6 is the larger number, again, because it lies to the right of 5 on the number line. So 5 and 6 here. We want the symbol to point to the smaller number. So we want the symbol to point towards the 5. So we're going to use a less than. Okay, again, we're pointing the symbol towards the smaller number. So 5 is less than 6. For our final problem, we have 2 question mark 4. So here's 4 on the number line and here's 2. So obviously 4 is greater than 2 because 4 lies to the right of 2 on the number line. And so again, we want the symbol to point to the smaller number. So we're going to point the symbol towards the 2. That means we're going to use a less than. 2 is less than 4. Hello and welcome to Pre-Algebra Test Section 1 on inequalities and the number line. So for the problems we're going to look at today, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 3 question mark 7. So if we look at our number line, we can see 3 is here and 7's here. Now, as I told you in the lesson, numbers increase moving from left to right. So 7 is a larger number than 3 because 7 lies to the right of 3 on the number line. Now, when we talk about putting in the correct inequality symbol between 3 and 7 there, we want a less than here. And the reason we want a less than is because we want the symbol that is going to point to the smaller number. You kind of think about this as it pointing to this 3 here, right? This is the open side and this is the pointy side. So the less than symbol is what we use here because it points to the 3 and the 3 is the smaller number. Here we have 12 question mark 5. So looking at the number line, I have 5 here, but my number line kind of stops putting notches at 9. I mean, it has an arrow here that says that, hey, this continues, but I don't see 12. What I do know is that 12 is to the right of 5 on the number line, so it's a larger number. So in this case, 12 and 5 here, we know 5 is going to be smaller, so we're going to point the symbol to the smaller number, and the smaller number again is 5. So we're going to use a greater than. 12 is greater than 5. Here we have 2 question mark 0. So we have 2 here and 0 here. 2 lies to the right of 0 on the number line. So we know that 2 is greater than 0. Again, we're going to point the symbol towards the smaller number. So we're using a greater than in this case. Here we have 1 question mark 8. So looking at the number line, we have 1 here, we have 8 here. So 8 is the larger number because it lies to the right of 1 on the number line. So we'll have 1 is less than 8, right? We're going to use the symbol that points to the smaller number. Again, the smaller number is 1, and this symbol is pointing towards the 1. Okay, for the final problem, we have 5 question mark 3. And looking at the number line, 5 is here and 3 is here. So 5 is the larger number because 5 lies to the right of 3 on the number line. So So when we think about the symbol we're going to use, we have 5 and 3. We want the symbol to point towards the 3 because it's smaller, so we're going to use a greater than, right? So 5 is greater than 3. Hello and welcome to Pre-Algebra Test Section 2 on inequalities and the number line. So for the problems we're looking at today, we want to replace each question mark with the inequality symbol less than or greater than. Okay, so we're going to start out with 12 question mark 1. So we don't see 12 as one of the notches on our number line. It kind of stops at 9, and then we have this arrow to indicate that it continues forever. But that's okay. We can see that 1 is here, and we know 12 is somewhere to the right of 1 on the number line, so we know 12 is bigger. So if we think about 12 and 1, what symbol would I put in here? Well, again, I have the choice of less than or greater than. I want the symbol that's going to point to the smaller number. So I want the symbol that's going to point to the 1, so it needs to point to the right. So I'm going to use this guy. I'm going to use the greater than symbol. So 12 is greater than 1. Again, we're using the one that points, so that little point right there, to the smaller number. What about 0 question mark 3? Well, here's 0 on the number line, and here's 3. And it's obvious that 3 is bigger because 3 lies to the right of 0 on the number line. So again, when we think about what inequality symbol to use, we want to point the inequality to the smaller number. So we're going to use a less than symbol. 0 is less than 3. See how it's pointing towards the 0. Okay, for the next one, we have 2 question mark 8. And looking at the number line, we can see the position of 2 is here, and the position of 8 is there. So 8 is clearly bigger, right? 8 lies to the right of 2 on the number line. And so when we think about which inequality symbol to use, remember we want to point the symbol towards the smaller number. So we're trying to point it towards the 2, and we're going to use the less than to do that. So 2 is less than 8. Now we have 6 question mark 4, and 6 is here on the number line, and 4 is here. So 6 is clearly bigger, right? Because 6 lies to the right of 4 on the number line. So we have 6 and we have 4. Again, use the symbol that points to the smaller number. So we're pointing towards the 4, so we're going to use the greater than symbol. So 6 is greater than 4. Okay, and so for our last problem, we have 4 question mark 1. So we have 4 here and 1 here. So 4 is bigger, again, because 4 lies to the right of 1 on the number line. So we're going to take 4 and 1 and think about which inequality symbol we're going to use there. Again, point the symbol towards the smaller number. The smaller number is 1, so we're going to use a greater than symbol. 4 is greater than 1. Hello and welcome to Pre-Algebra Test Section 3 on inequalities and the number line. So for the problems we're going to look at, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 2 question mark 11. And looking at our number line, we can see that 2 is here. We don't have a notch for 11, but we know it's somewhere over here. And what we were told in the lesson is that numbers increase moving from left to right. So since 11 is to the right of 2 on the number line, it's a larger number. So when we think about the relationship between 2 and 11, we want to put the inequality symbol that points towards 2, right? Because it's the smaller number. So our choices were to use the less than or the greater than. We're going to use the less than because it points towards the 2. So we would have 2 is less than 11. Okay, for this problem, we have 0 question mark 7. And looking at the number line, we see that 0 is here and 7 is here. So 7 is clearly the larger number because 7 lies to the right of 0 on the number line. And so when we think about 0 and 7, we're going to use a less than symbol here because we want the symbol that points to the smaller number. And in this case, the smaller number is 0. Okay, now we have 7 question mark 0. So we've reversed the position of the numbers from the last problem. So we have the same situation. We have 7 and we have 0. But again, we've reversed the position of the number. So in the first case, we had 0 is less than 7. But that's because the smaller number's on the left. In this case, the smaller number's on the right. We have 7 and we have 0. So again, we're using the symbol that points to the smaller number. So now we want to use the greater than symbol. 7 is greater than 0 because in each case, the symbol points to the 0, the smaller number. Here we have 8 question mark 9. And on the number line, we can see that 8 is here and 9 is here. So 9 lies to the right of 8 on the number line, so it's the larger number. So we have 8 and we have 9. And again, we want to use the symbol that points to the smaller number. So we're going to use the less than symbol because that's going to point towards the 8. So we have 8 is less than 9. Okay, for the final problem, we have 10 question mark 1. And we have 1 on the number line, but we don't have a notch for 10. It's somewhere over here. And we know that 10 is larger than 1. 10 would be, again, somewhere over here. It's to the right of 1 on the number line. And so when we write our problem again, 10 and 1, we know 1 is the smaller number, and we know we want the symbol that points to the 1, so we would use a greater than. Right? 10 is greater than 1. Hello, and welcome to Pre-Algebra Test Section 4 on inequalities and the number line. Okay, so for our problems today, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 6 question mark 12. So let's look at 6 on the number line. That's here. And we don't have a notch for 12, but we know it's over here. Now, what we learned in the lesson was that numbers increase from left to right. So if a number like 12 is to the right of another number like 6 on the number line, we know it's a larger number. So we have 6, and again, we have 12. Now, if we know 6 is the smaller number, we have a choice between using the less than symbol and the greater than symbol. Which one do we want to use? Well, again, as I taught you in the lesson, we want to point the symbol towards the smaller number. So we want to use this less than symbol because that's going to point towards the 6. So we would have 6 is less than 12. And another way you can check it is just read it. 6 is less than 12 and just say, okay, is that true? Well, yes, it is. If I had chose this other symbol and I had said 6 is greater than 12, just reading that, you know that's wrong. 6 is not greater than 12. It's a smaller value. So again, here's our answer. 6 is less than 12. Okay, here we have 3 question mark 1. So we have 3 here on the number line. We have 1 here. So 3 lies to the right of 1 on the number line, so it's the larger number. So we have 3 and we have 1. Again, we want to use the symbol that points to the smaller number. So in this case, we're going to use a greater than, right? Because the symbol is going to point towards the 1, and that is smaller. So we have 3 is greater than 1. Okay, here we have 0 question mark 9. So on the number line, we have the 0 here, and we have 9 here. Okay, so we can see that 9 is the larger number. 9 lies to the right of 0 on the number line. So when we look at the relationship between 0 and 9, which symbol do we want to put in between them? We want to use a less than, because we want to use a symbol that's going to point towards the smaller number, and the smaller number again is 0. So 0 is less than 9. Okay, for the next one we have 14 question mark 10. We're going to do this one without a number line. We all know that 14 is a bigger number than 10. If you had $14 in your pocket, you would have more money than if you just had $10 in your pocket. So if 14 is the larger number, which symbol do I want to use? Well, I want to use the greater than symbol, right? Because remember, I want to point the symbol towards the smaller number. And the greater than symbol does that. So 14 is greater than 10. Okay, for the last one, we have 12 question mark 4. And we should all know that 12 is a larger number than 4. And so if we look at 12 and we look at 4, which symbol are we going to use? We're going to, again, use a greater than symbol because the 4 is smaller, and we want the symbol that points towards the smaller number. So we would have 12 is greater than 4. Hello, and welcome to Pre-Algebra Test Section 5 on inequalities and the number line. So for the problems we're going to look at, we want to replace each question mark with the inequality symbol less than or greater than. So we're going to start out with 3 question mark 8. And if we look at the number line, we have 3 here and 8 here. And what I taught you in the lesson is that numbers increase moving from left to right. So 8 is to the right of 3 on the number line, so that tells us it's a larger number. So if we have 3 and we have 8, 3 is going to be the smaller number, 8 is going to be the larger number. Now, we want to put an inequality symbol between them that represents the relationship. The choices we had were the less than or the greater than. Now, what I told you in the lesson is you always want to use the symbol that points to the smaller number. So in this case, we're going to use this symbol, which is the less than symbol, because it's going to point to 3, the smaller number. So we would have 3 is less than 8. So now we have 13 question mark 11. We don't have a number line, but most of you will know that 13 is the larger number. So if we have 13 and we have 11, we want the symbol that points to the smaller number. And the smaller number is 11, so we're going to use a greater than in this case, because the greater than symbol will point to the 11. So we'd have 13 is greater than 11. Next we have 17 question mark 82. So 17 is the smaller number in this case. 82 is the larger number. So we want the symbol that's going to point towards the 17, and that's going to be the less than symbol. Right? We'd have 17 is less than 82. We have 100 question mark 150. 100 in this case is the smaller number. 150 is the larger number. So which symbol do we want to use? Well, we want to use the less than symbol because, again, we want the symbol that points to the smaller number. The smaller number is 100. So we would have 100 is less than 150. And for our last problem, we have 30,000 question mark 10,570. So 30,000 is the larger number. 10,570 is the smaller number. So we want to use the inequality symbol again that's going to point towards 10,570 because it's smaller. So if we do that, we're going to be using a greater than symbol. So we'd have 30,000 is greater than 10,570. Hello, and welcome to Pre-Algebra Practice Set number 4. And in this video, we're going to look at some additional problems for the lesson that we did on rounding whole numbers. Okay, for the first problem, we want to round 227 to the nearest 10 and the nearest 100. So let's start out with rounding it to the nearest 10. So we have our number 227. The very first step is to locate the digit in the round-off place. So if we're rounding to the nearest 10, we want the digit in the tens place. So that's going to be this 2 right here. Now, the next step is to locate the digit to the right of the round-off place. So that's this 7 right here. And then basically you're looking to see which category it falls into. You have 2. You have where the digit is 4 or less, and then you have where the digit is 5 or larger. The 7 is in the category of 5 or larger. And when this happens, you increase the digit in the round-off place by 1. So this 2 is a digit in the round-off place, so we're going to increase it by 1, so it will become a 3. So you will have this 2 right here will stay the same. Then, as I just said, this 2 will increase by 1 and become a 3. And then for the final step, you replace each digit to the right of the round-off place with a 0. So all we have in this case is a 7 that's to the right of the round-off place. So we just change that to a 0, and we get our answer, which is 230. So 227 rounded to the nearest 10 is 230. Okay, so now let's round 227 to the nearest 100. Okay, to the nearest 100. All right, so again, 227 is the number. But now we're looking at the hundreds place. So we're looking at that 2 there. And then what we want to do is we want to look to the digit to the right of the hundreds place. So we want to look at this 2 here. And in this case, the 2 falls in the category of 4 or less. And when this happens, we leave the digit in the round-off place unchanged. So this 2 will be unchanged. Then for the final step, we replace each digit to the right of the round-off place with a 0. So what we're going to have, the 2 is going to be unchanged. And then the 2 and the 7 here are each to the right of the round-off place. So we're going to change those each into a 0. So the 2 will become a 0, and the 7 will become a 0. And so we get our answer of 200. So 227 rounded to the nearest 100 is 200. Okay, for the next problem, we want to round 65,377 to the nearest 100 and nearest 1,000. So we'll start with this nearest 100. So 65,377. Let's find the hundreds place, and that's going to be right here. And then we're going to look at the digit immediately to the right. So that's going to be this 7 here. And that falls into the category of 5 or larger. And when this happens, we increase the digit in the round off place by 1. So we'll have this 6 and this 5. That's going to stay the same. The 3 increases by 1 and becomes a 4. And then for the final step, we'll replace each digit to the right of the round off place with a 0. So this 7 becomes a 0 and this 7 becomes a 0. Those are both to the right of the hundreds place, which was the round off place. So 65,377 rounded to the nearest hundred is 65,400. Okay, let's talk about rounding it to the nearest 1,000. And I'm just going to erase this real quick. Okay, so now we're going to the nearest 1,000. And so the thousandths place is this 5 here. And we want to look at the digit immediately to the right of that. So we're looking at the 3. And 3 falls in the category of 4 or less. So this is going to be unchanged. It's going to be unchanged. And then basically all we're going to do is change everything that follows. So the 3, the 7, and the 7 into a 0. So we will end up with the 6 stays the same. The 5 stays the same. The 3 will become a 0. The 7 becomes a 0. And the 7 becomes a 0. So 65,377 rounded to the nearest 1,000 is 65,000. Okay, now we want to round 10,155,010 to the nearest 1,000 and million. So let's start out by rounding it to the nearest 1,000. The nearest 1,000. So 10,155,010. And where's the thousands place? Well, that's going to be right here. So we're looking at the digit immediately to the right, and that's this 0 here. 0 falls in the category of 4 or less. So that means we leave our digit in the round off place unchanged. Unchanged. So all this stuff to the left of the round off place, we don't have to touch that. So we just copy that. The 5 is unchanged. And then everything that follows will be a 0. So this is already a 0. This 1 will be a 0. And this 0 is already a 0. So 10,155,010 rounded to the nearest 1,000 is just 10,155,000. Okay, let's erase this. We'll look at the other scenario, which is to round it to the nearest million. So where's the millions place? That's going to be right here. So we're looking at that 0 there. Now, we look at the digit that follows the 0, and that's this 1. And 1 again falls in the category of 4 or less. So that means that we leave the digit in the round off place unchanged. And then every digit that follows, we're going to replace with a 0. So this 1 is going to stay the same. The 0 stays the same. And then everything after that's just going to be a 0. So 0, 0, 0, comma, 0, 0, 0. And so 10,155,010 rounded to the nearest million is 10 million. Okay, now we want to round 7,815,319,215 to the nearest billion. So the billions place on this guy is right here. Let me just rewrite the number. It'd be 7,815,319,215. And again, the billions place is right here. And we want to look at the digit that follows that. So we're looking at this 8 here. And that falls in the category of 5 or larger. So when this occurs, we add 1 to the digit in the round off place. So this will be plus 1. And then again, the next step is to replace each digit that follows the round off place with a 0. So all these digits will be a 0. So let's go ahead and write this. The 7, we increase by 1 and it becomes 8. And then all this is going to be 0. So 0, 0, 0, 0, 0, 0, 0, 0, 0. And so 7,815,319,215 rounded to the nearest billion is 8 billion. For the final problem, we want to round 18,375,015,927 to the nearest 100 billion. Okay, so let's just rewrite that. 18,375,015,927. So we're looking for the digit in the 100 billions place. So that's going to be right here. The 3 is in the 100 billions place. Now, looking at the digit to the right of that, we have a 7. And again, that falls in the category of 5 or larger. So that means that we're going to increase the digit in the round off place by 1. Okay, so everything to the left of it is just the same. So we have the 1, then the 8, and then 3 plus 1 would give me 4. And then I'm replacing everything that follows the round off place with a 0. So 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 18,375,015,927 rounded to the nearest 100 billion is 18,400,000,000,000. Hello, and welcome to Pre-Algebra Test Section 1 on rounding whole numbers. So for the first problem we're going to look at, we want to round 15,375 to the nearest 10, 100, and 1,000. So we're going to begin by rounding this number to the nearest 10. So we have 15,375. And to round to the nearest 10, we're looking for the digit in the tens place. So that's going to be this 7 here. And then the next thing we want to do is locate the digit to the right of that. So we're looking at this 5 here. Now, when you have the scenario where the digit is 5 or larger, you want to increase the digit in the round off place by 1. So this will increase by 1. So all this to the left of the 7 is the same. The 1, the 5, and the 3. We don't need to change that. We increase the 7 by 1. That becomes 8. And then the final step is to replace each digit to the right of the round off place with a 0. So this number will be 15,380. So that's the answer to round 15,375 to the nearest 10. Again, it's 15,380. Okay, let's look at the next scenario, which is to round the number to the nearest 100. So 15,375. And where's the hundreds place at? That's right here. That's this 3. So now what I want to do is I want to look at the digit immediately to the right of that 3, and that's this 7. 7, again, falls in the category of 5 or greater. So we're going to increase the digit in the round off place by 1. And so the 1 and the 5 will stay the same. The 3 will increase by 1 and become 4. And then we want to replace each digit to the right of the round off place with a 0. So the 7 becomes a 0, the 5 becomes a 0. So 15,375 rounded to the nearest 100 is 15,400. Okay, let's erase these and get some room going. And so for the final scenario, we want to round to the nearest 1,000. So 15,375. Where's the thousands place at? That's going to be right here. So let's look at the digit immediately to the right of that. That's this 3. Now the 3 falls in the category of 4 or less. So when this happens, we leave the digit in the round off place unchanged. So unchanged. So we'll have the 1 and the 5 that stay the same. Now, we want to replace each digit to the right of the round off place with a 0. So the 3, the 7, and the 5. So there's our answer. 15,375 rounded to the nearest 1,000 is 15,000. Okay, now we want to round 373,575, again, to the nearest 10, 100, and 1,000. So let's rewrite this number. 373,575. And again, we'll start out by rounding to the nearest 10. So the tens place is right here. That's that 7. And so if I look at the digit immediately to the right of that, I have a 5. And so when the digit is a 5 or greater, we want to increase the digit in the round off place by 1. So this is going to be a plus 1 here. And so we'll start by just rewriting the 3, the 7, the 3, the 5. And then 7 plus 1 would give me 8. And then as the final step, I replace each digit to the right of the round off place with a 0. So that means I just replace that 5 with a 0. So 373,575 rounded to the nearest 10 is 373,580. Now let's look at the second scenario, which is to round it to the nearest 100. So the hundreds place, if we look, is right here. And then we're looking at the digit immediately to the right of that, and that's this 7. Again, that falls in the category of 5 or greater. So we're going to add 1 to the digit in the round off place. So all this will be the same. The 3, the 7, and the 3. We add 1 to the 5 and we get 6. And then finally we replace each digit to the right of the round off place with a 0. So the 7 and the 5, we'll replace those each with a 0. So it's 373,575 rounded to the nearest hundred is 373,600. Okay, for the last scenario, we want to round to the nearest 1,000. So where's the thousands place here? Well, that's going to be this 3. And we're looking for the digit immediately to the right of that, and we have this 5 here. And again, 5 falls in the category of 5 or larger, so this is going to be plus 1 here. Right? We want to add 1 to the digit in the round off place. So this 3 and this 7 will be the same. We're going to add 1 to the 3 to get 4. And then we'll replace each digit that follows the 3 with a digit in the round off place with a 0. So the 5 becomes a 0, the 7 becomes a 0, and lastly the 5 becomes a 0. And so our answer for 373,575 rounded to the nearest 1,000 is 374,000. Okay, for the final problem, we want to round 21,583, again to the nearest 10, 100, and 1,000. So let's begin by rounding to the nearest 10. And so I'm just going to rewrite this number here, 21,583. So where's the tens place? That's right here. And now I'm looking at the digit that follows. So that's this 3 here. That falls in the category of 4 or less. And when that happens, we leave the digit in the round off place unchanged. Okay, unchanged. So we have the 2, the 1, the 5, and the 8 that are all going to stay the same. And then as the final step, we replace each digit to the right of the round off place with a 0. So that means this 3 becomes a 0. And we get 21,580. So 21,583 rounded to the nearest 10, again, is 21,580. Okay, now let's look at rounding to the nearest 100. And so if we round 21,583 to the nearest 100, we would start by finding the digit in the hundreds place. So that's this 5 here. And then the digit that follows is this 8. 8 obviously falls in the category of 5 or larger. So we're going to increase the digit in the round off place by 1. And so we would have 2, 1, comma, 5 plus 1 would be 6. And then again, we replace each digit that follows the digit in the round off place with a 0. So that becomes a 0, and then that becomes a 0. And 21,583 rounded to the nearest 100 is 21,600. Okay, lastly, let's round to the nearest 1,000. So where's the thousands place at? That's going to be right here. And the digit that follows is going to be this 5 here. So again, that falls in the category of 5 or greater. So that means we increase the digit in the round off place by 1. So this 2 will be the same. 1 plus 1 will give me 2. And then every digit that follows the digit in the round off place, so every digit that follows that 1, we're going to change into a 0. So the 5 becomes a 0, the 8 becomes a 0, and the 3 becomes a 0. So 21,583 rounded to the nearest 1,000 is 22,000. Hello and welcome to Pre-Algebra Test Section 2 on rounding whole numbers. So for the first problem, we want to round 5,273,371 to the nearest 1,000 and 10,000. So let's start out by rounding to the nearest 1,000. And we'll just rewrite this number here. 5,273,371. And the nearest 1,000 means that we're looking for the digit in the thousands place, which is right here. It's that 3. Now, we're looking to the digit immediately to the right of that, and that's a 3 as well. And that 3 falls in the category of 4 or less. So when the digit to the right of the digit in the round off place falls in the category of 4 or less, what you want to do is leave the digit in the round off place unchanged. So this will be unchanged. And so let's rewrite this. Those are all the same. The 3 is going to be the same. And then we're going to replace each digit that follows the digit in the round off place with a 0. So in other words, after this 3, we're going to replace this with a 0, this with a 0, and then this with a 0. And so 5,273,371 rounded to the nearest thousand is 5,273,000. Okay, now let's talk about rounding this number to the nearest 10,000. So all we're doing is we're going one digit to the left. Now we're looking at this 7 here. That's our digit in the 10,000s place. And when we look to the digit to the right of that, we have this 3 here. So again, the 3 is in the category of 4 or less. And when this happens, we leave our digit in the round off place unchanged. So this will be unchanged. So the 5, the 2, and the 7 will be unchanged. So 5, 2, then 7. Now, each digit that follows your digit in the round off place, which is the 7, we're going to change that into a 0. So this 3 will be a 0. Then this 3 will be a 0. Then the 7, and then the 1. So 5,273,371 rounded to the nearest 10,000 is 5,270,000. For the next one, we want to round 65,315 to the nearest 1,000 and 10,000. So we'll start with rounding to the nearest 1,000. So again, we have 65,315. And the thousands place is going to be right here. So we're looking for the digit immediately to the right of that. And again, we have a 3. And 3 falls in the category of 4 or less. So this 5 is going to be unchanged. Unchanged. So the 6 and the 5 are both going to stay the same. And then we're going to replace each digit that follows that 5, the digit in the round off place, with a 0. So 0, 0, 0. So 65,315 rounded to the nearest 1,000 is 65,000. Okay, next let's look at rounding this to the nearest 10,000. So the 10,000s place is going to be right here. So that's going to be that 6 there. And we want to look at the digit to the right of that. So that's going to be this 5 here. So that falls in the category of 5 or greater. So that means we're going to add 1 to the digit in the round off place. So we're adding 1 to the 6. So that's going to become 7. Now, each digit that follows that 6, again, the digit in the round off place, is going to be changed to a 0. So the 5, the 3, the 1, and the 5. So 65,315 rounded to the nearest 10,000 is 70,000. Okay, for the last one, we want to round 26,300, again, to the nearest 1,000 and 10,000. So we're going to begin by rounding to the nearest 1,000. So 26,300. And where's the thousands place? That's going to be right here. And the digit that follows, again, is a 3. And that falls in the category of 4 or less. So we're going to leave this digit unchanged. Unchanged. So the 2 and the 6 will be the same. And then we're going to replace everything that follows the 6, again, the digit in the round off place, with a 0. So the 3, we're going to change that to a 0. And then these are already 0, so we're just going to copy those. So we end up with 26,000 for the answer. And again, it's 26,300 rounded to the nearest 1,000, and that gives us 26,000. Okay, now let's round to the nearest 10,000. And so the 10,000s place is right here. So we're looking at that 2 for the 10,000s place. We go one digit to the right, and we have this 6 here. And the 6 falls in the category of 5 or greater. So again, when this happens, we add 1 to the digit in the round off place. So that 2 will become a 3. And then we'll replace every digit that follows with a 0. So the 6 becomes a 0, the 3 becomes a 0, and then these are already zeros. So we end up with 30,000 as our answer. And again, for rounding 26,300 to the nearest 10,000. Hello and welcome to Pre-Algebra Test Section 3 on rounding whole numbers. For the first problem, we want to round 6,375,322 to the nearest million. So let's rewrite this number, 6,375,322, and we're looking for the millions place, right? We're rounding to the nearest million. So that's going to be this 6 right here, and then we're looking to the digit immediately to the right of that, and that's this 3 here. 3 falls in the category of 4 or less. So when this happens, you want to leave your digit in the round off place unchanged. So this will be unchanged. So this will just be a 6. And then you're going to replace every digit that follows the digit in the round off place with a 0. So essentially 0, 0, 0, comma 0, 0, 0. So 6,375,322 rounded to the nearest million is 6 million. Okay, for the next problem, we want to round 17,955,971 to the nearest million. So let's rewrite that. 17,955,971. And again, we're rounding to the nearest million. So we're looking for the digit in the millions place, and that's going to be this 7 here. So if we look at the digit immediately to the right of that, we have a 9. And when we have a digit like 9, it falls in the category of 5 or greater, and that tells us to add 1 to the digit in the round off place. So this 1 will be the same. 7 plus 1 is 8. And then we're going to replace every digit that follows that digit in the round off place, the 7, with a 0. So this will be a 0, a 0, a 0, comma. We have another 0, and lastly, another 0. So 17,955,971 rounded to the nearest million is 18 million. Okay, for the last problem, we want to round 19,100,571 to the nearest million. So 19,100,571, and again, we're rounding to the nearest million. So that's going to be right here. That 9 is in the millions place. And so we're looking at the digit immediately to the right, and that's a 1. And the 1 falls again in the category of 4 or less. When that happens, we leave our digit in the round off place unchanged. And so the 1 and the 9 will stay the same. And then every digit that follows that 9, again, the digit in the round off place, we're just going to turn that into a 0. So the 1 becomes a 0. These two are already zeros. And then the 5, the 7, and the 1 will make those each into a 0. So 19,100,571 rounded to the nearest million is 19 million. Hello and welcome to Pre-Algebra Test Section 4 on rounding whole numbers. So for the first problem today, we'd like to round 163,517,325,317 to the nearest billion. Okay, so to the nearest billion. Let's just rewrite this number. So again, 163,517,325,317. So where's the billions place at here? Well, it's going to be right here. It's going to be this 3. And we want to look at the digit that follows the digit in the round off place. So that's going to be this 5 here. And then the 5 falls into the category of 5 or greater. And so what we do is we add 1 to the digit in the round off place. So the 1 and the 6 will stay the same. 3 plus 1 gives me 4. And then as the final step, we want to replace each digit to the right of the round off place with a 0. So everything to the right of a 3 is going to be a 0. So 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 163,517,325,317 rounded to the nearest billion is 164 billion. Okay, now we want to round 224,978,381,500 to the nearest billion. Okay, so again, to the nearest billion. All right, let's just rewrite this number here. So again, we have 224,978,381,500. So where's the billions place? It's going to be right here. Then we want to look at the digit that follows that. So that's going to be this 9. And the 9 falls in the category of 5 or greater. So that means we add 1 to the digit in the round off place. So this 2 and this 2 will stay the same. 4 plus 1 gives me 5. And then we replace everything to the right of the 4, the digit in the round off place, with a 0. So we'll have 0, 0, 0, 0, 0, 0, 0, 0, 0. So 224,978,381,500 rounded to the nearest billion is 225 billion. Okay, for the final problem, we have 6,536,179, and we want to round this to the nearest billion. Okay, again, rounding to the nearest billion. So 6,536,179. So the billions place is here. It's this 0. And the digit to the right of that is a 0 as well. So that falls in the category of 4 or less. And when this happens, we leave the digit in the round off place unchanged. So unchanged. So what's going to happen is this 6 is going to stay the same. Then these 3 zeros will be the same. And then everything to the right of this 0 here in the billions place, we're going to change into a 0 if it's not already a 0. So we'll have 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 6,536,179 rounded to the nearest billion is 6 trillion. Hello and welcome to Pre-Algebra Test Section 5 on rounding whole numbers. So for the first problem, we want to round 169,315,111,827,059 to the nearest 10 trillions. So 10 trillions. Let's just rewrite this number. 169 trillion, 315 billion, 111 million, 827,059. So the 10 trillions place is going to be right here. That's this 6. So if we look at the digit that follows, that's this 9. 9 falls in the category of 5 or greater. So that means we're going to add 1 to the digit in the round off place. So that 6 is going to become a 7. So this 1 is going to be unchanged. Again, the 6 becomes a 7. And then everything to the right of the 6, we're going to replace with a 0. So then we'll just have 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 169 trillion, 315 billion, 111 million, 827,059 rounded to the nearest 10 trillions is 170 trillion. Okay, next we want to round 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192 to the nearest 10 trillions. So let's rewrite this. 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192. So the 10 trillions place is going to be right here. It's going to be that 7. And if we look at the digit that follows, it's going to be this 8 here. So that falls in the category of 5 or greater. So we're going to add 1 to the digit in the round off place. So this 5, this 9 will stay the same. The 7 plus 1 will give us 8. And then everything that follows the 7, again, the digit in the round off place, we're going to change into a 0. So this will be a 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192 rounded to the nearest 10 trillions is 5 quadrillion, 980 trillion. Hello and welcome to Pre-Algebra Practice Set number 5. In this video, we're going to look at some additional practice problems for the lesson that we did on properties of addition. So for the first set of problems we're going to look at, we want to use the commutative property to rewrite each sum. So the commutative property of addition tells us that we can add in any order without changing the sum. So starting with 2 plus 9, I could rewrite this as 9 plus 2. Because in this case, 2 is first and 9 is last, if we think about the order of the add-ins. And when I say add-ins, I mean the numbers that are being added together. The commutative property, again, tells us that we can switch that around and still get the same result. So instead of 2 being first, now 9 is first and 2 is last. So 2 plus 9 gives us the same result as 9 plus 2. In each case, you get 11. 2 plus 9 equals 11. 9 plus 2 equals 11 as well. Okay, for another one, we have 7 plus 15. So to rewrite this, we would just switch the order, and we would put 15 plus 7. And in each case, you'd be looking at 22, right? 7 plus 15 equals 22. And 15 plus 7 equals 22 as well. Again, the order does not change the sum. Now we have 12 plus 3. Again, just change the order around. So we're going to write this as 3 plus 12. So 12 plus 3 equals what? Equals 15. And 3 plus 12 equals 15 as well. Okay, we'll look at 2 more. So we have 6 plus 2. So again, change the order around. We'll make that 2 plus 6. And in each case, that's 8, right? 6 plus 2 equals 8. And 2 plus 6 equals 8 as well. Okay, for the final one, we have 8 plus 5. And again, we're just going to switch the order around. So we'll write this as 5 plus 8. And again, it's the same answer either way. 8 plus 5 is 13. And 5 plus 8 is 13 as well. Okay, now for the next set of problems, we want to use the associative property to rewrite each sum. So the associative property of addition tells us that the addition of 3 or more numbers can be grouped in any order without changing the sum. So for example, here we have 3 plus 5 plus 2. Now notice how we have 3 plus 5 inside of parentheses. So we could refer to this as the quantity 3 plus 5. We could rewrite this as 3 plus 5 plus 2, where we put parentheses around 5 plus 2 now. So we'd have 3 plus the quantity 5 plus 2. Notice how the numbers that we're adding are the same, 3 plus 5 plus 2. All we did was we just changed what we had parentheses around. So in this case, we have parentheses around 3 plus 5. Here we have parentheses around 5 plus 2. And as I told you in a lesson, we haven't gotten to the order of operations yet, but essentially, when you have parentheses, you want to do what's inside of the parentheses first. So if we were to evaluate each side, we think about what's on the left. 3 plus 5 would be done first because it's inside of parentheses. So that would give us 8. So you'd have 8 plus 2. That would give you 10. So essentially, the left side would be 10. If we look at the right side, we do 5 plus 2 first because that's what's in parentheses now. 5 plus 2 is 7. So we'd have 3 plus 7, and that equals 10 as well. So either way you do it, you're going to get the result of 10. And that's, again, what the associative property of addition is telling us. Okay, for the next problem, we have 9 plus 7 inside of parentheses. So we'll go ahead and just say that's the quantity 9 plus 7, then plus 8. Okay, so the quantity 9 plus 7 plus 8. So we want to use the associative property of addition to rewrite this. So it's going to be the same numbers. So 9 plus 7 plus 8. We're just going to change what we have parentheses around. So here we have parentheses around 9 plus 7. Here we'll put parentheses around 7 plus 8. And so we rewrite it. But the sum is going to be the same either way. So 9 plus 7 would be done first here on the left because it's inside of parentheses. That's 16. Then 16 plus 8 is 24. Over here on the right, 7 plus 8 would be done first because now that's what's inside of parentheses. 7 plus 8 is 15. And then we'd add 9 to that. 15 plus 9 is, again, 24. So again, another example where we changed what we had parentheses around, but it didn't matter. We're adding the same 3 numbers, and that's what the associative property of addition is telling us. Okay, for the next example, we have 6 plus the quantity 1 plus 4. And again, parentheses around 1 plus 4 there. So we're going to rewrite this using the associative property. Basically just going to put parentheses around different numbers. So we'll write 6 plus 1 plus 4. Those are the 3 numbers that are being added together. I'm just, again, going to change what I have parentheses around. So now we're going to put parentheses around 6 plus 1. Let me just highlight that. And to prove that you get the same result, on the left I do 1 plus 4 first because that's what's inside of parentheses. 1 plus 4 is 5. So we'd have 6 plus 5, that's 11. On the right, we do 6 plus 1 first because that's what's inside of parentheses. 6 plus 1 would give me 7. Then 7 plus 4, again, would give me 11. So we're getting the same answer. Okay, here we have the quantity 3 plus 5, then plus 3. So again, parentheses are around 3 plus 5. And to rewrite this using the associative property, we're going to use the same numbers. So 3 plus 5 plus 3. We're just going to change where we have our parentheses. So now I'm going to put parentheses around 5 plus 3. And again, just to prove to you that you get the same result, 3 plus 5 on the left would be done first because that's what's inside of parentheses. 3 plus 5 is 8. Then we'd add 3 to that. 8 plus 3 is 11. On the right, we'd do 5 plus 3 first. 5 plus 3 is 8. 8 plus 3 again is 11. Now we have 6 plus the quantity, 2 plus 13. And 2 plus 13 here is inside of parentheses. So let's rewrite this as 6 plus 2 plus 13, where we put parentheses around 6 plus 2 now. So the quantity 6 plus 2 plus 13. And again, just changing what we have parentheses around. The numbers that we're adding are still the same. We're still adding 6, 2, and 13 together. That doesn't change. Just changing what we put parentheses around. And again, to prove that we get the same result either way, on the left, we'd start with 2 plus 13. That's what's inside of parentheses. 2 plus 13 is 15. And then we'd add 6 to that. 15 plus 6 is 21. Over here on the right, 6 plus 2 is 8. And then 8 plus 13 is 21 as well. Okay, now we want to find each sum. So the problems we're going to look at here deal with the identity property of 0. And the identity property of 0 just tells you that you can add 0 to a number and the number stays unchanged. So in this example, we have 3 plus 0 equals what? Again, we're adding 0 to 3. 3 is not going to change. So 3 plus 0 equals 3. Here we have 1,759,373 plus 0. It doesn't matter that I used a relatively large number. Adding 0 to a number doesn't change it. So I'm just going to use this number as the result. 1,759,373. Okay, so for the last one here, we have 0 plus 12,335,988,642. So it doesn't matter how big the number is, because it's a relatively large number. The rule for adding 0 to a number holds for all real numbers. So we would just get this number back. So the answer would be 12,335,988,642. Okay, for the last set of problems we're going to look at, we want to identify the parts of each addition problem. And essentially, we want to label each as either an add-in or a sum. So the add-ins are the numbers that are being added together. So being combined together through the addition process. The sum is the result. So when we look at 3 plus 6 equals 9, when we want to label the parts of the addition problem, the numbers being added together, those are the add-ins. So these are the add-ins. The result of the addition is the sum. So 9 is the sum. It's the result when we add 3 and 6 together. Okay, here we have 9 plus 8 plus 15 plus 12 equals 44. So the numbers being added together, the 9, the 8, the 15, and the 12, those are the add-ins. And then the 44, which is the result of the addition, is the sum. Okay, final problem. We have 0 plus 5 plus 2 plus 8 equals 15. Again, the numbers being added together, 0, 5, 2, and 8, these are the add-ins. And then the result of the addition, 15, is the sum. Hello, and welcome to Pre-Algebra Test Section 1 on Properties of Addition. So for the problems we're going to look at today, we want to rewrite each using the commutative property. So the commutative property of addition tells us that we can add in any order that we want, and it's not going to change the sum. So let's take a look at the first part. We have 1 plus 7. So essentially, to rewrite this using the commutative property, we just change the order of the add-ins. And again, the numbers being added together, those are called add-ins. So instead of 1 plus 7, we'll just have 7 plus 1. Again, all I did was I just switched the order. And you can see that the result will be the same either way. 1 plus 7 is equal to 8, and 7 plus 1 is equal to 8 as well. For the next one, we have 2 plus 4. Again, all we're doing is we're just changing the order. So we'll write this as 4 plus 2. And we know that 2 plus 4 equals 6. And we know that 4 plus 2 equals 6 as well. Okay, next we have 6 plus 15. So we're going to rewrite this as 15 plus 6. Again, just switching the order. And 6 plus 15 is 21. And so is 15 plus 6. Right? Changing the order does not change the sum. So one final problem. We have 13 plus 12. And we're just going to change the order of the add-ins. So we're just going to put 12 first, then plus 13. And again, it's the same result either way. 13 plus 12 equals 25. And 12 plus 13 equals 25 as well. Hello and welcome to Pre-Algebra Test Section 2 on Properties of Addition. So for the problems we're going to look at, we're going to rewrite each using the commutative property. So the commutative property of addition, again, tells us that we can add in any order that we want, and we're not going to change the sum. So we start with 21 plus 1. When you get a problem like this, all you want to do is just change the order of what we call the add-ins. The numbers being added together are called add-ins. So we're going to change the order. Instead of 21 being first, we're going to make it last. And we're going to put 1 first. So we're going to put 1 plus 21. So we switch the order of the addition, but the sum is not going to change. The result from the addition is the same. So 21 plus 1 equals 22. 1 plus 21 equals 22 as well. What about 13 plus 9? Again, just switch the order. So this will be 9 plus 13. And again, just to prove to you that the commutative property of addition works, 13 plus 9 is 22, and 9 plus 13 is 22 as well. Okay, now we have 51 plus 7. And again, to rewrite this using the commutative property, just switch the order. So we'll have 7 plus 51. And 51 plus 7 equals 58. And 7 plus 51 equals 58 as well. Okay, final problem, we have 103 plus 2. Again, we can rewrite this using the commutative property by switching the order. So we'll put 2 plus 103. And 103 plus 2 equals 105. And it's the same when we switch the order. 2 plus 103 equals 105 as well. Hello and welcome to Pre-Algebra Test Section 3 on Properties of Addition. So what we want to do for these problems, we want to identify the parts of each addition problem. So when we look at an addition problem, you have two parts. You have the add-ins, and the add-ins are the numbers that are being added together. And then you have the sum, which is the result from the addition. So let's take a look at the first one. So we're going to begin with 9 plus 4 equals 13. So we're going to label the 9 and the 4 as the add-ins. Okay, the add-ins. These are the numbers that are being combined together through addition. The result of 9 plus 4 is 13. So 13 is your sum. Okay, 13 is the sum. Next we have 12 plus 10 equals 22. So again, the numbers being added together, the 12 and the 10, those are the add-ins. So these are the add-ins. And the result of the addition, 12 plus 10, is 22. 22 is your sum. Okay, now we have 5 plus 4 plus 11 plus 3 equals 23. So the numbers being added together, the 5, the 4, the 11, and the 3, those are the add-ins. So these are the add-ins. And then 23 is the result of the addition. This is the sum. Okay, for the next set of problems, we're asked to find each sum. And these problems deal with the identity property of 0, which tells us we can add 0 to any number, and the number will remain unchanged. So let's take a look at what we have. We have 37 plus 0, and of course that's just going to be 37. Adding 0 to 37 doesn't change it, so you just get 37. Here you have 0 plus 962. That's just going to be 962. Again, adding 0 does not change the number. Okay, for the last one, we have 1,362,373 plus 0. And again, adding 0 to a number does not change it, so you get 362,373 as the answer. Hello and welcome to Pre-Algebra Test Section 4 on Properties of Addition. So for these problems, we want to rewrite each using the associative property. So the associative property of addition tells us that when we're adding 3 or more numbers, we can group this addition any way that we'd like, and we're not going to change the sum. So let's take a look at the first one here. And we have 3 plus 1 plus 5. Notice how 3 plus 1 is inside of parentheses. So we're just going to go ahead and say that this is the quantity 3 plus 1, then plus 5. So how would we rewrite this using the associative property? Well, we're going to use the same 3 numbers. So 3 plus 1 plus 5. We're just going to put parentheses around different numbers. So instead of there being parentheses around 3 plus 1, we're going to put parentheses around 1 plus 5. And just to test out that the associative property is true, let's go ahead and evaluate each side and see what we get. Now, we do whatever is inside of parentheses first. So on this side, we do 3 plus 1 first. So 3 plus 1 would give me 4, and then I'd have plus 5, and 4 plus 5 would give me 9. On the right side, what we have inside of parentheses is 1 plus 5. So we're going to do that first. 1 plus 5 is 6, so we would have 3 plus 6. That gives me 9 as well. So either way we get 9, even though we put 3 plus 1 here in parentheses, and we put 1 plus 5 over here in parentheses, it didn't matter. And that's exactly what the associative property of addition tells us. Okay, for the next problem, we have 17 plus the quantity 11 plus 2. And again, I said the quantity 11 plus 2 because it's inside of parentheses. So we're going to rewrite this using the associative property. Again, using the same 3 numbers. So 17 plus 11 plus 2. I'm just going to change what I have parentheses around. Here I have parentheses around 11 plus 2. Here I'm going to put parentheses around 17 plus 11. But again, I get the same result either way. On the left, if I do 11 plus 2 first, I get 13. Then I add that to 17, I'm going to get 30. On the right, what's in parentheses is 17 plus 11. 17 plus 11 is 28. Then if I add 28 and 2 together, I get 30 as well. So again, it doesn't matter that we have parentheses around different numbers. We get the same result. Okay, last problem. We have the quantity 9 plus 2, then plus 1. So the quantity 9 plus 2, and again, I'm saying it that way because 9 plus 2 is inside of parentheses. And to rewrite this using the associative property, again, use the same 3 numbers. So 9 plus 2 plus 1. I'm just going to shift what I have parentheses around. So instead of it being around 9 plus 2, I'm going to put it around 2 plus 1. And again, we're going to get the same result. On this side, I do 9 plus 2 first because that's in parentheses. 9 plus 2 is 11. Then I add 1 to that, so I'd get 12. On this side, I'd do 2 plus 1 first. 2 plus 1 is 3. And then I'd add that to 9. 9 plus 3 is 12. So either way, I get 12. And again, this is what the associative property of addition is telling us. It doesn't matter what we're putting parentheses around. When we're just simply adding, you're going to get the same result either way. Hello and welcome to Pre-Algebra Test Section 5 on Properties of Addition. So for these problems, we want to rewrite each using the associative property. So again, the associative property of addition tells us that when we're adding 3 or more numbers, we can group this addition in any way that we'd like, and it's not going to change our sum. So we're going to begin with the quantity 4 plus 6. And I say the quantity 4 plus 6 because there's parentheses around 4 plus 6. So the quantity 4 plus 6 plus 7. How would we rewrite this using the associative property? Well, we're going to use the same 3 numbers. So the 4, the 6, and the 7. So the addition part is the same. It's still 4 plus 6 plus 7. What we're changing is the grouping. So what we have parentheses around. So instead of having parentheses around 4 plus 6, we're going to put parentheses around 6 plus 7. So now we'd have 4 plus the quantity 6 plus 7. But what the associative property of addition is telling us is that it doesn't matter how you group the addition, the result is going to be the same. On the left, we have 4 plus 6 inside of parentheses, so when we evaluate, we would do that first. So 4 plus 6 would give us 10. So we would essentially have 10 plus 7, which is 17. So this side is 17. On the right, we would do 6 plus 7 first because now that's inside of parentheses. 6 plus 7 is 13. So we would have 4 plus 13, and that is 17 as well. So you can see it does not matter what you put parentheses around if you're adding the same three numbers. You get the same result either way. Okay, now we want to look at 13 plus the quantity 2 plus 8. So we have parentheses around 2 plus 8. And so I'm just going to rewrite this, 13 plus 2 plus 8. And I'm just going to put parentheses around different numbers. So instead of it being around 2 plus 8, we'll put it around 13 plus 2. And again, to show you that you get the same result either way, 2 plus 8 is 10. 10 plus 13 is 23. Over here, 13 plus 2 is 15. 15 plus 8 is 23 as well. Okay, for the last one we have the quantity 10 plus 20, then plus 15. Again, parentheses around 10 plus 20. And we're rewriting this using the associative property of addition. So we have 10 plus 20 plus 15. And we're just going to shift what we have parentheses around to 20 plus 15. Again, to prove that this property holds, if we look at the left side, we do 10 plus 20 first because it's in parentheses. 10 plus 20 is 30. Then we add 15 to the result. That gives us 45. Over here we have 20 plus 15. That would be done first because that's what's inside of parentheses. 20 plus 15 is 35. Then we add 10 to that. We would get 45 as well. So you can see either way, you get 45 as your answer. And changing what we had parentheses around didn't make a difference. And that's, again, what the associative property of addition is telling us. Hello, and welcome to Pre-Algebra Practice Set number 6. And in this video, we're going to look at some additional practice problems for the lesson that we did on adding whole numbers using a number line. Okay, so to begin, we want to add each using a number line. And we start out with the first problem. It's 7 plus 4. So when we perform addition of whole numbers on a number line, essentially we just take the leftmost number of the addition problem and we start there on the number line. So our leftmost number is a 7, so we locate 7 on the number line and we just start there. Then we're adding 4. So that means we're just moving to the right 4 units on the number line. So I'm going to move 1, 2, 3, 4 units to the right, and I end up at 11. Okay, so we all know that 7 plus 4 is 11. So let me just write that here. 7 plus 4 equals 11. Now we have 3 plus 1 plus 5. And even though we're adding 3 numbers, we're going to do the same thing. We're going to start at the leftmost number, which is 3, on the number line. And then every time we add a number, we're just going to move to the right on the number line by that number of units. So we're adding 1, so we just go 1 unit to the right. So that will put us at 4. And then we're adding 5, so now we're going to go 5 units to the right. So I'm going to go 1, 2, 3, 4, 5 units to the right, and we end up at 9. So we end up at 9, so 3 plus 1 plus 5 equals 9. And you can check that in your head. 3 plus 1 is 4, 4 plus 5 is 9, so we can see that that is correct. For the next problem, we have 12 plus 5 plus 2. So again, we're going to start at the leftmost number on the number line, so we'll start at 12. So that is going to be right here. And then we're adding 5, so that means we're moving to the right by 5 units. So we're going 1, 2, 3, 4, 5 units to the right. So that's going to put us at 17. Now we're adding 2 to that, so we're going to go another 2 units to the right. So 1, 2 units to the right, and that gives us a final answer of 19. So 12 plus 5 plus 2 equals 19. And just check that in your head. 12 plus 5 is 17. 17 plus 2 is 19. Yeah, that checks out. Okay, for the final problem we're going to look at, we have 9 plus 1 plus 4 plus 6. Again, even though it's 4 numbers now that we're adding, the procedure is still going to be the same. Start out at the leftmost number on your number line. So here's 9 here. And we want to move to the right by the number of units that we're adding. So if we're adding 1, we're moving to the right 1 unit. So that puts us at 10. Then we're adding 4. So we're moving to the right 4 units. 1, 2, 3, 4. So that is 14. And then we're adding 6. So now we're moving to the right 6 units. 1, 2, 3, 4, 5, and 6. and that gives us a final answer of 20. So 9 plus 1 plus 4 plus 6 is equal to 20. We can just mentally check that. 9 plus 1 is 10, 10 plus 4 is 14, and 14 plus 6 is in fact 20. Hello, and welcome to Pre-Algebra Test Section 1 on adding whole numbers using a number line. So for our problems, we want to add each using a number line. So we're going to start with the problem 1 plus 4. So basically, when we add whole numbers using a number line, we take our leftmost number from the addition problem, and we start there on the number line. So we're going to start out at 1, which is our leftmost number from the addition problem. And then when we add a whole number, we just move to the right on the number line by that number of units. So we're adding 4, so we're just going to go 1, 2, 3, 4 units to the right, and we end up at 5. So 1 plus 4 equals 5, and we all know that that is true. Okay, now we want to work on 2 plus 6. So again, we want to start at the leftmost number of the addition problem, which is 2 on our number line. And then we're adding 6, so we're just moving 6 units to the right on the number line. So 1, 2, 3, 4, 5, 6. And of course, we end up at 8, right? Because 2 plus 6 is equal to 8. Okay, for the final problem, we're adding 3 numbers, and essentially we're just using the same technique. Starting at the leftmost number on the number line, and then every time we add a whole number, we just move to the right on the number line by that number of units. So if we have 5 plus 2 plus 3, 5 is the leftmost number of the addition problem. We're going to start there on the number line. We're adding 2, so we're just going 1, 2 units to the right to end up at 7. And then we're adding 3, so we're just going to go 1, 2, 3 units to the right, and we end up at 10 on our number line. So 5 plus 2 plus 3 is equal to 10. And of course, we can mentally check that. 5 plus 2 is 7. 7 plus 3 is in fact 10. Hello, and welcome to Pre-Algebra Test Section 2 on adding whole numbers using a number line. So for the problems today, we just want to add each using a number line. So we're going to begin with 1 plus 3 plus 2. And basically the way this works is you start at the leftmost number. So you start out at 1 on the number line. So that's right here. And then every time you add a number, you're going to move to the right by that number of units on the number line. So we're adding 3 to 1. So we're just going to move 3 units to the right. So 1, 2, 3 units to the right. That would put us at 4. And then we're adding 2 more. So we're going to move 2 more units to the right on the number line. So 1, 2, and that's going to put us at 6. So the answer for 1 plus 3 plus 2 is 6. 1 plus 3 plus 2 equals 6. And you can kind of mentally check this. 1 plus 3 gives you 4. 4 plus 2 does give you 6. Okay, for our last problem, we have 6 plus 2 plus 4. Again, we're going to start out on the number line at the leftmost number. So we're going to find 6, and that's right here. And we're going to move to the right 2 units to add 2. So we're adding 2. That puts us at 8. And then we're adding 4. So we're going to move 4 units to the right. So 1, 2, 3, 4. So that puts us at 12. So 6 plus 2 plus 4 equals 12. And again, you can mentally check that. 6 plus 2 is 8. 8 plus 4 is 12. Hello, and welcome to Pre-Algebra Test Section 3 on adding whole numbers using a number line. So for our problems today, we want to add each using a number line. Okay, so we begin with 4 plus 3 plus 5 plus 1. So when we add whole numbers using a number line, we start on the number line at the leftmost number of the addition problem. So we're going to start out at this 4. Every time we add a number, we're going to move to the right by that number of units. So we're adding 3. We're going to go to the right 1, 2, 3 units. So we're going to end up at 7. Then we're adding 5. So we add 5, we're going to go 5 units to the right. 1, 2, 3, 4, 5. That's going to put us at 12. And then lastly, we're adding 1 more. So we're going to go 1 more unit to the right, and that's going to give us 13. So the answer for our addition problem, 4 plus 3 plus 5 plus 1, is 13. And let me just highlight that here. So started at 4 and went to 13. And again, you can check this mentally. 4 plus 3 is 7, 7 plus 5 is 12, and 12 plus 1 is in fact 13. Okay, last one. we have 7 plus 1 plus 5 plus 1. So again, start at the leftmost number of the addition problem. So start at 7 on the number line. And then every time we add a number, we're going to move to the right by that number of units. So we start by adding 1. So we're going to go to the right 1 unit. That puts us at 8. Now we're going to add 5. So we're going to go 5 units to the right. So 1, 2, 3, 4, 5. That's going to put us at 13. And then lastly, we add 1. So we're going to go 1 more unit to the right. And that's going to put us at 14 as our final answer. Let me highlight that guy. So we have 7 plus 1 plus 5 plus 1 equals 14. And again, you can mentally check it. 7 plus 1 is 8. 8 plus 5 is 13. 13 plus 1 is, in fact, 14. Hello, and welcome to Pre-Algebra Test Section 4 on adding whole numbers using a number line. So for these exercises, we want to add using a number line. And we're going to start with 9 plus 4 plus 3 plus 1 plus 2. And again, we want to start out at the leftmost number of the addition problem, and we're going to find that on the number line. So we start out at 9. And every time we add a number, we're just moving to the right by that number of units on the number line. So if we're going to add 4, we're just going 4 units to the right on the number line. So that's 1, 2, 3, and 4. So we're going to end up at 13. Then we're adding 3. So we're going to go 1, 2, 3. So we end up at 16. Then we're adding 1. So we're just going 1 unit to the right. So that's 17. And then we're adding 2. So to add 2, we're going 2 units to the right. So 1, 2. And we end up at 19 as our final answer. So 9 plus 4 plus 3 plus 1 plus 2 is equal to 19. And again, you can kind of mentally check this. 9 plus 4 is 13. 13 plus 3 is 16. 16 plus 1 is 17. 17 plus 2 is, in fact, 19. Hello, and welcome to Pre-Algebra Test Section 5 on adding whole numbers using a number line. So for the problems we're going to look at today, we want to add using a number line. So our problem is 10 plus 2 plus 4 plus 6 plus 1. So to add whole numbers using a number line, we're going to start at the leftmost number of your addition problem on the number line. So here's 10 on the number line. Now every time we add a number, we just move to the right by that number of units on the number line. So we're adding 2. So we're just going to go 1, 2 units to the right on the number line. So that puts us at 12. Then we're adding 4. So that's going to put us 1, 2, 3, 4 units to the right on the number line. So at 16. Then we're adding 6. So that's going to put us 1, 2, 3, 4, 5, 6 units to the right on the number line. So at 22. And lastly, we're adding 1. So we're just going to go 1 more unit to the right on the number line. And that puts us at 23. 23. Let's write our answer. 10 plus 2 plus 4 plus 6 plus 1 is equal to 23. And you can mentally check that. 10 plus 2 is 12. 12 plus 4 is 16. 16 plus 6 is 22. And then 22 plus 1 is 23. Hello, and welcome to Pre-Algebra Practice Set number 7. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical addition. So the instructions for today, we want to just perform each addition. So we're going to begin with 62 plus 55. So remember, we're going to stack these numbers on top of each other. And we got to make sure we line them up by place value. So we'll have 62 plus 55. And again, remember, it's got to be by place value. So this is all the numbers that are in the ones place are going to go here. And then all the numbers in the tens place are going to go here. They got to be lined up. So now we perform our addition. And we start in the rightmost column or the ones column, and we work to the left. So we start with 2 plus 5. That's 7, so we're going to put that in the ones column for the answer. We just go straight down. We're moving to the left now. So we're going to the next column left. That's the tens column. And we're going to do 6 plus 5. That's 11. So we just write a 1 in the tens column. And we would usually carry a 1 into the next column up here, but there's no more numbers, so we just write it here. So we get an answer of 117 for 62 plus 55. Okay, next we have 5,092 plus 7,001. So 5,092 plus 7,001. Okay, so again, we're going to start with the numbers in the ones column. We're just going to go straight down. So 2 plus 1 is 3. We put that result in the ones column for the answer. Again, just going straight down. Now we're moving to the left. So now we're going to do 9 plus 0. 9 plus 0 is 9. Moving to the left again, 0 plus 0 is 0. Moving to the left again, 5 plus 7 is 12. We can go ahead and write a 12 here because there's no more numbers to the left. So we're just putting a 2 in the thousands place and a 1 is going into the 10,000s place. So our answer here is 12,093. Okay, now we have 343,221 plus 6,341,592. Typically, when we have numbers that have a different number or a different amount of digits in them, we take the number that has the most digits and we put that on top. You don't have to do that. You can do it either way. But this is generally how we're going to do that. We're going to put 6,341,592 on top, and we're going to put 343,221 on the bottom. And again, make sure you line them up by place value, and you just work right to left. So we're going to start in the ones column. 2 plus 1 is 3. And we're going to the tens column. 9 plus 2 is 11. Now remember, 11 is too big to fit in this space here. Okay? So what we do is we put a 1 down. We put a 1 down, and we carry a 1. Okay? We carry a 1. Essentially, when you have 11, you take the rightmost digit, and you put in the answer column, and then you carry the leftmost digit into the next column, and that's what we've done. Okay, so now we're going to continue our addition. So now we have 1 plus 5, that's 6. 6 plus 2 is 8. Then we go 1 plus 3, that's 4. Then we have 4 plus 4, that's 8. Then 3 plus 3 is 6. And then this 6 we can just bring down. So we end up with 6,684,813 as our answer. Okay, for the next problem, we have 99,672 plus 3,357 plus 115,799. And essentially, this is a little bit new for us because we haven't done one with 3 add-ins in it, or 3 numbers that are being added. But it's the same. I'm just going to start by putting the numbers on top of each other. I'm going to stack them up. And I'm going to take the number with the most amount of digits, which is 115,799, and I'm going to put that on top. Then I'm going to go to the number with the second most amount of digits in it, which is 99,672. Put that in the middle. And then I'm going to take 3,357, and I'm going to put that guy on the bottom. Okay, so let's do some addition here. So I'm going to start in the right column, which is the ones column, and I'm going to add. 9 plus 2 is 11. 11 plus 7 is 18. So I'm going to put an 8 here, which is the rightmost digit of 18, and I'm going to carry a 1. I'm going to carry a 1. Okay, now we're going to do 1 plus 9, that's 10. 10 plus 7 is 17. 17 plus 5 is 22. So I'm going to put a 2 into the answer column, the rightmost digit, and I'm going to carry a 2 into the next column. So now we have 2 plus 7, that's 9. 9 plus 6 is 15. 15 plus 3 is 18. Okay, so I'm going to put an 8 down into the answer column, and I'm going to carry a 1. So now we move it to the next column. 1 plus 5 is 6. 6 plus 9 is 15. 15 plus 3 is again 18. So I'm putting an 8 down in the answer column, and I'm carrying a 1 over into the next column. 1 plus 1 is 2. 2 plus 9 is 11. So again, putting a 1 down and carrying a 1. Okay, carrying a 1. And now I just have 1 plus 1, and that's 2. So I can bring that down here. I end up with 218,828 as the answer. Hello and welcome to Pre-Algebra Test Section 1 on vertical addition. So for the problems today, we just want to perform each addition. Okay, so we'll begin with 29 plus 30. And basically what we want to do is stack these numbers on top of each other and make sure that they're lined up by place value. So 29 plus 30. Notice how it's lined up where the digits in the ones place or the ones column are on top of each other, and the digits in the tens place of the tens column are stacked up on top of each other. So now we want to just add the digits in the ones column, and we're going to work our way to the left after that. So 9 plus 0 is 9. Just go ahead and put the result directly below. And then as we go to the left, next we're going to have 2 plus 3, that's 5. put the result directly below, and we have an answer of 59. Okay, next let's look at 717 plus 182. So again, we're going to stack these numbers up on top of each other, make sure they're lined up by place value. So we're going to start with the digits in the ones column. So 7 plus 2 is 9. And we're going to work our way to the left. 1 plus 8 is 9 as well. And then 7 plus 1 is 8. So we end up with 899 as our answer. So lastly, we have 5060 plus 129. And whenever we have numbers that we're adding, and we have one number with more digits than the other, we're going to typically take the number with the most amount of digits and put that on top. So I'm going to take 5060 and put that on top of 129. And again, make sure you line it up by place value. We're going to start with the rightmost column, or the ones column. 0 plus 9 is 9. Then we'll do the tens column. 6 plus 2 is 8. Then we'll do the hundreds column. 0 plus 1 is 1. And then we have the thousands column, which just has a 5 here. Nothing down here, so we can just basically bring this number down, or say 5 plus 0 equals 5. So we end up with 5,189 as the answer. Hello and welcome to Pre-Algebra Test Section 2 on vertical addition. So for the problems we're going to look at today, we just want to perform each addition. Okay, for the first problem, we have 593 plus 715. And again, to work these problems, we start out by stacking the numbers on top of each other and by place value. So we'll take 593 and stack that on top of 715. And notice how everything is lined up. Your digits in the ones place are lined up on top of each other. Your digits in the tens place are lined up on top of each other. And your digits in the hundreds place are lined up on top of each other. So now we start our addition by looking at the digits in the rightmost column, or the ones column. So we have 3 plus 5, that's 8. We write the answer directly below. Now we work our way to the left. So we're going into the tens column. Now we have 9 plus 1, that's 10. Now, like we talked about in the lesson, if your answer is larger than 9, you're going to use a process called carrying. So we think about 10, we take the rightmost digit of this number, and we put it in the answer column. So the 0 goes there. Then we take the leftmost digit of this number, which is a 1, and we carry it into the next column to be included with the addition. So now we move to the next column, and we have this 1 plus 5, that's 6, then plus 7, that's 13. Now normally you'd have to put a 3 down and carry the 1, but there's no more numbers over here, so you can just write 13, right? Because if you carried the 1 into the next column, it would just come down. There's nothing to add it to. So our answer here is going to be 1,308. Okay, let's continue with 2,950 plus 3,087. So 2,950 plus 3,087. Again, notice how your numbers are lined up by place value. So we're going to begin in the rightmost column and work our way to the left. So 0 plus 7 is 7. 5 plus 8 is 13. So I'm going to put a 3 down, the rightmost digit, and I'm going to carry a 1, the leftmost digit. Then I'm going to continue with my addition. 1 plus 9 is 10. So I'm going to put a 0 down, which is the rightmost number, and then I'm going to carry the 1, which is the leftmost number. So then we have 1 plus 2, that's 3. 3 plus 3 is 6. We end up with 6,037 as our answer. Okay, for the final problem, we have 6,591 plus 97,563. So again, we're going to stack these numbers on top of each other and align them by place value. Now, these two numbers have a different amount of digits in them. Typically, what you're going to see is when a number has more digits, you're going to put that one on top. You don't have to do it that way, but generally that's what we do. So we're going to take 97,563 and put that on top of 6,591. Now we're ready to add. So we start in the rightmost column. So we have 3 plus 1, that's 4. We're going to work our way to the left. 6 plus 9 is 15. Put a 5 down, carry a 1. Right? If you think about 15, the rightmost digit is a 5. That goes in the answer column. The left digit is a 1 that gets carried into the next column. Now we have 1 plus 5, that's 6, plus 5, that's 11. Put a 1 down, okay, the rightmost digit, and carry a 1. So now we have 1 plus 7, that's 8. Then 8 plus 6 is 14. So we're going to put the 4 down, the rightmost digit, and we're going to carry a 1. Carry a 1 over here. So 1 plus 9 is 10. And because there's no more numbers here, I can just write 10. So we end up with 104,154 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical addition. So for the problems we're going to look at today, we just want to perform each addition. And let's start out with 598,753 plus 6,322,195. Now, as I keep repeating, generally what you're going to do is you're going to start out by putting this number, the 6,322,195, on top because it has more digits. That's just a common practice. If you wanted to put this number, the 598,753 on top, you can do that. You will get the same answer. So, again, we want to stack the numbers on top of each other, line them up by place value. So we're going to have 6,322,195. I'm going to put that on top. I'm going to put 598,753 on the bottom. And again, I can't stress this enough. Notice how I line up all the numbers in the ones place, all the numbers in the tens place, all the numbers in the hundreds place, so on and so forth moving down. Now, when we start our addition, we start in the ones column, and we're going to add 5 plus 3. We know the result is 8, so we put it directly below into our answer column. Move to the left, we have 9 plus 5. Now 9 plus 5 is 14. That result is too big to put in the tens column for the answer. So we use a process called carrying. With carrying, you think about the number 14. The right part, or the 4, is going to go into the answer column. So I'm going to put the 4 there. The 1, or the left part of the number, is going to get carried into the next column to be included with that column's addition. So now we're going to have 1 plus 1, that's 2. Then 2 plus 7 is 9. Next column, we have 2 plus 8, that's 10. So again, we're going to split the number up, right? We're using the carrying process. The right part of the number, the 0, goes into the answer column. And the 1, the left part of the number, gets carried into the next column. So now we're going to include that in our addition. 1 plus 2 is 3. 3 plus 9 is 12. Again, break 12 up. The right part of the number is the 2. The left part of the number is the 1. So you're going to carry that into the next column. Then we have 1 plus 3, that's 4. 4 plus 5 is 9. And then finally I have 6. I'm not adding anything to that. So bring that number down. And we get 6,920,948 as our answer. All right, next let's look at this 655,999 plus 9,875,822. So we're going to stack these numbers on top of each other and line them up by place value. So again, I like to take the number with more digits and put that on top. 9,875,822. I'll take the number with fewer digits, put that on the bottom, 655,999. Again, if you switch this, put this on top and this on the bottom, you get the same answer. Does not matter whatsoever. So let's start our addition in the ones column. So we'll do 2 plus 9, and that's 11. So immediately we have to carry. Remember, put the rightmost digit, which is 1, into the answer column, and carry the leftmost digit into the next column. So in this case, each digit is a 1, so we just put a 1 in the answer column, and we carry a 1. Now we have 1 plus 2, that's 3. 3 plus 9 is 12. So I'm going to put a 2 down, and I'm going to carry a 1 into the next column. Now I have 1 plus 8, that's 9, and 9 plus 9 is 18. So I'm going to put an 8 down, and I'm going to carry a 1 into the next column. 1 plus 5 is 6, 6 plus 5 is 11. So I'm going to put a 1 down, and I'm going to carry a 1 into the next column. Now I have 1 plus 7, that's 8. 8 plus 5 is 13. So I'm going to put a 3 down, and I'm going to carry a 1. Okay, I'm going to carry a 1 into the next column. Now I have 1 plus 8, that's 9, and 9 plus 6 is 15. So I'm going to put a 5 down, and I'm going to carry a 1 into the next column. So lastly, we have 1 plus 9, and that's 10. So when I have no more numbers over here, I don't have to use any kind of carrying. I can just write that number into the answer. So we end up with 10,531,821 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on vertical addition. So for the problems we're going to look at today, we would just want to perform each addition. And so we begin with 199,573 plus 996,522. So we want to start by stacking these numbers on top of each other, but we got to make sure that they're lined up by place value. So we have 199,573. We have 996,522. And just notice how we have our place value for each number aligned. So in other words, the 3 here, which is in the ones place for 199,573, sits directly on top of the 2, which is in the ones place for this number 996,522. And as we move to the left, we basically do the same thing for the tens, the hundreds, the thousands, the 10,000s, and the 100,000s. Okay, so now we're ready to add. And to add, we basically start at the rightmost column, or the ones column, and we just sum the digits. So 3 plus 2 is 5. So I just put that answer directly below, and I move to the left now. 7 plus 2 is 9. Put the answer directly below. And then we get 5 plus 5, that's 10. So whenever we have an answer that's larger than 9, we have to do something called carrying. So if we think about the number 10, we basically just split it up into the right part and the left part. So the right part of this number, 0, is going to go into the answer. The left part is going to get carried into the next column. So we're going to carry this 1 over here, and we're just going to include it in our addition now. So we have 1 plus 9, that's 10, and then 10 plus 6 is 16. So we're going to do the same thing. We're going to take the right part of that number, which is 6, put it in the answer, and then we're going to carry the 1 into the next column. Include it with the addition. So 1 plus 9 is 10, 10 plus 9 is 19. Doing the same thing. We're going to put a 9 down, which is the right part of the number, and then we're going to carry the left part, which is a 1, into the next column. So now I can add in this column. 1 plus 1 is 2. 2 plus 9 is 11. So because there's no numbers over here, I could just go ahead and write the 11 like that, put a comma, and we're done. So our answer is 1,196,095. Okay, for the last problem, we have 39 plus 715 plus 1,037. So we're adding 3 numbers here, but basically the procedure is the same. We're just going to stack the numbers on top of each other and line them up by place value. So you take the number with the largest amount of digits in it, and you put that one on top. You don't have to, but it's generally what we're going to do. So this number, 1,037, has 4 digits. Okay, it has 4 digits, so I put that one on top. 715 has 3 digits, so I'll put that one in the middle. And 39 has 2 digits, so I'll put that one on the bottom. And again, if you change the order of this, if you wanted to put 715 on top and 1,037 on the bottom and 39 in the middle, you're going to get the same answer. This is just generally how we do it. Okay, so we're starting in the ones column here, and we're just summing. So 7 plus 5 is 12. 12 plus 9 is 21. So because I can't fit 21 here, I use the carrying process. Take the right part of 21, which is a 1, put it in the answer, carry the 2 to the next column. Now we add. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 3 is 9. Then we go to the next column. 0 plus 7 is 7. And then the final column, we just have a 1, and that can basically just come down, right? So we end up with 1,791 as our answer. Hello, and welcome to Pre-Algebra Test Section 5 on vertical addition. So for these problems, we want to perform each addition, and we're going to start out with 315 plus 975 plus 10,341 plus 31,393. So when we add more than 2 numbers together, the process is still the same. We want to stack these numbers on top of each other and line them up by place value. So typically what we do is we take the numbers with the larger amount of digits in them. So in other words, this number has 5 digits, this number has 5 digits, this number has 3 digits, and this number has 3 digits. So you want to take the ones with the larger amount of digits in them and put those on the top. You don't have to, but that's generally what we do. So 10,341 can go on the top. Then 31,393 can go below that. Then let's take 975 and put that below that. And then we'll finish up with 315. And again, if I change the order here, it's not going to matter. I can put 315 on top. I can put 975 on top. It doesn't really matter. It just, in my opinion, just makes it easier if you put the larger numbers or the numbers with more digits in them on the top. Okay, so let's do some addition now. So we start by looking at the numbers in the rightmost column. Okay, so in the rightmost column or the ones column, and we're just going to add those. So 1 plus 3 is 4, 4 plus 5 is 9, and then 9 plus 5 is 14. So I can't fit a 14 there, so what we need to do is use a process called carrying. And when you carry, you take the rightmost part of that number, or the rightmost digit of that number, 14, and you put it in the answer. So I'm going to put a 4 there, and then I'm going to carry the left part into the next column. So the 1 goes there. Now, I just do my addition in the next column, and I include this 1. So 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 7 is 21, and then 21 plus 1 is 22. So again, I need to carry. I'll put the rightmost part of that number, which is a 2, in the answer, and then I'll carry a 2. We continue. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 9 is 17, and then 17 plus 3 is 20. So I put the rightmost part of 20, which is a 0, down in the answer, and then carry a 2. Now I have 2 plus 0, that's 2, and then 2 plus 1 is 3. And then finally I have 1 plus 3, which is 4. So our answer is 43,024. Final problem, we have 513,212 plus 9,375,158 plus 126,393,591. So again, we're going to stack these numbers on top of each other. This number here, 126,393,591, has the largest amount of digits in it. So I'm going to put that on top. So 126,393,591. Then I'm going to take this number right here. I'll put that in the middle. The 9,375,158. And then on the bottom, I'm going to put 513,212. Okay, so now we're just going to add, and we're going to start in the ones column. So 1 plus 8 is 9, 9 plus 2 is 11. And again, we need a carry. So I'm going to put a 1 down, and I'm going to carry a 1. Put the rightmost number down in the answer column, then carry the leftmost number into the next column. So 1 plus 9 now is 10. 10 plus 5 is 15. 15 plus 1 is 16. Put a 6 down, the rightmost part of that number. Carry the 1, the leftmost part. Now we continue. 1 plus 5 is 6. 6 plus 1 is 7. 7 plus 2 is 9. Go to the next column. 3 plus 5 is 8. 8 plus 3 is 11. So put a 1 down, carry a 1. Now we continue. 1 plus 9 is 10. 10 plus 7 is 17. 17 plus 1 is 18. So we're going to put an 8 down. We're going to carry a 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 5 is 12. So we'll put a 2 down, carry a 1. 1 plus 6 is 7. 7 plus 9 is 16. So we're going to put a 6 down and carry a 1. 1 plus 2 is 3. And then this 1 can just go down. And you just bring this down. So we end up with 136,281,961 as our answer. Hello and welcome to Pre-Algebra Practice Set number 8. And in this video, we're going to look at some additional practice problems for the lesson that we did on subtracting whole numbers using a number line. So for the problems we're going to look at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So let's take a look at the first one. Okay, we're going to start out with 11 minus 3. So 11 minus 3. So to do this on a number line, we're going to start at the leftmost number of the subtraction problem, otherwise known as the menu end. So we're going to find that on the number line. So here's 11. And basically what we want to do is we want to move to the left by the number of units being subtracted away. So if we have 11 minus 3, we're subtracting away 3. So we're just going to go 3 units to the left on the number line. So that's going to be 1, 2, and 3. So that puts us at 8. And so that's the answer for our problem. So 11 minus 3 is equal to 8. Of course, we all know that already. Let's go ahead and label the parts of the subtraction problem now. So we have 11 minus 3 equals 8. So 11 is known as the menu end. The menu end. That's the whole amount or the amount that you start with. 3 is known as the subtrahend. And that's the amount that's being taken away. We're taking 3 away from 11. And then lastly, 8, which is the result of the subtraction operation, or you could say the result of 3 being taken away from 11, it's called the difference. Okay, so again, 11 is the minuend, 3 is the subtrahend, and 8 is the difference. Okay, for the next problem, we have 6 minus 4. And of course, we start the same way. We look at the left number of the subtraction problem. And in this case, that's 6. Find that on our number line. So that's right here. And then we're subtracting away 4. So we're just going to go 4 units to the left in the number line. So starting at 6, we're going 4 units to the left. That's 1, 2, 3, and 4. And we end up at 2. So 6 minus 4 equals 2. And to label the parts of the subtraction problem, 6 minus 4 equals 2. 6 is the minuend. Again, that's the whole amount or the amount we're starting with. Then 4 is the subtrahend. That's the amount we're subtracting away. And then 2, which is the result of 6 minus 4, is the difference. Okay, now we have 15 minus 9. So again, we're going to look for 15 on the number line. That's our leftmost number for the subtraction problem, and that's going to be right there. Now we're subtracting away 9, so that means we're going 9 units to the left on the number line. So count them out. 1, 2, 3, 4, 5, 6, 7, 8, and then finally 9. So that puts us at 6. And so that's going to be our answer. So 15 minus 9 is 6. And of course, we already know that. So 15 minus 9 equals 6. So let's go ahead and label this guy. So 15 is the minuend. Okay, again, that's the whole amount we're starting with. 9 is the subtrahend. That's the amount we're taking away, right? We're subtracting 9 away from 15. And then 6 is the difference. Okay, 6 is the difference. It's a result of 15 minus 9. Okay, last problem. We have 4 minus 3. And obviously the answer to that is 1. We're going to do it on the number line. So 4, the leftmost number, is going to be right here on the number line. And we're subtracting away 3. So let's go 3 units to the left on our number line. So that's going to be 1, 2, 3 units to the left to put us at 1. And again, of course, we know that 4 minus 3 is 1. We just want to do it on a number line. So 4 minus 3 equals 1. Let's label this one last time. The leftmost number here, this 4, is the whole amount that we're starting with. This is the minuend. This 3 here is the amount we're subtracting away, or the amount we're taking away. That's our subtrahend. And then lastly, 1 is going to be our difference. It's the result of 4 minus 3. Hello and welcome to Pre-Algebra Test Section 1 on subtracting whole numbers using a number line. So today we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 9 minus 2. So the way we subtract on a number line is we start out at the leftmost number of the subtraction problem, and we find that on the number line. So we have 9 as the leftmost number of the subtraction problem, and on the number line, that guy is right there. Now, we're subtracting away 2. So when we subtract away 2, we move 2 units to the left on the number line. So we're just going to go 1, 2 units to the left on the number line, and we end up at 7. So that will be our answer for this problem. 9 minus 2 equals 7. Now, it also asks us to label the parts of the subtraction problem. So a subtraction problem has 3 parts. The first part is called the minuend. So this 9 right here is the minuend. And basically that represents the whole amount or the amount we're starting with. Then 2 is known as the subtrahend. Okay, it's known as the subtrahend. The subtrahend is the amount that we're taking away. So we're taking 2 away from 9. So that's why 9 is the minuend. That's the whole amount. 2 is the subtrahend. That's the amount we're taking away. Then the result of 9 minus 2 is 7. This is known as the difference. Okay, so 7 is the difference. For our final problem, we have 7 minus 6. So we start out on the number line at 7, the leftmost number of the subtraction problem. And then, since we're subtracting away 6, we're just going to move 6 units to the left. So we're going to go 1, 2, 3, 4, 5, 6 units to the left, and end up at 1. Okay, we end up at 1. So 7 minus 6 equals 1. And again, to label the parts of the subtraction problem, 7 is the amount we start out with. So this is your minuend. 6 is the amount that we're subtracting away. That's what we're taking away from 7. So this is the subtrahend. And then 1 is the result of the subtraction operation. So we have 7 minus 6, that gives us 1. So 1 is known as the difference. Hello and welcome to Pre-Algebra Test Section 2 on subtracting whole numbers using a number line. So for the problems today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 11 minus 5. So we start out at the leftmost number of the subtraction problem, and we find that guy on the number line. And then if we're subtracting away 5, it means we move to the left 5 units on the number line. So we're going to go 1, 2, 3, 4, and 5 units to the left to end up at 6. So that will be our answer for 11 minus 5. That equals 6. So now we need to label the parts of this subtraction problem. So you have 3 parts to a subtraction problem. You have the minuend, you have the subtrahend, and you have the difference. So the minuend is going to be this number here on the left. This is the minuend. And that's basically the amount we start with. So you can think of it as, let's say I start out with $11 and I spend $5 on a sandwich and I end up with 6. So 11 would be the amount you start with. That's your minuend. Now 5, the amount you spend or the amount that's taken away, this is called the subtrahend. This is the subtrahend. And then the result that you get from subtracting 11 minus 5 is known as the difference. Okay, the difference. So 6 is the difference. Okay, let's look at another one. We have 6 minus 6 here. So we all know that 6 minus 6 is 0, but we want to do it on a number line, and we're just going to start at the leftmost number here. So we're going to find 6 on the number line, that's right there. And then we're subtracting away 6, so we're just going to move 6 units to the left. So we're going to go 1, 2, 3, 4, 5, and then finally 6 units to the left to end up at 0 on the number line. Okay, so 6 minus 6 equals 0. Now, let's label the parts of the subtraction problem. Now, we have the same number involved in 2 different areas, but we still label them differently. This 6 on the left is the minuend. Minuend. This 6 right here, to the right of the other 6, is the subtrahend. You can just think of this as I start with $6 and I spend $6 and I'm left with $0. So my starting amount was 6, that's the minuend. I'm subtracting away 6, that's the subtrahend. Let me make that D a little bit better. Subtrahend. And then I end up with 0. That's the result of the subtraction operation. This is the difference. Hello and welcome to Pre-Algebra Test Section 3 on subtracting whole numbers using a number line. Okay, so for the problems, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 13 minus 4. So to do 13 minus 4 on the number line, we start out at 13 on the number line. the leftmost number. So here's 13. And then if we're subtracting away 4, that means we're going to move to the left of the number line 4 units. So we'll go 1, 2, 3, 4 units to the left, and end up at 9 on the number line. So 13 minus 4 equals 9. Now let's label the parts of the subtraction problem. The amount here on the left, 13, is known as the minuend. This is the minuend. The 4 right here, the amount that's being subtracted away or taken away, is the subtrahend. The subtrahend. And then the 9 here, which is the result of 13 minus 4, is known as the difference. Okay, now we have 5 minus 2. So again, we start out on the number line at the leftmost number of the subtraction problem. So we're going to start on the number line at 5. And then we're subtracting 2 units away. So that correlates to a 2-unit movement on the number line to the left. So 1, 2 units to the left. And that puts us at 3. And that's going to be the answer to our problem. So 5 minus 2 equals 3. And then to label the parts of the subtraction problem, 5, the amount here on the left, the starting amount, is the minuend. 2, the amount that's being taken away or subtracted away, is the subtrahend. And then 3, which is the result of the subtraction operation here, is the difference. Hello and welcome to Pre-Algebra Test Section 4 on subtracting whole numbers using a number line. Okay, so for the problems we're going to look at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. All right, so we begin with 9 minus 5. So to subtract on a number line, you start out on the number line at the leftmost number of the subtraction problem. So we're going to start out on the number line at 9, right? We have 9 minus 5, so we start out at 9. Then, whatever we're subtracting away, we're going to go that many units to the left. So we're subtracting away 5 here. So that means that I'm going to go 5 units to the left on the number line. So that means I'm going to go 1, 2, 3, 4, 5 units to the left and end up at 4. Okay, end up at 4 on the number line. So that tells us that 9 minus 5 equals 4. So now we're also going to label the parts of the subtraction problem here. And there's 3 parts. There's a minuend, a subtrahend, and a difference. So this leftmost number here, this 9, basically you can think of it as the whole amount that you start out with. This is the minuend. This is the minuend. And then what we're subtracting away, or what we're taking away from that whole amount, is 5. That's known as the subtrahend. And then lastly, the result of subtracting 9 minus 5 is 4. This is known as the difference. Okay, now let's look at 13 minus 10. Okay, so the first thing we want to do is find 13 on the number line. That's right here. And then we're subtracting away 10, so we're just going to move 10 units to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left and end up at 3 on the number line. And so 13 minus 10 is equal to 3. So again, to label this, the 13, the leftmost number, is the minuend. The 10, which is the amount being subtracted away or taken away, is the subtrahend. And then the 3 is the difference. Hello and welcome to Pre-Algebra Test Section 5 on subtracting whole numbers using a number line. So for the problems we're looking at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we begin with 12 minus 7. And to do 12 minus 7 on a number line, we start out by finding the leftmost number of the subtraction problem, which in this case is 12, on our number line. So that guy is right here. Let's go ahead and highlight that. And basically, whatever we're subtracting away, we're moving that many units to the left on the number line. So since we're subtracting away 7, we're going to go 7 units to the left on the number line. So we're going to go 1, 2, 3, 4, 5, 6, and finally 7 units to the left on the number line. So that's going to put us at 5. And so that's the answer for our subtraction problem. Okay, so we have 12 minus 7 equals 5. And now we just want to label the parts of the subtraction problem. So if we look at 12, that's going to be the minuend. The minuend. That's the left number in the subtraction problem. It's the amount that we're starting out with. And then 7 is the amount we're taking away, or the amount we're subtracting away. This is known as the subtrahend. The subtrahend. Then finally, 5 is a result of the subtraction operation here. That's called the difference. 5 is called the difference. Okay, for the final problem, we want to do 10 minus 6. So we're going to start out by finding 10 on our number line. And that guy's going to be right here. And then since we're subtracting away 6, we're just moving 6 units to the left on the number line. So we're going to go 1, 2, 3, 4, 5, and then finally 6. So this is where we're going to stop, right here at 4. So that tells us that 10 minus 6 is equal to 4. And then again, to label the parts of the subtraction problem, the 10 here, the leftmost part of the subtraction problem, is the minuend. The minuend. The 6 is the subtrahend. The subtrahend. And then lastly, the 4 is the difference. Hello and welcome to Pre-Algebra Practice Set number 9. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical subtraction. So for the problems today, we just want to perform each subtraction. Okay, we're going to begin today with 67 minus 35. So we start out by stacking the numbers on top of each other and lining them up by place value. But this is different from addition. They have to go in a certain order. So this left number here, remember this is called the minuend. The minuend. This guy has to go on top. He's first. He's the whole amount that you're going to take away from. Then this part right here, the 35, this is called the subtrahend. The subtrahend. That's the amount we're subtracting away, or the amount we're taking away from 67. This has to go on the bottom. Okay, this has to go on the bottom. So notice how we've stacked these numbers up where, again, 67 is on top, 35 is on the bottom, and we've lined up the place values. So all the numbers in the ones place line up, all the numbers in the tens place line up, and if we had more digits in these numbers, we would continue. All the numbers in the hundreds place would have to line up, so on and so forth. Now, we're going to start our subtraction in the rightmost column, or the ones column, and we're going to work our way to the left. So we're just going to do 7 minus 5, and that's 2. Then we're going to do 6 minus 3, and that's 3. So we end up with 32 as the answer. Next, we have 98 minus 21. So again, we're going to stack these numbers on top of each other, line them up by place value, but this leftmost number, 98, has to go on top, and then 21 is going to go on the bottom. And again, we start on the rightmost column and work our way to the left. So 8 minus 1 is 7, then 9 minus 2 is 7 as well. So we end up with 77. Okay, for the next problem, we have 710 minus 459. So 710 goes on top, 459 is going to go on the bottom. And when we start our subtraction problem out, we notice we have a little bit of a problem. So when we do this column, the ones column, we have 0 minus 9. So 0, the number on top, is smaller than 9, the number on the bottom. So when we run into this, we use a little procedure called borrowing. Okay? So what we're going to do is we're going to take 1 away from the digit immediately to the left of it. So 1 minus 1 is 0. And then I'm going to write a 1 in front of this digit 0. So this 0 is now going to become a 10. And all I did was I took 10 from the tens place. If you think about this 1 here, since it's in the tens place, it's really a 10. So I took 10 from the tens place and I just stuck it in the ones place. So now instead of having 0, I have 10 in the ones place. So 10 minus 9 is 1. Then I move to the next column to the left and I have the same problem. 0 minus 5, I can't do that, so I need to borrow. So I'm going to go to my neighbor to the left, take 1 away. 7 minus 1 is 6. And then I'm going to write a 1 in front of this 0. So now I have a 10 there, and then 10 minus 5 would give me 5. And then I go to the next column, 6 minus 4 would give me 2. So I end up with 251 as my answer. Now, I explained to you a way to kind of dig into this and see what's going on in the lesson. And basically what you can do is just write these numbers in expanded notation. So 710 is 700 plus 10. And then I'm just going to put plus. I'm going to put a blank space because there's a 0 in the ones place. So we really don't have anything there. But essentially, I'm just going to put a blank space there. And then 459 is 400 plus 50 plus 9. Now, if you think about just subtracting in these kind of columns here, if you think about just subtracting, what would happen when we try to do nothing minus 9? Well, we can't do that, right? So we have to go and borrow. So I go over here and I borrow 10. Let's just cross this 10 out and put a 0. And let's just send it over here and put 10. Now, I haven't changed the value of the number. I still have 700 plus 10. I've just changed the way that it looks. And obviously, we can't fit a 10 in the ones place when we're writing a number. But for the purposes of what we're doing, we're just temporarily doing that so that we can perform the subtraction in that column. So we're doing 10 minus 9. That would give us 1. But now when I go over to the tens column, I have 0 and I'm trying to take away 50. So I have to borrow again. So I go over to my neighbor, which is the hundreds, and I take 100 away. So this 700 becomes 600, and I send 100 over. And if you look at the number, it's still the same. 600 plus 100 plus 10 is still 710. So now I can do subtraction. 100 minus 50 is 50. And then over here, 600 minus 400 is 200. And if I look at this number here in expanded notation, it's 251, right? 200 plus 50 plus 1. So that's what we're doing when we're borrowing. We're just temporarily rewriting the column so that we can perform the subtraction in that column. Okay, now we have 198,387 minus 126,377. So 198,387 minus 126,377. So we start in the rightmost column. 7 minus 7 is 0. Then we move to the left. 8 minus 7 is 1. 3 minus 3 is 0. 8 minus 6 is 2. 9 minus 2 is 7. And then 1 minus 1 is 0, so I don't need to put anything there. So we end up with 72,010, and let me rewrite that. 72,010 is our answer. Okay, next we have 614 minus 79. So 614 minus 79. So when we start in the rightmost column, the ones column, 4 is smaller than 9, so I'm going to borrow from my neighbor. So what you do is you take 1 away, so 1 minus 1 is 0, and then you write a 1 in front of this digit in the ones column. So now the 4 becomes a 14. Essentially, if you think about the place values here, all I did was I temporarily sent 10, right? This 1 right here, since it's in the tens column, is 10, over to the ones column. So instead of having a 4, I have 14, right? 4 plus 10 is 14. Didn't change the value of the number. 600 plus 14 is still 614. So now when we think about this ones column, I can subtract. 14 minus 9 is 5. Okay, is 5. And when we move to the left, we have the same problem. Now I just have a 0 here, and I'm trying to subtract away 7. So borrow from the neighbor. We take away 1. 6 minus 1 is 5. And we put the 1 in front of this digit. So put a 1 in front of the 0, you end up with a 10. So then 10 minus 7 is 3. And then we can just bring down the 5 here. And we end up with 535 as our answer. And again, just for the last time, just thinking about writing these numbers in expanded notation, 614 is 600 plus 10 plus 4. 79 is 70 plus 9. So what we did here, when we crossed out this 1 originally, we were crossing out this 10 and saying that it's 0, and we were sending that 10 over to the ones column. So this 4 became a 14, right? When I put a 1 in front of that 4, it became a 14. Then I did my subtraction. 14 minus 9 is what? That's 5. Now, when I try to do 0 minus 70, I needed to borrow again. So I borrowed a 1, which is basically a 100, because if you think about a 1 in the hundreds place, that's 100. So over here, I'm borrowing 100. So this becomes 500, and this becomes 100. But when you look at it in the standard form, I just wrote it as 10 because 10 tens would be 100. So 100 minus 70 now is 30. And then this 500 just comes down because I'm not subtracting anything away. And so 500 plus 30 plus 5 is 535. Okay, now we have 703,321 minus 698,977. So 703,321 minus 698,977. So when we begin, we immediately need to borrow. 1 minus 7, I need to borrow. So I go to my neighbor to the left. I take away 1. 2 minus 1 is 1. So now this is a 1, and I put a 1 in front of this digit, and that becomes an 11. So 11 minus 7 is now 4. Okay, we have 4. Now when I try to do 1 minus 7, I need to borrow again. So I go over here. I'm going to take 1 away. 3 minus 1 is 2. So this is now a 2. Put a 1 in front of this digit, it becomes an 11. Now 11 minus 7 is 4. Now when I do 2 minus 9, I need to borrow again. So go over here. This 3 is going to become a 2. Right? Just take away 1 and then put a 1 in front of this digit so it becomes a 12. Now 12 minus 9 is 3. Okay, this is 3. Now moving to the left, 2 minus 8, I need to borrow again. But here's where there's a problem, and I talked to you about this in the lesson. You can't borrow from a 0, right? You can't borrow from a 0. So you actually have to borrow in 2 steps. I got to keep going to the left until I get a non-zero number. So when I go to this 7, I'm going to cross that out and subtract away 1 to get the 6. I'm sending my value over to the column to the right. I can't send it all the way over here. I've got to do it in 2 steps. So this becomes a 6, and I put a 1 in front of this digit, it becomes a 10. Now I can borrow from the 10. You think about this, 2, I'm going to borrow from this 10. 10 minus 1 is 9, so now this is a 9, and I'm going to put a 1 in front of the 2 to make it a 12. So now finally I can do my subtraction in that column. 12 minus 8 is 4. And then moving to the left, 9 minus 9 is 0, and 6 minus 6 is 0. So we end up with 4,344 as our answer. Okay, for the final problem, we have 6 million minus 4,578,125. So 6 million minus 4,578,125. Okay, so when we try to do our subtraction in the rightmost column, the ones column, we see we have 0 minus 5. We need to borrow. But the problem is we don't have anything we can borrow from until we get to this 6. So this leads to a long, tedious process. This 6 I'm going to borrow from. The 6 will become a 5, and I'm going to put a 1 in front of the digit here. But I have to keep doing this basically until I get to the ones place. So I'm going to keep borrowing. So the 10 will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. And then finally this will become a 9, and this will become a 10. So we have to do all that work just so that we can start our subtraction problem. And when you get numbers with a lot of trailing zeros like that, that's going to happen to you. So we start with 10 minus 5, and that's 5. And then we have a 9 minus 2, that's 7. Then we have a 9 minus 1, that's 8. Then we have 9 minus 8, that's 1. Then we have 9 minus 7, that's 2. Then we have 9 minus 5, that's 4. And then lastly, we have 5 minus 4, which is 1. So we end up with 1,421,875 as our answer. Hello, and welcome to Pre-Algebra Test Section 1 on vertical subtraction. So for the problems we're going to look at today, we want to perform each subtraction. So we're going to start out by looking at 71 minus 55. So when we do vertical subtraction, we want to stack the numbers on top of each other and make sure they're lined up by place value. So I'm going to put 71 on top. and I'm going to put 55 on the bottom. Now, you have to do it that way. Recall when we did vertical addition, it didn't matter. You could put whatever number on the top and whatever number on the bottom, made no change to the result. Here, it will change the result. So we have to make sure that we put the left number here, or the minuend, on top, and the right number here, or the subtrahend, on the bottom. Now, when we perform our subtraction, we start in the rightmost column, and so we would do 1 minus 5. But there's a problem here. When we have a number in the top that's smaller than the number on the bottom, we need to do a little trick called borrowing. So I'm going to go to my neighbor to the left, and I'm going to borrow 1. So if I subtract 1 away from 7, I will get 6. And then I'm going to write a 1 in front of whatever digit is here. In this case, it's a 1, so this will become an 11. Now, we would take 11 and subtract away 5, and that will give us 6. Now we move to the next column to the left, and now this is a 6. It's no longer a 7 because I borrowed from it. So 6 minus 5 now is 1, and we get an answer of 16. Okay, for the next problem, we have 312 minus 18. So 312 minus 18. Okay, so we're going to start out in the rightmost column, and we have 2 minus 8. So again, we need to borrow in this situation because 2 is smaller than 8. So I go to my neighbor to the left, and I borrow 1, and this becomes 0, and I put a 1 in front of that digit. So now I get a 12 here, and I can do my subtraction. 12 minus 8 is 4. Now going to the left, now I have a problem again because this is now a 0, and 0 minus 1 is going to cause us to borrow. So I need to go over to the left and borrow from my neighbor. So subtract 1 away from 3, and I'll get 2. And I'm going to put 1 in front of this digit to make it a 10. So now 10 minus 1 would give us 9. And then 2 minus, you can think of this as 0, or basically just say I'm just going to bring this 2 down to end up with 294 as my answer. Okay, let's look at the last one. We have 1090 minus 1002. So 1090 minus 1002. Now, when I go to subtract in the right column, I need to borrow, right? Because I'm trying to do 0 minus 2. So I borrow from this 9, subtract away 1 from the 9, and we get 8, and put a 1 in front of this digit right here. So now I have a 10. 10 minus 2 is 8. And I move to the left. 8 minus 0 is 8. 0 minus 0 is 0. And 1 minus 1 is 0. So these two zeros don't add any value to the number. So I can just erase them. I don't need them at all. My answer here is going to be 88. Hello and welcome to Pre-Algebra Test Section 2 on vertical subtraction. So for the problems today, we just want to perform each subtraction. We're going to begin with 572 minus 101. So to do a vertical subtraction, you want to stack the numbers on top of each other and make sure they're lined up by place value. But what's different with vertical subtraction versus vertical addition, the order that you subtract in does matter. So you have to be careful about what you put on the top and what you put on the bottom. So this leftmost number here, this 572, otherwise known as the minuend, is going to go on top. That's what we're starting with. Then we're taking away, or we're subtracting away, this number on the right, this 101. This is known as the subtrahend. So minuend, or 572, is going on top. Subtrahend, or 101, is going on the bottom. Now, again, notice how I've lined up the numbers according to their respective place values. So all the numbers in the ones place are on top of each other. All the numbers in the tens place are on top of each other. All the numbers in the hundreds place are on top of each other, so on and so forth. So we begin by just subtracting in the rightmost column, and we're going to work our way to the left. So 2 minus 1 is 1. Going to the left, 7 minus 0 is 7. And then 5 minus 1 is 4. So very easy problem. We end up with 471 as our answer. Okay, so for the next problem, we have 3001 minus 865. So 3001 minus 865. And notice how, again, I put 3001 on top and 865 on the bottom, and the numbers are lined up by place value. When we begin this problem, we start in the rightmost column, and immediately we know that we have a situation. We have 1 minus 5. So when we run into the situation where the number on top is smaller than the number on the bottom, we use a little procedure called borrowing. And to do that, we look to our neighbor to the left and we try to borrow from that. But because this is 0 and this is 0, we have to go all the way over to this 3 to borrow. And we can't just borrow and go straight back to the 1. We have to go through each number. So what we do when we borrow is we take 1 away. So 3 minus 1 is 2. And then we put a 1 in front of the digit to the right. So this 0 will become a 1. Now we're going to borrow again. So this 10 will become a 9. We put a 1 in front of this digit. This becomes a 10. Then we're going to borrow one more time. This 10 becomes a 9. And we put a 1 in front of this digit. It becomes an 11. So now we can finally perform our subtraction in this right column. We have 11 minus 5, that's 6. And now we just move to the left. So now this is a 9. 9 minus 6 is 3. This is a 9. 9 minus 8 is 1. And this is a 2. But I don't have anything down here, so I can just bring it straight down. And I end up with 2,136 as my answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical subtraction. So for the problems we're going to look at today, we just want to perform each subtraction. Okay, for the first problem, we're going to look at 15,984 minus 14,297. You need to stack the numbers on top of each other and make sure they're lined up by place value. But you have to make sure that you put the leftmost number here, 15,984, on the top. Okay, this is known as your minuend, or basically the amount you're starting with. And you have to make sure that you put 14,297 on the bottom. This is your subtrahend, or the amount that you're subtracting away from the 15,984. So it has to go in this order, otherwise you won't get the right answer. Subtraction is not commutative like addition, where you can just do it however you want. So once we have our subtraction problem set up, we're ready to go. We start out in the rightmost column, the ones column, and we're going to work our way to the left. Now when we start our subtraction, we see that there's a problem right away. We have 4 minus 7. So when the number up top here is smaller than the number on the bottom, we need to use a little trick called borrowing. So I go to my neighbor to the left in the tens column, and I'm going to borrow 1 away from it. So 8 minus 1 is 7. And I'm going to write this 4 as 14. I'm just going to put a 1 in front of it. And just thinking about what I did was, this 8 is really an 80. It's in the tens place. So when I write it as 7, now it's a 70. So where did the 10 units go? Where did the 10 go? Well, it's going right here. I had a 4, and now I wrote it as a 14 by putting a 1 in front of the 4. So I haven't changed the value of the number. I've just temporarily changed what it looked like so that I could do the subtraction. So now if I look in the ones column, I have a 14 minus a 7. I can do that. 14 minus 7 is 7. And then I move to the left. Now I have 7 minus 9. I'm in the same boat that I just was in. So I need to borrow again. So to make this kind of short and sweet, I subtract 1 away from 9. That makes it 8. And then I just put a 1 in front of the 7. That makes it a 17. And basically that's what you do when you borrow. You take 1 away from what you're borrowing from, and you put a 1 in front of the digit that you needed to borrow for. So now we have a 17 here, and we can perform our subtraction. 17 minus 9 is 8. And we move to the left. 8 minus 2 is 6. And we move to the left. 5 minus 4 is 1. And then 1 minus 1 is 0. So we end up with 1,687 as our answer. Okay, for the last problem, we have 13,215 minus 9,087. So again, we want to stack the numbers on top of each other and make sure they're lined up by place value. So 13,215 minus 9,087. Again, 13,215, the minuend goes on top, the leftmost number. 9,087, the subtrahend is going to go on the bottom, right? That's what we're taking away. Okay, so when we start our subtraction, we start in the rightmost column. And again, we notice that we have a problem, 5 minus 7. So we need to borrow. And again, to make this quick, you go to the left number. And the left number here is a 1. You're going to take 1 away. 1 minus 1 is 0. Then you're going to put a 1 in front of the digit that you needed to borrow for. So I needed to borrow for this 5. I put a 1 in front of it. I get a 15. So now we can do our subtraction because we have 15 minus 7. That can be done. 15 minus 7 is 8. Now we move to the column to the left. But again, there's a problem because now I have a 0, and I need to subtract away 8. So I'm going to borrow again. Go to my neighbor to the left, and basically I'm going to take 1 away. 2 minus 1 is 1, and I'm going to put a 1 in front of the digit I needed to borrow for. So I'm going to put a 1 in front of that 0, and it becomes a 10. So now I'm going to do 10 minus 8. 10 minus 8 is 2. Moving to the left, I have 1 minus 0, that's 1. Moving to the left, I have 3 minus 9, so I need to borrow. Go to my neighbor to the left, this 1 will become a 0, right? 1 minus 1 is 0. Put a 1 in front of the digit I needed to borrow for, so the 3 becomes 13, and 13 minus 9 is 4. So we have our answer now. It's 4,128. Hello and welcome to Pre-Algebra Test Section 4 on vertical subtraction. So for the problems today, we just want to perform each subtraction. So we're going to begin today with 313,975 minus 303,989. So we have to stack these numbers up on top of each other, and we have to make sure they're lined up by place value. Now it's important what you put on top and what you put on the bottom. The left number here, the menu end, needs to go on top. So 313,975 is going to go on top. And then the subtrahend, the number on the right here, is going to go on the bottom. 303,989. Now we're ready to subtract. And let me just move this bar down a little bit. So we always start in the rightmost column and work our way to the left. So we would start with 5 minus 9. Well, there's a little problem there because this number right here, this 5, is smaller than the 9. So when this happens, we use a little trick, and that trick is called borrowing. So we go to our neighbor to the left and we borrow. So what we do is we'll cross this 7 out, we'll subtract 1 away from the 7, and we'll make it a 6. And then we'll write a 1 in front of the digit. And essentially, if you think about what's going on here, this 7 is in the tens place. So it really represents 70. If I take 1 away from it and put it as a 6, really now it's 60. Okay, so it's 60 instead of 70. So where did the 10 go? Well, the 10 went over here because instead of having a 5, I now have a 15. So I just took 10 away from here and lent it to the 5 to make it a 15. So I didn't change the value of the number. I'm just temporarily changing what it looks like so that I can perform my subtraction. So now I can subtract in the ones column. I have 15 minus 9. That's going to give me 6. Now we move to the left. We have 6 minus 8, and we have a problem again. We need to borrow. So we're going to do the same thing. We're going to go to the left. We're going to subtract 1 away from that, so 9 will be 8. And then we're going to put a 1 in front of the digit that we needed to borrow for. So this 6 is now a 16. So now we can do our subtraction. 16 minus 8 is 8. And we move to the left. We have 8 minus 9. Again, we need to borrow. So we're looking to the left. This 3 will become a 2, right? I'm subtracting 1 away from it, and I'm putting a 1 in front of the digit that I needed to borrow for. So this 8 is now an 18, and now I can do my subtraction. 18 minus 9 is 9. Okay, moving on, we have a 2 minus 3, and again, we need to borrow. So we're going to take 1 away from 1, that's going to give me 0, and I'm going to put a 1 in front of that digit I needed to borrow for. Now that's going to be a 12. So 12 minus 3 gives me 9. Moving to the left, 0 minus 0 gives me 0. And moving to the left again, 3 minus 3 gives me 0. So what we end up with here, since those zeros don't add any value to the number, 9,986 as our answer. Okay, for the final problem, we have 4,277,680 minus 305,000. Okay, so let's go ahead and set this up in vertical subtraction format. This number right here, the menu end, the leftmost number, the 4,277,680 is going to be on the top, and the subtrahend, the number on the right, the 305,000 is going to be on the bottom. So when we start out subtracting, we look at the rightmost column, and so we have 0 minus 0, that gives us 0. Move to the left, 8 minus 0 gives us 8. Move to the left, 6 minus 0 gives us 6. We'll continue moving to the left. 7 minus 5 gives us 2. 7 minus 0 gives us 7. And then we have 2 minus 3. So again, when this number is smaller than this number, we need to borrow. So I'm going to borrow from this 4. 4 minus 1 gives me 3. and then put a 1 in front of the digit that I needed to borrow 4. So the 2 is now a 12. Again, I put a 1 in front of it. So 12 minus 3 would give us 9. And then I can just bring this 3 down. So we end up with 3,972,680 for our answer. Hello and welcome to Pre-Algebra Test Section 5 on vertical subtraction. So for the problems we're going to look at today, we just want to perform each subtraction. And we're going to start out with 80,773,916 minus 42,874. So for vertical subtraction, we just want to stack the numbers on top of each other and make sure they're lined up by place value. But we have to make sure that we do it in the correct order. So this number on the left, known as the menu end, has to go on top. 80,773,916. This number on the right here has to go on the bottom. This is number on the right, 42,874, known as the subtrahend. So 42,874. And again, make sure that you line this up by place value. Otherwise, if you misalign it, you're not going to get the correct answer. So we always start out our subtraction in the rightmost column, the ones column, and we work our way to the left. So if we start with 6 minus 4, we'll get 2. Next, we'll have 1 minus 7. So when we run into something like that, where the number on top is smaller than the number on the bottom, we need to borrow. So we go to the neighbor next to us to the left, and we subtract away 1 from it. So 9 minus 1 is 8. And then we put a 1 in front of the digit that we needed to borrow 4. So now this 1 is an 11. And we can perform our subtraction in that column. 11 minus 7 is 4. Moving to the left, 8 minus 8 is 0. 3 minus 2 is 1. 7 minus 4 is 3. And then over here we just have blank space. So essentially you can just bring the numbers down. So we'll bring down the 7. Bring down the 0, and bring down the 8, and we'll have 80,731,042 as our answer. Okay, for the next one we have 919,121,426 minus 141,914,627. So 919,121,426 is going to go on top. Again, that's the menu end, the left number in the subtraction problem. And then minus, we have 141,914,627. So that number, the subtrahend, the number on the right, the number that we're taking away from the menu end, is going to go on the bottom. Okay, let me write this a little better. 6, 2, and then 7. Okay, so we're going to start subtracting in the rightmost column. And we want to do 6 minus 7. So again, there's an issue there because 6 is smaller than 7. So we're going to borrow from the tens place. So taking 1 away from 2 gives me 1. And I put a 1 in front of the digit that I need to borrow for. So the 6 is now a 16. So 16 minus 7 is 9. And now I go to the next column. Remember, now I have a 1. 1 minus 2, I need to borrow. So this 4 is going to become a 3. The 1 is going to become an 11. Okay, so 11 minus 2 is now 9. And move to the left, I have a 3 minus 6. Again, I need to borrow. Take 1 away from the 1, I get 0. Put a 1 in front of the 3, I get 13. So 13 minus 6 is 7. Okay, now we have 0 minus 4. Need to borrow again. So take 1 away from the 2, you get 1. Put a 1 in front of the 0, you get 10. 10 minus 4 is 6. We keep moving to the left. 1 minus 1 is 0. We keep moving to the left. 1 minus 9, we need to borrow. So I'm going to take 1 away from 9. I'm going to get to 8, and I'm going to put a 1 in front of this 1 here. So now this is an 11. Okay, this is an 11. So 11 minus 9 gives me 2. Keep moving to the left. 8 minus 1 is 7. And now we have 1 minus 4. So we need to borrow again. So this 9 is going to become an 8, right? Subtract 1 away from the 9, you get 8. Put a 1 in front of the 1, and you get an 11. So now we do 11 minus 4. Okay, 11 minus 4, we're going to get 7. Move to the left, 8 minus 1, we're going to get 7 as well. So we end up with 777,206,799 as our answer. Hello and welcome to Pre-Algebra Practice Set number 10. And in this video, we're going to look at some additional practice problems for the lesson that we did on the properties of multiplication. So for the first few problems, we're going to multiply each and identify the components of the multiplication problem. So we begin with 4 times 3. So the multiplication part's very simple. 4 times 3 is 12. And to identify the parts of the multiplication problem, essentially we have factors, which are numbers that are multiplied together. So 4 and 3 are being multiplied together. Those are factors. And then we have something known as the product. So 12 is the product. It is the result of the multiplication operation. Okay, now we have 9 times 4 times 1. So 9 times 4 is 36. 36 times 1 is still 36. And then to label the parts of the multiplication problem, the numbers being multiplied together are known as the factors. So 9, 4, and 1 are factors. And then 36, which is the result, is the product. Okay, here we have 7 times 5 times 0 times 12. Now, I warned you about problems like this in the lesson. This is basically kind of, you can think of it as a trick question. If you think about the fact that 0 times any number will always give you 0, and all of this is just multiplication, there's no other operations involved, 0 will be the result here. 7 times 5 will give you 35, but then once you multiply 35 times 0, you get 0, and then 0 times anything after that will be 0. So if you have numbers that are being multiplied together, and it's only multiplication involved, and 0 is involved in that, you know the answer is 0. Now to label the parts here, we have the numbers that are being multiplied together, the 7, the 5, the 0, and then the 12. These are the factors. And then the 0 here is the product. It is the result of the multiplication operation. Okay, for the next set of problems, we want to rewrite each using the commutative property. And again, the commutative property just tells us that we can reorder the factors in a multiplication problem, and it's not going to change the result. The product will be the same. So if we start out with 12 times 3, notice how 12 is first, 3 is last. We can change the order here and put 3 first and 12 last, and either way you get the same result. 12 times 3 is 36. 3 times 12 is also 36. Next, think about 9 times 11. Okay, we can reorder this using the commutative property as 11 times 9. Again, same result either way. 9 times 11 is 99. 11 times 9 is also 99. Now we have 2 times 8, and again we can reorder this to 8 times 2. 2 times 8 is 16. 8 times 2 is also 16. Okay, now we want to rewrite each using the associative property. And remember, the associative property tells us that when we're multiplying 3 or more numbers, we can group this multiplication however we want. And when I say group, meaning put parentheses around whatever we want, and it won't change the result. So we're going to begin with 3 times 4 inside of parentheses, then times 2. So essentially, the numbers stay the same. 3 times 4 times 2. And I just switch what I have parentheses around. So in this case, I have parentheses around 3 times 4. In this case, I have parentheses around 4 times 2. With the order of operations, it tells us that we do what's inside of parentheses first. So on the left side here, I would do 3 times 4 first. That would be 12. Then I'd multiply 12 times 2, I'd get 24. On the right, I have 4 times 2 inside of parentheses. So I'd do that first, I would get 8. Then I would multiply 8 times 3, I'd also get 24. So you can see that I changed what I had parentheses around. I changed what numbers I multiplied first. And it did not change the result. I got 24 either way. Here we have 9 times 7 inside of parentheses, then times 1. And we'll use the same 3 numbers, 9 times 7 times 1. We're just going to change what we put parentheses around. So in this case, we'll put parentheses around 7 times 1. And again, if we check this, on the left side, 9 times 7 is 63. We do that first because that's what's inside of parentheses. Then times 1, still 63. Over here on the right, 7 times 1 would be done first because that's what's in parentheses. 7 times 1 is 7. Multiply that by 9, still get 63. Okay, now we have 5 times, and then we have 6 times 3 inside of parentheses. So I'm just going to rewrite this as 5 times 6 times 3. And I'm just going to shift the parentheses to where I have parentheses around 5 times 6 now. And again, you get the same answer either way. On the left, 6 times 3 is done first. That's what's inside of parentheses. 6 times 3 is 18. So we would have 5 times 18. And 5 times 18 is 90. And on the right, I'd do 5 times 6 first. That's what's inside of parentheses there. 5 times 6 is 30. So you'd have 30 times 3, and that's 90. So either way, you get 90 as the result. All right, for our last set of problems, we want to use the distributive property to find each product. So we're going to start out with 9 times the quantity 6 plus 2. And I kind of spent a little bit of time explaining what the distributive property was in the lesson. Essentially, when you normally look at this problem, we do what's inside of parentheses first. We do 6 plus 2, that's 8. So you would have 9 times 8, and that's 72. So the distributive property gives us an alternative way to solve this problem. So we have 9 times this quantity, 6 plus 2. So what I can do is I can distribute the 9 to each number inside of the parentheses. So 9 times 6 plus 9 times 2. 9 times 2. You have to remember to write this addition sign. Very, very important. Now, again, we haven't done the order of operations yet, but we need to multiply before we add. So to make that clear, I'm going to put some parentheses around the multiplication operations that we have so that we can keep those separated from the addition. So 9 times 6 is 54. Then plus 9 times 2, that's 18. If we were to find this sum, let me erase this real quick. If we were to find this sum, we would get 72 as well. So either way, we would get the same answer. Okay, let's look at 3 times the quantity 7 plus 4. So if I kind of think about this the usual way, 7 plus 4 is 11. So this is 3 times 11, and that's 33. And then using the distributive property, again, I can distribute the 3 to each number inside the parentheses. So 3 times 7, and don't forget the addition, plus 3 times 4. 3 times 4. And again, just for our purposes, I'm going to put parentheses around these multiplication operations so that we know we do them first. All right, so 3 times 7 is 21. So that's 21. Then plus 3 times 4, that's 12. And if we find this sum here, we get 33. So either way, we get 33. All right, now we have 12 times the quantity 1 plus 9. So again, kind of 1 plus 9 would be 10. So this would be 12 times 10, and that would be 120. Doing it the other way, using the distributive property, we'd have 12 times 1, 12 times 1, plus 12 times 9, 12 times 9. So again, I'm going to put parentheses around the multiplication operation so we don't get confused on what we're going to do. So 12 times 1 is 12. Then plus 12 times 9 is 108. And we find this sum, and again, we get 120. Okay, let's look at a few with subtraction now. So we have 3 times the quantity 6 minus 5. So again, if I work what's inside of parentheses first, 6 minus 5 is 1. This would give me 3 times 1, or 3. So then using the distributive property, and it's the same as if you're doing it with addition, 3 times the quantity 6 minus 5. I'm going to do 3 times 6, 3 times 6, then minus, okay, minus 3 times 5, 3 times 5. So again, I'm going to put some parentheses around the multiplication operations just so that we don't get confused. And again, I just can't stress this enough. You don't need those. So 3 times 6 is 18. Then minus 3 times 5, that's 15. So if we do 18 minus 15, again, we're going to get 3. Okay, let's look at one final problem. After you do enough of these, it becomes very, very simple. And I can't stress to you enough how important it is to understand how to use this property, because when you get to algebra, you're really going to need it. So we have 5 times the quantity 10 minus 3. So again, if I do this by working inside of parentheses first, 10 minus 3 is 7. We'd have 5 times 7, that's 35. If I use my distributive property, I'll have 5 times 10, 5 times 10, minus 5 times 3, 5 times 3. So again, I'm going to put parentheses around the multiplication operations just because I don't want us to get lost. So 5 times 10 is 50. Then minus 5 times 3, that's 15. And we subtract here and we get 35. Hello and welcome to Pre-Algebra Test Section 1 on Properties of Multiplication. Okay, so for our problems today, we want to multiply each and identify the parts of the multiplication problem. All right, so we're going to begin with 6 times 2. And at this point, we all know that the answer to this is 12. When we go to label the parts of the multiplication problem, we think about there are factors and then there's the product. So factors are numbers that are multiplied together. So the 6 and the 2, those are the factors. Okay, those are the factors. And then the 12 is the result of multiplying 6 and 2. That's called the product. A lot of times you'll hear people say 12 is the product of 6 and 2. Okay, now we want to look at 7 times 2 times 1. So 7 times 2 is 14. And then 14 times 1 is still 14. Because remember, when we multiply a number times 1, it remains unchanged. Now, as far as labeling this multiplication problem, we have 3 factors here, 3 numbers that we're multiplying together. So 7, 2, and 1, those are the factors. And then 14, which is the result of this multiplication, is the product. Okay, here we have 171 times 9 times 0 times 5 times 18. So you might go through and say, I need a calculator to do this. But you actually don't. And the reason is because you have a 0 involved. So you have 0 as a factor. And essentially when you multiply something by 0, you always get 0. So whatever 171 times 9 is, which it happens to be 1,539, when you multiply it by 0, you get 0. Then when you multiply times 5, you get 0. Then you multiply by 18, you get 0. So look out for this type of question on a test. You might have a long string of numbers being multiplied together where 0 is one of the factors. You know the result in the end is going to be 0. Now for labeling the parts here, you have 1, 2, 3, 4, 5 factors. So 171 is a factor, 9 is a factor, 0 is a factor, 5 is a factor, and 18 is a factor. And then 0 is the result. It's your answer. So that's the product. Hello and welcome to Pre-Algebra Test Section 2 on Properties of Multiplication. All right, so for this section, we want to rewrite each using the commutative property. Now this commutative property is a pretty simple one. It just tells us that when we're performing multiplication, we can do it in any order and we won't affect our product. So the end result will be the same. So essentially when you see a problem like this and it tells you to rewrite each using the commutative property, you just switch the order around. So we have 3 times 7 here. Just switch the order and put 7 times 3. 3 times 7 is 21. 7 times 3 is also 21. Either way, you'll get the same result. Here we have 12 times 8. Again, just switch the order around and write it as 8 times 12. 12 times 8 is 96. 8 times 12 is also 96. Next, we look at 6 times 7. Again, all we're doing is just switching the order around. So I'm going to write this as 7 times 6. And either way, you're going to get 42. 6 times 7 is 42. 7 times 6 is also 42. Okay, last one. We have 9 times 5. And again, all we're doing here is just changing the order. So 9 is first in this case. Now it's going to be last. 5 is last. Now it's going to be first. So we'll just write this as 5 times 9. And again, either way, the answer is 45. 9 times 5 is 45. And also 5 times 9 is 45 as well. Hello and welcome to Pre-Algebra Test Section 3 on Properties of Multiplication. So for our problems today, we want to rewrite each using the associative property. When we think about the associative property of multiplication, essentially what it tells us is that if you're multiplying 3 or more numbers, you can group that multiplication however you want, and you will not change the product. Meaning, you can put parentheses around different numbers, you can shift that around. You won't change the result at the end of the day. So if we look at 5 times 2, and notice how that's inside of parentheses here. Then we multiply by 7. Using the associative property, we can rewrite this as 5 times 2 times 7. And we're just going to change what we have parentheses around. Now, that's relevant because the order of operations tells us we do operations inside of parentheses first. So if I look at the left and the right side and I think about kind of performing these operations separately, So on the left, I would do 5 times 2 first. That's what's inside of parentheses. 5 times 2 is 10. So I would have 10 times 7. That equals 70. Now think about on the right. You have 2 times 7 inside of parentheses. 2 times 7 is 14. So you would have 5 times 14. But that's also 70. That's also 70. So even though we put different numbers inside of parentheses, meaning we grouped this multiplication differently, we got the same result. So when you're multiplying the same 3 or more numbers, it doesn't matter what you put the parentheses around, you will always get the same answer. All right, let's look at a few more. So we have 8 times, and then 1 times 3 is inside of parentheses. We'll rewrite this with 8 times 1 inside of parentheses, then times 3. And again, either way you do this, you'll get the same result. On the left, you would do 1 times 3 first. That's what's inside of parentheses. You would get 3. You would then multiply that by 8 to get 24. On the right, you do 8 times 1 first. That's what's in parentheses there. You would get 8, multiply that by 3. Again, you get 24. All right, let's look at 10 times 4. That's inside of parentheses there. Then times 2. So again, rewriting this using the associative property, just change what you have parentheses around. That's all we're doing. So 10 times 4 times 2. And I'm just going to put parentheses around 4 times 2 now. Again, if you check this, on the left, 10 times 4 is 40. Do that first because that's what's in parentheses. Then multiply by 2, you get 80. On the right, 4 times 2 is done first. That's what's inside of parentheses. 4 times 2 is 8. Then multiply that by 10, and you also get 80. All right, so final one. We have 3 times 7 inside of parentheses, then times 5. And again, to rewrite this using the associative property, you have 3 times 7 times 5. Again, we're just going to put parentheses around 7 times 5 now. So we have parentheses around different numbers here. And again, we're going to get the same result. On the left, if I do 3 times 7 first, that's what's in parentheses, I get 21. Then 21 times 5 is 105. 105. On the right, I would do 7 times 5 first. That's what's in parentheses there. So I get 35. So you'd have 3 times 35, and big surprise, that's 105 as well. Hello and welcome to Pre-Algebra Test Section 4 on Properties of Multiplication. All right, so what we want to do here is use the distributive property to find each product. And we're starting out with 6 times the quantity 4 minus 2. So I'm going to do this problem 2 ways. I'm going to do it the way in which we work inside of the parentheses first, and then I'll use the distributive property so that you can see you get the same answer either way. So if we do 4 minus 2 first, because that's what's inside of parentheses, you get 2. So this problem would simplify to 6 times 2, and we know that that is 12. Now, if I use the distributive property, what I can do is I can distribute the 6 to each number inside of the parentheses. So I can say, well, this is 6 times 4, 6 times 4, and then we're going to subtract away 6 times 2, 6 times 2. And what I've been doing, since we haven't covered the order of operations yet, I've just been putting these multiplication operations inside of parentheses so that we know to do them separately. Okay, I just don't want you to get confused. But moving forward, you really don't need them because you need to multiply before you do subtraction. Okay, so with that being said, let's do our operations. 6 times 4 is 24. Then minus 6 times 2, that's 12. We do our subtraction and we get 12. So the same result as we got there. Okay, let's look at 3 times the quantity 7 plus 3. So again, if I do it the normal way where we work inside of parentheses first, 7 plus 3 is 10. So we would have 3 times 10. That gives us 30. If I use my distributive property, I can distribute the 3 to each number inside of parentheses. So we'd have 3 times 7. Then we'd have plus, and we do 3 times 3. 3 times 3. And again, I'm adding these parentheses in just for the sake of keeping these multiplication parts separate from the addition so you don't get lost. All right, so we're going to multiply 3 times 7 first. That's 21. Then we're going to do 3 times 3. That's 9. And when we find the sum here, we get 30. Okay, we get 30. Same as we did up here. Now we have 8 times the quantity 9 plus 4. And let's work inside of parentheses first. 9 plus 4 is 13. And then 8 times 13, okay, 8 times 13 is 104. Okay, so now let's do it using the distributive property. So we'll do 8 times 9. 8 times 9 then plus 8 times 4. 8 times 4. And again, I keep adding these parentheses in here just so that you understand that we're doing our multiplication operation separate, and then we're finding the sum. So we're going to do 8 times 9, that's 72. And we're going to add to that the result of 8 times 4, that's 32. So 72 plus 32 is 104. Again, just like we got up there. Okay, finally we have 10 times the quantity 1 plus 3. So again, if we do 1 plus 3 first, that would give us 4. Then we do 10 times 4, that's 40. If we use our distributive property, we'd multiply 10 times 1, 10 times 1, and then we're going to add to that 10 times 3, 10 times 3. And again, I'm going to put parentheses around 10 times 1, and I'm going to put parentheses around 10 times 3, so that we do these separate from our addition. So 10 times 1 is 10, plus 10 times 3, that's going to give me 30. And so 10 plus 30 is 40, just like we got up here. You can see either way we get the same result. Hello and welcome to Pre-Algebra Test Section 5 on the properties of multiplication. So for the problems we're going to look at, we want to use the distributive property to find each product. We start with 3 times the quantity 5 minus 3. So kind of the first way that we do this is we think about doing what's inside of parentheses first. 5 minus 3 is 2. So we could say 3 times 2 equals 6. So the distributive property gives us an alternative way to do this. Basically, we can distribute this 3 to each number inside of the parentheses. So we would do 3 times 5, 3 times 5, and then we would subtract away 3 times 3, 3 times 3. And what I've been doing, since we haven't learned the order of operations yet, I've been putting some parentheses around the multiplication parts here, just so that we know we do them separately. In the order of operations, we're taught that we multiply before we subtract. So normally when you see this, you're not going to have parentheses around it. You would just know that, okay, I do this multiplication here, and I do this multiplication here, and then I subtract the results. But just to make that completely clear, I'm going to put some parentheses around these multiplications here. So 3 times 5 would give us 15. 3 times 3 would give us 9. And when I find the result of 15 minus 9, I get 6, which is exactly what I got up there. Here we have 10 times the quantity 7 minus 7. So we all know this is going to be 0, hopefully, because 7 minus 7 is 0. And when we multiply a number times 0, we get 0. But let's use the distributive property to show this too. So we'd have 10 times 7, 10 times 7, then minus, again, 10 times 7. And I'm going to put parentheses around my multiplication parts just so we don't get confused. So 10 times 7 is 70, then minus 10 times 7, which is also 70, and 70 minus 70 is also 0. Let's look at 8 times the quantity 5 plus 2. If we worked inside of parentheses first, 5 plus 2 is 7. 8 times 7 is 56. If we use our distributive property, we'd have 8 times 5, 8 times 5, plus 8 times 2, 8 times 2. So again, I'm going to put parentheses around my multiplication parts so that we don't get lost. 8 times 5 is 40, plus 8 times 2, that's 16. We find the result of 40 plus 16, and that's 56, same as it was right there. All right, last problem. We have 11 times the quantity 4 plus 1. So for one last time, let's work inside the parentheses first. 4 plus 1 is 5. So then you'd have 11 times 5, that's 55. And if we do it the other way, if we use the distributive property, we'll multiply 11 times 4, 11 times 4, then plus, we'll have 11 times 1, 11 times 1. So again, I'm going to put parentheses around the multiplication parts, again, just because I don't want us to get lost. Just please keep in mind that we don't normally do that. It's just something I'm doing so that we don't get lost and confused about which operation to perform in which order. So 11 times 4 is 44. Then plus 11 times 1 is 11. And if we find this sum, we get 55. Hello and welcome to Pre-Algebra Practice Set number 11. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical multiplication. Okay, for the problems we're going to look at today, we just want to find each product. And we are going to begin with an easy one, 532 times 4. And to do this in vertical multiplication format, we stack the numbers on top of each other, meaning we do them vertically. And I typically like to take the number with more digits and put that on top. So 532 will go on the top, and 4 will go on the bottom. And again, we put a multiplication symbol out to the left of the bottom number, and we put a horizontal line underneath the bottom number. Now, if you wanted to switch this up and put 4 on the top and 532 on the bottom, you could do that. Remember, multiplication is commutative. You can do it in any order, and it will not change the result. This is just my preference. Now, when we start multiplying, we take this 4 here, and we multiply it by the rightmost digit of the top number, and we work our way to the left. So we're going to do 4 times 2 to start, 4 times 2, and that's 8. So we write the result in the ones column for the answer, and then we're just working our way to the left. So now we're going to do 4 times 3. 4 times 3 is 12. So when I try to fit a 12 in here, there's a problem. So I put a 2 down, the rightmost digit, and I carry a 1. Okay, I carry a 1. Now, the next thing I'm going to do is I'm going to multiply 4 times 5. This 1 here that I carried is not going to be involved in the multiplication. It's just something I'm going to add to the result of 4 times 5. So 4 times 5 is 20. Then I add 1 to that, and I get 21. And so my answer here is 2,128. All right, let's take a look at another easy one. We have 2,197 times 9. So again, I'm going to stack these numbers on top of each other and line them up by place value. And I'm going to take 2,197 and put that on top because it has more digits in it. So again, we start out with 9 times the rightmost digit of that top number, and we work our way to the left. So 9 times 7 is 63. So I'm going to put a 3 down, because that's what I can fit in the ones column, and I'm going to carry a 6 into the next column. Now this 6 is not going to be involved in any multiplication. It's just going to be added to the result of 9 times 9. So 9 times 9 is 81, and then if I add 6, I get 87. So I'm going to put a 7 down, the rightmost digit of 87, and I'm going to carry an 8 into the next column. Again, this 8, what I carried, is not going to be involved in any multiplication. It's just going to be added to the result of 9 times 1. 9 times 1 is 9, then 9 plus 8 is 17. So put a 7 down and carry a 1. And again, the 1 that I carried is not involved in any multiplication. It's just to be added to the result of 9 times 2. 9 times 2 is 18, plus 1 is now 19. So we end up with 19,773 as our answer. Okay, let's look at one that's a little bit harder. We have 5,062 times 15. So I'm going to put 5,062 on the top, and I'm going to put 15 on the bottom. And now, because we have a multi-digit number in the bottom, we have to remember that we start out at the rightmost digit, and we're going to multiply by every digit in the top number, working right to left. So we start out by multiplying by this rightmost digit, and we work our way to the left. So we're going to do 5 times 2, that's 10. And again, I have to carry there. So I'm going to put a 0 down, and I'm going to carry a 1 into the next column. Next, I'm going to do 5 times 6. 5 times 6 is 30. And then I add to that the 1 that I carried. So 30 plus 1 is 31. So I put a 1 down, and I carry a 3 into the next column. Now I'm going to do 5 times 0. 5 times 0 is 0. And now I'm going to add that 3, and that's going to give me 3. And just working my way to the left. Now I'm going to do 5 times 5. So 5 times 5, and that's 25. And there's nothing else over here, so I can just write the 25 in. Now, I'm not done. This 25,310 is what we call a partial product. We have to add that to the result of 1, okay, 1 times 5,062. But remember, because we moved to the left in this bottom number, we have to move to the left when we start writing our answer for this multiplication. And again, the reason for that, as I explained to you in the lesson, is because this 1 is not a 1. It sits in the tens place, so really it's a 10. Really, I'm saying 10 times 2 is 20. So I would put a 2 here to represent 20, right? If I put the 2, if I didn't do this and I did 1 times 2 like that and just said, okay, well, that's 2 right there, that's technically not right, because this is a 10 times a 2, which is a 20. So to correct for that, we go one place to the left, and we start our 2 right here, so that we can say it's a 20. Okay, and just work your way to the left. Now 1 times 6 is 6, 1 times 0 is 0, 1 times 5 is 5. And again, as I told you in the lesson, if you have a 1 in your bottom number, you can just copy this top number down. You just have to make sure you get the place value correct. I could have just copied 5062 down here, just make sure that you shift it to the left. And again, the reason for that is because when you multiply 1 by a number, you get that number back. Okay, so with that being said, you see that I put my addition operation over here. We're going to add these 2 rows here. So we have 25,310 plus, and because of its position, I could really write a 0 here to make this clear, we have 50,620. Okay, so we're adding those 2 numbers. So 0 plus 0 is 0, 1 plus 2 is 3, 3 plus 6 is 9, 5 plus 0 is 5, and 2 plus 5 is 7. So our answer here is going to be 75,930. Okay, for the next one, we have one that's more tedious. We have 2,460 times 319. So 2,460 times 319. So again, always we want to start with the rightmost digit of the bottom number times the rightmost digit of the top number, and we're just working our way to the left. So we're going to do 9 times 0 to start. That's 0. Then 9 times 6, that's 54. So I'm going to put a 4 down, and I'm going to carry a 5 into the next column. Now I want to do 9 times 4, that's 36, plus 5 is 41. So I'm going to put a 1 down, and I'm going to carry a 4 into the next column. Now I'm going to do 9 times 2, that's 18, then plus 4, that's 22. And because there's no more numbers over here, I can just go ahead and write 22. So the result of that is 22,140. So you got to kind of think about this as 9 times 2,460 gives you this. Okay. Now, the next thing we're doing is we have this 1. Okay, we have this 1 that's in the tens place. So remember, when we move to the left, we've got to move to the left here to start our answer, because that's not a 1, it's a 10. Now, something I just did in the last problem, I told you if you have a 1 here and you're multiplying it, really you can just copy the number. Because as you work right to left, you're going to get 1 times 0, that's 0. You're going to get 1 times 6, that's 6. You're going to get 1 times 4, that's 4. And then 1 times 2 is 2. I could have just copied 2,460 down. As long as I know where to start it, I'm okay. Because really, you think about this as 10 times 2,460, which is 24,600. Let me just put a 0 in there. And you don't have to add that in. It's just something I'm doing so that you see what we really have. What is the true value of that number? Okay, so now we're moving to the left again in the bottom number. And so in my answer, I've got to move to the left again. So I started here last time, so I'm moving to the left. Now I'm going to start my answer in the hundreds place. And again, the reason for that is because this 3 is in the hundreds place. It's really a 300. So I'm going to start with 3 times 0. That is 0. And that goes right here. And if I want to make this completely clear, I can put some zeros here, or I can leave it blank. Doesn't really matter. Okay, now I have 3 times 6. That's 18. So we're going to put an 8 down, and we're going to carry a 1. Now we have 3 times 4, that's 12, plus 1, that's 13. So put a 3 down, carry a 1. Then we have 3 times 2, that's 6, then plus 1 is 7. Okay, so now we're just going to crank out this addition. So we're adding all these zeros together. We know that's just going to give us 0. Then we're adding 4 plus 0 plus 0. That's just going to give us 4. 1 plus 6 plus 0 is going to give us 7. 2 plus 4 is 6. 6 plus 8 is 14. Put a 4 down, carry a 1. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. And this 7 can just come down. So we end up with 784,740. Okay, for the final problem we're going to look at today, we have 583,002 times 1,050. So whenever you see a long problem like this and you have some zeros involved, you can kind of breathe a sigh of relief because those zeros are going to help us a little bit. When you multiply 0 by something, it's 0, so it's going to save us some time. So 583,002 is what I'm going to write on top. And I'm going to take and write 1050 on the bottom. Okay, so we start out at the rightmost digit of the bottom number, and we multiply it by the rightmost digit of the top number, and we work our way to the left. Now, before you start going 0 times 2, 0 times 0, 0 times anything is 0. So the result of this row is just 0. I don't need to go through and write 6 zeros here. Don't need to do it. Because remember, this is a partial product, and at the end of the day, you're going to be adding this up to the other rows. So this doesn't change the value of what we're going to get at all. We don't need it. So we just leave it there as a 0, just to say, hey, I'm done with this, and I'm going to move on to the next one. Okay? So when we go to this 5, remember, we move to the left to get to that 5. So this 5 is in the tens place. So we got to move to the left here. Okay, so we got to think about this and move to the left. So this is where I'm going to start my answer. So I'm going to have 5 times 2. So 5 times 2 is 10. So I'm going to put a 0 down. I remember where to put it. And I'm going to carry a 1. Now I have 5 times 0. That's 0. Plus 1 is 1. Now I have 5 times 0. That's 0. Now I have 5 times 3. That's going to give me 15. So I'm going to put a 5 down. And I'm going to carry a 1. Next, I have 5 times 8, that's 40. Then plus 1 is 41. So I'm going to put a 1 down, and I'm going to carry a 4. And then lastly, I have 5 times 5, that's 25, plus 4 is 29. Okay, so the next thing we want to do is move to the left again. So we move to the left again, and we start in this hundreds column, and we have a 0 there. So in my answer, when I go to write it down, I've got to start in the hundreds column. So I've got to start right there. But again, we have this 0, and we're going to multiply 0 by 2, then 0, then 0. 0 times anything is 0. So I can just write a 0 here and be done. Just move on to the next number to the left. All right, so I move on to this 1 now, and that's also going to help us because it's a 1. Now, again, I got to do the same thing. Because I'm starting in the thousands place, my answer has to start in the thousands place, so it's going to start right there. Right here in the thousands place. Now, 1 times anything is itself. So I don't have to go through and do this multiplication. I can just copy 583,002 and write it in. I just have to make sure I line it up correctly. The 2 has to start right here, and then work your way to the left. So then you'd have 0, 0, 3, 8, and then 5. Okay, now I want to find the sum. And I know this looks like a cluster field, but basically, you can think of this 0 just coming all the way down. All the way down, okay? And if you wanted to, you could have just written some zeros in here. Okay, I could write zeros in there or here. Whatever you want to do to make you feel more comfortable. It doesn't matter. You get the same answer either way. Then we have zeros here, so that just comes down. Then we have a 1 plus 0 plus 0, that's just a 1. Then we have a 0 plus a 2, that's just a 2. Then we have 5 plus 0, that's 5. 1 plus 0 is 1. 9 plus 3 is 12, so put a 2 down and carry the 1. 1 plus 2 is 3. 3 plus 8 is 11, so put a 1 down and carry the 1. Lastly, 1 plus 5 is 6. So we're going to end up with 612,152,100 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on vertical multiplication. Okay, so for our problems today, we just want to find each product. We're starting out with 510 times 9. So to do this problem, we're going to use vertical multiplication. And we basically stack the numbers on top of each other and line them up by place value. As I taught you in the lesson, I typically take the number with more digits and put that on top, and the number with fewer digits and put that on the bottom. As I keep telling you, you may switch this if you'd like. Okay, so we start out with this number right here, the number on the bottom, and we multiply it by the rightmost digit of the number on top, and we work our way to the left. So we would say 9 times 0, that gives us 0. We just write the answer to that multiplication in the ones column. And then we work our way to the left. Now we have 9 times 1, that's 9. And we're just going to write our answer one place to the left. Then 9 times 5 is 45. And no more numbers to multiply over here. So we just write our answer down, and we get 4,590 as our answer. Next, we have 437 times 3. So 437 times 3. So same thing. I stack the numbers up vertically by place value, and I put the number with more digits on top, the number with fewer digits on the bottom. And again, we start out with this number right here, and we multiply it by the rightmost digit of the top number, and we work our way to the left. So 3 times 7 is 21. Now 21 is too big to fit in the ones place for the answer. So we're going to do our little carrying trick. We're going to put a 1 down, which is the rightmost digit of 21, and we're going to carry that 2, the leftmost digit, into the next column. Now, we're not going to use this 2 in any multiplication. We're not going to do that. This is just going to be added to the result of 3 times 3. So 3 times 3 is 9. Then we add 2, and that's 11. So we put a 1 down, and we carry a 1. Now, again, this 1 here that we carried will not be in any multiplication problem that we're doing. We're just going to add it along to the result of 3 times 4. So 3 times 4 is 12. Then add 1, we get 13. No more numbers over here, so I can just write 13 down. So we get 1,311 as our answer. Okay, for the last one, we have 1,064 times 2. 1,064 times 2. And this is a really easy one. We're just going to start again with 2 times the rightmost digit of this top number. So 2 times 4 would be 8, and we work our way to the left. 2 times 6 is 12, so we need to carry. We'll put a 2 down, carry a 1, and again, this 1 will not be involved in any multiplication. We're going to do 2 times 0, and that's 0, and then we're going to add that 1. Okay, so 2 times 0 is 0, plus 1 is 1. And then we have 2 times 1, that's 2. So we get 2,128 as our answer. Hello, and welcome to Pre-Algebra Test Section 2 on vertical multiplication. So for the problems today, we just want to find each product. We'll begin with 139 times 15. So as I taught you in the lesson, we're going to set this up vertically and by place value. So I take the number with more digits and put that on top, 139, and I put 15 on the bottom. Now, again, as I keep telling you in every video, you can switch that and put 15 on top and 139 on the bottom. Multiplication is commutative, so the order is not going to change it. I just personally find this method a little easier. Okay, so to begin our multiplication, we start with the rightmost digit of the bottom number, and we multiply it by the rightmost digit of the top number. So we would do 5 times 9, that's 45. We can't fit 45 into the ones column of the answer, so we write a 5 down, the rightmost digit, and we carry a 4 into the next column. Now we're working right to left, so next we're going to do 5 times 3, that's 15, and then we add the 4, what we carried over. So 5 times 3 again is 15, plus 4 is 19. So we put a 9 down and we carry a 1. Next we would do 5 times 1, that's 5, and then we would add the 1 that we carried over. So again, 5 times 1 is 5, plus 1 is 6. So basically the result of 5 times 139 is 695. Now, the next thing we're doing is we're moving to the left. Okay, we're moving to the left. And we're going to take this 1 and we're going to multiply it by 139, starting with the 9 and working our way to the left. But what we have to do is we have to start our answer for this multiplication one place over to the left. We're going to start our answer in this tens column. And the reason for that is because this 1 is not a 1. It's a 10 because it's in the tens place. So again, we do that to correct for the fact that this is not a 1, this is a 10. So we'll begin with 1 times 9. And again, 1 times 9 is 9. And we work our way to the left. 1 times 3 is 3. Then 1 times 1 is 1. Now what we're going to do here is we're going to add the two results that we got. Now you see that there's a blank space here. There's nothing here because we started our answer to the left. If you feel more comfortable, you can put a 0 there. Okay, you can put a 0 there. If not, we're just doing addition here, so you can just bring the 5 down if you want. 5 plus 0 will be 5 either way. It doesn't matter. So just bring that 5 down, and then 9 plus 9 is 18. Put an 8 down, carry the 1. 1 plus 6 is 7. 7 plus 3 is 10. Put a 0 down, carry the 1. Then 1 plus 1 is 2. So we end up with 2,085 as our answer. All right, next let's look at 14,275 times 24. So I'm going to write 14,275 on top, and I'm going to write 24 on the bottom. And we start at the rightmost digit of the bottom number being multiplied by the rightmost digit of the top number. And again, we work our way to the left. So 4 times 5 is 20. I'm going to put a 0 down and carry a 2. 4 times 7 is 28. Then I add the 2. That gives me 30. So put a 0 down, carry the 3. 4 times 2 is 8. Then plus 3 is 11. So we're going to put a 1 down and carry a 1. 4 times 4 is 16. Plus 1 is 17. So I'm going to put a 7 down, and I'm going to carry a 1. 4 times 1 is 4. Plus 1 is 5. So the result of 4 times this 14,275 is 57,100. Now we're moving to the digit to the left in this bottom number. So we're going to be multiplying this 2 by this number, working right to left. Again, remember, when we do that, we got to start by putting our answer in the tens column. So let me move over here. And again, another way to do that would just be to put a 0 here. You can do that, or you can put an arrow over, whatever you want, as long as your answer starts right here, because this 2 is a 20, it is in the tens place. All right, so now we do 2 times 5, that's 10. So there's going to be a 0 here, carry a 1. 2 times 7 is 14, plus 1 is 15. 5 down, carry a 1. 2 times 2 is 4, plus 1 is 5. 2 times 4 is 8. And then lastly, 2 times 1 is 2. And we're going to find this sum here. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 5 is 6. 7 plus 5 is 12. So we put a 2 down and carry a 1. 1 plus 5 is 6. Then plus 8 is 14. Put a 4 down and carry a 1. 1 plus 2 is 3. So what do we get? We get 342,600 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical multiplication. All right, so we want to find each product, and we have 116,315 times 472. So I'm going to stack these numbers on top of each other, line them up by place value, and as I tell you in every video, I take the number with more digits and put that on top. So 116,315, I'm going to put that on top. I'm going to put 472 on the bottom. And again, I know you get tired of me saying this, but you can flip the order of that and you will get the same answer. All right, so we start by multiplying. We take the rightmost digit of the bottom number and we multiply it by the rightmost digit of the top number, and then we're going to work our way to the left. So we're going to do 2 times 5, that's 10. So we need a carry there. We're going to put a 0 down. We're going to carry a 1. Now we're going to do 2 times 1. 2 times 1 is 2. Then we add 1, we get 3. Then we do 2 times 3. That's 6. We do 2 times 6, that's 12. So we need a carry. Put a 2 down, carry a 1. Then we do 2 times 1, that's 2. Plus 1 is 3. Then finally 2 times 1 is 2. So we have done 2 times this number, 116,315, and this is our result. Again, this is known as a partial product. Okay, a partial product. Now what we're going to do is we're going to move to the left in the bottom number, and we're going to be multiplying with this 7 here. Now because this 7 is in the tens place, it's really a 70. So when I say 7 times 5 is 35, I'm really saying 70 times 5 is 350. So to compensate for the fact that this is a 7 in the tens place, we slide our answer one space over to the left, and we start in the tens column. Okay. Now you can just start there, and you can put a 0 there if you want. You don't have to. A lot of students will put a 0 there. But really, remember what you're doing. You're going to end up adding this, and adding with 0 doesn't change the result. So I can just leave that blank if I want and just do my multiplication. So we're working right to left. 7 times 5 is 35. So put a 5 down, carry the 3. 7 times 1 is 7, plus 3 is 10. So put a 0 down, carry the 1. 7 times 3 is 21, plus 1 is 22. Put a 2 down, carry a 2. 7 times 6 is 42, plus 2 is 44. Put a 4 down, carry the 4. 7 times 1 is 7, plus 4 is 11. Put a 1 down, carry the 1. Then 7 times 1 is 7, plus 1 is 8. So if we look at what happened here, we basically multiplied 7 times 116,315. But again, really it wasn't a 7 because the 7's in the tens place. So I'm saying, hey, 70 times 116,315 is, and you think about this with a 0 because of the position of the number, 8,142,050. I just tell you that you can leave it off because essentially this is a partial product, so we're going to end up adding, and I can just drag that 0 down, or if I had a 0 here, when we add them together, it's still 0. It's not going to matter. Okay, so continuing, we're going to slide to the left one more time. So now I'm going to be working with this 4 here. The 4 is in the hundreds place. It's basically a 400. So I'm going to slide my answer one more space to the left, and I'm going to start right there in the hundreds place. So we're going to do 4 times 5, again working right to left. 4 times 5 is 20. So that's put a 0 down, carry a 2. 4 times 1 is 4, plus 2 is 6. 4 times 3 is 12, put a 2 down, carry a 1. 4 times 6 is 24, plus 1 is 25. Put a 5 down, carry a 2. 4 times 1 is 4, plus 2 is 6. Then lastly, 4 times 1 is 4. Okay, so now we're going to add. Okay, we're going to take these 3 partial products and add. And again, you could have put zeros in here, but you don't need them because when you add with 0, so 3 plus 0 would still be 3. Or 3 plus 5 plus 0 would still be 8. It doesn't matter if you put those zeros in there. So I'm just going to bring this 0 down. Again, as I just said, 3 plus 5 is 8, and then it can just come down. Then 6 plus 0 plus 0 is 6. 2 plus 2 is 4. 4 plus 6 is 10. Put the 0 down, carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 2 is 10. Put the 0 down, carry the 1. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 5 is 9. Then we have 8 plus 6, that's 14. Put a 4 down, carry the 1. And lastly, 1 plus 4 is 5. So we end up with 54,900,680 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on vertical multiplication. All right, so we just want to find each product. Okay, so for the only problem we're going to work today, we have 63,755 times 4,006. So we're going to stack these numbers up on top of each other and make sure they're lined up by place value. And again, if you wanted to switch this, you could. I always take the number with more digits and put that on top. I find that personally to be a little easier. Now, what are we going to do? We're going to start out in the rightmost digit of the bottom number, and we're going to multiply it by each digit of the top number working right to left. So in other words, we'd start with 6 times 5 and go that way. So 6 times 5 is 30. I would put a 0 down, and I would carry a 3. Now, as I keep telling you, this 3 has no part of the multiplication process. It's just something we're going to add on after. So we would do 6 times 5. That's your multiplication part. That's 30. And then you would add what you carried. So 30 plus 3 is 33. So put a 3 down and carry a 3. Next, we'd have 6 times 7. That is 42. 42 plus 3 is 45. So put a 5 down, carry a 4. 6 times 3 is 18. 18 plus 4 is 22. Put a 2 down, carry a 2. 6 times 6 is 36. Plus 2 is 38. No more numbers over here to multiply, so we just write 38. So essentially, 6 times 63,755 is 382,530. So that's kind of the first part of this problem. Now, we need to multiply every digit of this number by every digit of this number. Now, we work our way left in this bottom number. So next we come across this 0. Now, the beautiful thing about 0 is that when you multiply it by a number, you get 0 back, no matter what you multiply it by. Now, what I've been telling you is that whenever you move left in your problem, you move left as far as where you start your answer. So that 0 times 5 would start out there. Now, I don't need to go through and do each one because all of them would be 0. So I'm just going to put a single 0 there and move on to the next number to the left, which is also a 0. Also a 0. So that would start out in the hundreds column because that 0 is in the hundreds. So we moved 2 spaces to the left, and I do 0 times 5, and that's 0, and I could stop there because everything else would be 0. And so now I've made it all the way to this 4. Now, this 4 is in the thousands place. So we must start our answer for this 4 times 5 in the thousands place. So I'm going to make sure that's lined up properly. So that's going to start out right here. Okay, I'm going to start out right there. So we do 4 times 5, that's 20. So I'm going to put a 0 down, and I'm going to carry a 2 into the next column over. Next, I do 4 times 5. That's also 20, plus 2 is 22. So put a 2 down, carry a 2. 4 times 7 is 28, plus 2 is 30. Put a 0 down, carry a 3. 4 times 3 is 12, plus 3 is 15. Put a 5 down, carry a 1. 4 times 6 is 24, plus 1 is 25. And no more numbers over here, so I can just write that in. Now, we want to add our results. Okay, we want to add our results. It can be a little tricky. Basically, you just put a plus sign out here and just add the individual columns, and you'll get your result. If it makes you feel more comfortable, you can put zeros in here to kind of fill these voids. Put some zeros in here so that you're not so confused. So we'll put this here, and essentially you can see our addition now. So 0 is going all the way down. This is a 0. 3 plus 0 plus 0 plus 0 is 3. 5 plus 0 plus 0 plus 0 is 5. 2 plus 0 plus 0 plus 0 is 2. 8 plus 0 plus 0 plus 2 is 10. Put a 0 down, carry a 1. 1 plus 3 is 4. Then plus 0 plus 0 plus 0 is 4. And then this 5 can come down, this 5 can come down, and this 2 can come down. And we get our answer of 255,402,530. Hello and welcome to Pre-Algebra Test Section 5 on vertical multiplication. So we just want to find each product. Okay, for the only problem, we have 112,964 times 100,503. So I'm going to put 112,964 on top and 100,503 on the bottom. So as we begin, we take the 3, the rightmost digit of the bottom number, and we multiply it by the 4, the rightmost digit of the top number. 3 times 4 is 12. Put a 2 down and carry the 1. Next, we're going to take 3 and multiply by 6. We're working right to left. So 3 times 6 is 18. Then we add what we carried. Okay, so 3 times 6 is 18 plus 1 is 19. Put a 9 down, carry a 1. 3 times 9 is 27. 27 plus 1 is 28. So I'm going to put an 8 down, and I'm going to carry a 2. Next, I have 3 times 2, that's 6, plus 2 is 8. Then I have 3 times 1, that's 3. And then 3 times 1 again, that's 3. Okay, so I'm done with this one, and I'm moving to the left. Now, normally, when I move to the left, I would say, okay, now because I'm starting in the tens place here, I've got to move to the left when I write my answer. When I multiply 0 times this number, I get 0. 0 times 4 is 0, 0 times 6 is 0, 0 times 9 is 0, 0 times whatever you multiply it by is 0. And because we end up adding these results, I don't have to even put it in there. I can just skip this over. I don't need to do it whatsoever. I can go straight to this 5 here. Only thing I have to realize is that because this 5 is in the hundreds place, I have to move 2 spaces to the left to the hundreds, and that's where I'm going to start my answer. Okay? So when I multiply 5 times 4, I'm going to put the result right here. So 5 times 4 is 20. So I'm going to put a 0 down, and I'm going to carry a 2 into the next column. Now I have 5 times 6. 5 times 6 is 30. 30 plus 2 is 32. Put a 2 down, carry the 3. Now I have 5 times 9. That's 45. 45 plus 3 is 48. Put an 8 down, carry a 4. Now I have 5 times 2. That's 10. Plus 4 is 14. Put a 4 down, carry a 1. 5 times 1 is 5. Plus 1 is 6. And then 5 times 1 is 5. Okay? So one of the things you can do at this point is you can leave these 2 spaces blank because we end up adding, so these numbers could just come straight down. Or you could put some zeros in there if you want to. Put some zeros there, and you'd have 56,482,000. Now, this space to the left is a 0, and this space to the left is a 0. So we can just skip those over. We don't have to do anything with them because, again, 0 times this number is going to be 0. Then when we get over here, 0 times this number is going to be 0. And when you're adding, if I just had put in zeros, let's say I put a 0 in there, what's it going to do? It's not going to affect anything. So we can skip it over completely. So next we look at this 1. And this 1 is in the hundred thousands place. So we're going to start our answer for this in the hundred thousands place. So that's right here. That's right here. That's where we're going to start our answer. Now, another trick you can think about is 1 times anything is just itself. So do I really need to go through and say 1 times 4 is 4, 1 times 6 is 6, 1 times 9 is 9? No. I can just write this number, okay? Just maintain where you're going to start from as far as your place value. So this 4 will start in the 100,000s place. Then this 6 is going to go to the left of that, then the 9, then the 2, then the 1, then the 1. Okay? And if we want to, we can add some zeros in. And now we're ready to add. Okay? So we took something that was pretty tedious and we made it into something that's somewhat simple. So we have 2 plus 0 plus 0, that's 2. 9 plus 0 plus 0, that's 9. 8 plus 0 plus 0, that's 8. 8 plus 2 is 10, plus 0 is still 10. So I'm going to put a 0 down, carry a 1. 1 plus 3 is 4. 4 plus 8 is 12. Then plus 0 would still be 12. Put a 2 down, carry a 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 4 is 12. So put a 2 down, carry a 1. 1 plus 6 is 7. Then plus 6 is 13. Put a 3 down, carry a 1. 1 plus 5 is 6. 6 plus 9 is 15. Put a 5 down, carry a 1. 1 plus 2 is 3. And then this 1 can come down, and this 1 can come down to give us 11,353,220,892. Hello and welcome to Pre-Algebra Practice Set number 12. And in this video, we're going to look at some additional practice problems for our lesson on multiplication with trailing zeros. Okay, so for the problems we're going to look at, we want to just find each product. So we start out with 605 times 1,000. And essentially what I taught you in the lesson was it's really easy to multiply numbers together when there's trailing zeros involved. Trailing zeros, again, are zeros that occur at the end of a number. So in the number 1,000, we have 1, 2, 3 trailing zeros. In the number 605, we don't have any trailing zeros. We have a 0 here, but it's not at the end of the number. Right? We have the 0 and then we have a 5. So this is not a trailing zero. These, because they're at the end of the number, they're not interrupted by a non-zero digit. These are what we call trailing zeros. So these are the trailing zeros. And this right here is just a regular zero. So to multiply 605 by 1,000, we basically multiply the numbers together by cutting off the trailing zeros. Okay? So you would do 605 times just 1. And the result of that is 605. Then when you're done, you just attach the trailing zeros to the end of the number. It's just that simple. So I have 3 trailing zeros, so I put 1, 2, 3 trailing zeros to the end of this number, and I found my product. It's 605,000. Okay, for the next problem, we have 14,000 times 5,000, and this is a perfect example of when this little trick comes in handy. If you look at 14,000, we have 1, 2, 3 trailing zeros. If we look at 5,000, we have 1, 2, 3 trailing zeros as well. So to do this multiplication, I only need to multiply 14 times 5 and then attach 1, 2, 3, 4, 5, 6 trailing zeros to the end. So what's 14 times 5? Let's do that in vertical multiplication format. 5 times 4 is 20. Put a 0 down, carry the 2. 5 times 1 is 5, plus 2 is 7. So 14 times 5 is 70. So I put a 70 there. And then again, I'm going to attach 6 trailing zeros. So 1, 2, 3, 4, 5, 6. Comma, comma, and I end up with 70 million as my result. Okay, what if we did 522 times 19,000? So 522 does not have any trailing zeros in it, but 19,000 has 1, 2, 3. So essentially what I do is I multiply 522 by 19. And once I have the result of that, I can just attach the 3 trailing zeros to this answer. Okay, so I'd start with 9 times 2, that's 18. Put an 8 down, carry a 1. 9 times 2 is again 18. Now plus 1 is 19. Put a 9 down, carry the 1. 9 times 5 is 45. Plus 1 is 46. Now we're moving to the left and we're starting in the tens column. So when we do this 1 times 2, the result has to go in the tens column here. We got to move over to the left. So 1 times 2 is 2. Then 1 times 2 is 2. and 1 times 5 is 5. And again, when you multiply 1 times something, you just get that back. So I could have just wrote 522 in, just noting where I have to start, right? Noting that it had to have the rightmost digit fall in the tens column. Okay, so let's sum. Bring down the 8. 9 plus 2 is 11. Put a 1 down, carry a 1. 1 plus 6 is 7. 7 plus 2 is 9. 4 plus 5 is 9. So we get 9,918. Let's drag this up here. 9,918. And remember, we want to attach 3 zeros to the end of the number. 1, 2, 3. And now we have our product. We get 9,918,000 as the result. Okay, let's look at 906,000 times 13,200,000. So we got a lot of trailing zeros between the numbers. We've got 1, 2, 3 in this number. We've got 1, 2, 3, 4, 5 in this number. So when we multiply, we can just leave those off. So I'm going to multiply 906 times 132. And basically whatever we get, we're going to attach 1, 2, 3, 4, 5, 6, 7, 8. We have 8 trailing zeros that we're going to attach to the end of this answer. So 2 times 6 is 12. Put a 2 down, carry a 1. 2 times 0 is 0, plus 1 is 1. 2 times 9 is 18. So now I need to move to the left because I'm going to multiply, starting with this 3 that's in the tens column. 3 times 6 is 18. Put an 8 down, carry a 1. 3 times 0 is 0, plus 1 is 1. 3 times 9 is 27. Now I need to move to the left again. And I'm going to be multiplying in the hundreds column. And again, if I multiply 1 times something, I just get that back. So I'm going to just do 1 times 906. That's 609 like that, right? Because if I went through 1 times 6 is 6, 1 times 0 is 0, 1 times 9 is 9. 1 times anything is itself. So now we just need to add. So bring this down. 1 plus 8 is 9. 8 plus 1 is 9, plus 6 is 15. Put a 5 down, carry the 1. 1 plus 1 is 2. 2 plus 7 is 9. 9 plus 0 is still 9. 2 plus 9 is 11. So we're going to get 119,592. I'm going to bring this up here. And remember, I found that there were 8 trailing zeros. 1, 2, 3, 4, 5, 6, 7, 8. Remember, this number over here, just in case you get confused, this is not a trailing zero. It does not occur at the end of the number. All right, so 8 trailing zeros. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and put some commas in. So our answer here is 11,959,200,000,000. Okay, let's look at one final problem. We have 9,000 times 115 times 10,000. So even though we're multiplying 3 numbers together, the procedure is still the same. I have 1, 2, 3 trailing zeros here. I have 1, 2, 3, 4 trailing zeros here. And in this number, there's no trailing zeros. But all I really have to do is multiply 9 times 115 times 1. And then whatever I get for that, I'm just going to attach 1, 2, 3, 4, 5, 6, 7. There are 7 trailing zeros here to the end, and I'll have my product. So we know that when we multiply by 1, we get the same thing. So I can essentially just erase that. I don't even need it. So what's 9 times 115? 115 times 9. 9 times 5 is 45. Put a 5 down, carry the 4. 9 times 1 is 9. Plus 4 is 13. Put a 3 down, carry the 1. 9 times 1 is 9. Plus 1 is 10. So let me kind of erase this. I'm going to drag this up here. 1,035 was the result of this. And I want to put 7 zeros behind that 5. So 1, 2, 3, 4, 5, 6, and then 7. Comma, comma, comma. So we end up with 10,350,000,000. Hello and welcome to Pre-Algebra Test Section 1 on multiplication with trailing zeros. Okay, so we want to find each product. Okay, so for the only problem we're going to look at, we have 60 times 700. So I taught you in a lesson kind of a shortcut to do this. Realize that these numbers have what we call trailing zeros. So these are zeros that are at the end of the numbers. So for 60, you have one trailing zero. For 700, you have two trailing zeros. So between these two factors, we have three trailing zeros. Okay? So to multiply these numbers quickly, what you do is, for each number, you just kind of cut off the trailing zero, and you think about the numbers that would remain. So on the left, you just have a 6. On the right, you just have a 7. So you multiply those numbers. 6 times 7 is 42. And then when you're done, all you need to do is attach to the end of this the total number of trailing zeros between the two factors. So we had 3 trailing zeros, so we put 1, 2, 3 trailing zeros behind 42. And we get our answer for 60 times 700. It's going to be 42,000. Hello and welcome to Pre-Algebra Test Section 2 on multiplication with trailing zeros. Okay, we want to just find each product. And we have just one problem. It's 313 times 15,000. So when you multiply numbers and at least one of them has trailing zeros, you can use a little shortcut. So look at the trailing zeros in the number 15,000. And when I say trailing zeros, I mean zeros that occur at the end of the number. You have 3 of them. So to multiply this more quickly, we can cut these numbers off. Okay? Cut them off and just multiply 313 times 15. So 313 times 15. Whatever we get here, we just attach 3 zeros to the end of it and we'll have our answer. Okay? So 5 times 3 is 15. Put a 5 down, carry the 1. 5 times 1 is 5, plus 1 is 6. 5 times 3 is 15. Now, we're moving to the left in this bottom number. We're starting in this 1 here. And because that's in the tens place, our answer for this multiplication needs to start in the tens place as well. But realize we're doing 1 times everything here. We're doing 1 times 3, then 1 times 1, then 1 times 3. So I can just write 313 starting from the tens, right? I take the 3, then go to the 1. I'm working right to left, then go to the 3, because that would be the result. Okay, then we're going to add, bring this down. So we'd have 5. 6 plus 3 is 9. 5 plus 1 is 6. 1 plus 3 is 4. So 4,695 is what we get for this. Bring that guy up here. 4,695. And all we need to do is attach 3 zeros to the end of this number, and we're done. So our answer for 313 times 15,000 is 4,695,000. Hello and welcome to Pre-Algebra Test Section 3 on multiplication with trailing zeros. Okay, we want to just find each product, and we're only looking at one problem, 17,300 times 12,000. So when we multiply with numbers with trailing zeros, and when I say trailing zeros, I mean zeros at the end of the number. So in this case, 17,300, you have 1, 2 trailing zeros, and for 12,000, you have 1, 2, 3 trailing zeros. So when you work with numbers in multiplication that have trailing zeros, you can kind of cut the trailing zeros off and just think about the numbers that are there. So here you'd have 173. Here you'd have 12, okay? And you can just multiply those numbers together. And once you're done with that, you can just attach the total number of trailing zeros to the result. So we have 1, 2, 3, 4, 5. So we're going to attach 5 trailing zeros to our answer we get here. It's just going to be that simple. So 2 times 3 is 6. 2 times 7 is 14. Put the 4 down, carry the 1. 2 times 1 is 2, plus 1 is 3. Now we're moving left, and we're doing this 1 here. It's in the tens place, so we need to start our answer down here in the tens place. But realize this is a 1. So I'm basically multiplying 1 times 173. So that's really easy. I'm just going to put a 3 here, a 7 here, and a 1 here. Right? 1 times 3 is 3. 1 times 7 is 7. 1 times 1 is 1. Very, very easy. So now we add. Bring down the 6. 4 plus 3 is 7. 3 plus 7 is 10. Put a 0 down, carry the 1. 1 plus 1 is 2. So we get 2,076. I'm going to drag this up here, and I'm going to attach 5 zeros. 1, 2, 3, 4, 5, comma, comma. So we end up with 207,600,000 as our final answer for 17,300 times 12,000. Hello and welcome to Pre-Algebra Test Section 4 on multiplication with trailing zeros. Okay, so we just want to find each product, and we're looking at one single problem here. 105,000 times 100 times 3,000. Now, just because we have three numbers involved doesn't mean we can't use our regular trick for this. Remember, when you're working with numbers that have trailing zeros, and again, trailing zeros mean that there's zeros at the end of the number. So you have 1, 2, 3 here, you have 1, 2 there, and 1, 2, 3 here. If you're doing multiplication with these numbers, there is a shortcut. What you're going to do is you can cut off the trailing zeros. Okay? Cut off the trailing zeros. And think about what numbers would be left. So I'd have 105, I'd have 1, and I'd have 3. So you can multiply these numbers together. 105 times 1 is just 105. Then if we multiply by 3, 3 times 5 is 15. Put a 5 down, carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3. So this is 315. All I need to do, once I have this result, is attach the total number of trailing zeros to the end of this, and I'll be done. So if we count these out, I have 1, 2, 3, 4, 5, 6, 7, 8. So I would write 315, and then behind it, I would put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, comma, comma, comma. So what are we going to end up with? This is 31,500,000,000. Hello and welcome to Pre-Algebra Test Section 5 on multiplication with trailing zeros. Okay, so we want to just find each product, and we only have one problem here. We have 12,000 times 1,800 times 200. So pretty easy to multiply with trailing zeros. Again, trailing zeros are zeros that occur at the end of a number. So for 12,000, you have 1, 2, 3. For 1,800, you have 1, 2. And for 200, you have 1, 2. So if I look at the total number between all the factors, I have 1, 2, 3, 4, 5, 6, 7. So 7 trailing zeros between all the factors involved. So the shortcut that we have for multiplying with trailing zeros, basically you just kind of cut them off from each number, and you look at what number would be there if they didn't exist. Okay, and then you just multiply those together. So in this case, you'd have 12 times 18 times 2. Whatever you get for that result, you attach 7 zeros to the end, which is the total number from all the trailing zeros, and then you have your product. Okay? So what is 12? Let's start with 12 times 18, and then we'll multiply by 2. This is what we're doing. 12 times 18 times 2. So 8 times 2 is 16. Put a 6 down, carry a 1. 8 times 1 is 8, plus 1 is 9. Now I'm going to the left, and I'm going to this 1 here. So that means I got to go to the left here. Now I'm multiplying with a 1. 1 times anything is just itself. So the answer would be 12. And you put the 2 there and the 1 there. You basically work right to left. You'd have 1 times 2, that's 2. 1 times 1, that's 1. So now we're going to add. Bring down the 6. 9 plus 2 is 11. Put a 1 down, carry a 1. 1 plus 1 is 2. So I get 216, and now I need to multiply that by 2. 2 times 6 is 12. Put a 2 down, carry a 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. So the answer for this is 432. Now, what we've done is we've multiplied 12 times 18 times 2. And again, it's 432. 432. All we need to do now, remember we said there were 7 trailing zeros between all the factors. We just attach those zeros to the end of this number now. 1, 2, 3, 4, 5, 6, 7. And we have our answer for 12,000 times 1,800 times 200. And that's going to be 4,320,000,000. Hello and welcome to Pre-Algebra Practice Set number 13. In this video, we're going to look at some additional practice problems for our lesson on the properties of division. Okay, so we're going to start out with something pretty easy. We just want to label the parts of each division problem. So as you recall from the lesson, each division problem is made up of three parts. The dividend, or the left part of the division problem, basically the amount that you start with. The next part is called the divisor. That's the amount that we're dividing by. And then the final part is called the quotient. That is the result of your division operation. So the problem we're given is 14 divided by 7 equals 2. So this leftmost number here, 14, is what we're starting with. This is our dividend. Okay, this is our dividend. Next, we're dividing by the number 7. So we're saying how many equal groups of 7 can be made out of the number 14. So this 7 here is what's known as our divisor. Our divisor. Then lastly, the result of dividing 14 by 7 is 2. So 2 is known as our quotient. Okay, now let's look at 27 divided by 9 equals 3. So again, this number all the way on the left is called the dividend. Okay, 27 is the dividend. And again, that's the number we're starting with. That's the number we're going to split up. And in this case, we're dividing by 9. So we're going to split it up into equal groups of 9. So this 9 here, again, that's what we're dividing by. This is our divisor. And then 3 is the result of the division operation. This is the quotient. Okay, next let's look at 60 divided by 12 equals 5. So again, this leftmost number, this 60, is the dividend. The dividend, and that's what we start with. Then we divide by 12. Okay, 12 is going to be the divisor. The divisor. And again, we're saying how many equal groups of 12 can we make out of 60? And then the result of that is 5. So this is your quotient. All right, now we want to practice a few basic division problems. So we want to find each quotient. So we're going to start with 16 divided by 2. Now, a lot of you already know that 16 divided by 2 is 8. But what if you didn't? How would you figure that out? Well, I kind of talked about two methods you could use. Actually, there's a third. You could kind of draw out 16 boxes and then separate them into groups of 2 if you wanted to. You'd find that you have 8 groups of 2. You could use subtraction. So you could say 16 minus 2 equals 14. You could say 14 minus 2 equals 12. All I'm doing is subtracting out groups of 2 until I get to 0. 12 minus 2 equals 10. 10 minus 2 equals 8. 8 minus 2 equals 6. 6 minus 2 equals 4. 4 minus 2 equals 2. And 2 minus 2 equals 0. So you're seeing how many groups of 2 did I pull out of the number 16? So you would just count the number of subtraction operations you did. You did 1, 2, 3, 4, 5, 6, 7, 8. So 16 divided by 2 would be 8. Now, both methods that I just mentioned are completely absurd if you're trying to get an answer quickly, right? You're not going to sit there and list all this stuff out. You don't have time for that. So you need to use multiplication. So we know that 16 divided by 2 equals 8. Let's just start with that fact for a second. Now, I taught you in the lesson that the related multiplication is this times this. So 8 times 2 is going to give me this, 16. Now, knowing that, if I didn't know that the answer was 8, I could replace this with a question mark and replace this with a question mark and just use the times tables to get my answer. What times 2 equals 16? Well, all of us pretty much know that off the top of our heads. 8 times 2 equals 16. Even if you didn't, you could kind of, wander around a little bit and say, okay, well, 6 times 2 is 12, 7 times 2 is 14, and finally 8 times 2 equals 16. So once you get to that result, you know that 8 is the answer. All right, what about 12 divided by 4? And I won't bother with going through and doing subtraction. Let's do this using multiplication. So what number times 4 is going to be equal to 12? Okay, what number times 4 is going to give us 12? Well, most of you will know that the answer to that is 3. Right? The answer to that is 3. And if you didn't know that, you could go through and think about multiplying by 4. Well, we got 1 times 4, that's 4. We got 2 times 4, that's 8. And we got 3 times 4, that's 12. And we could stop there. What about 0 divided by 7? Do I need to go through and say, okay, question mark times 7 equals 0? No, I do not. Because I taught you in the lesson that when you take 0 and you divide it by any non-zero number, the result is always 0. And you can check that with multiplication. 0 times 7 equals 0. Yes, that's true. Going backwards, I could check that. But it's not necessary, again, because whenever you divide 0 by a number, let's say I did 0 divided by, I don't know, 1,362,411. Well, the answer is 0. All right, let's look at 7 divided by 0 now. So the one thing that I should draw your attention to is immediately you should say, I cannot have 0 as a divisor in a problem. So when I see that, I'm supposed to write that the answer is undefined. Okay? If you see 0 as a divisor, it's undefined. All right, what about 146 divided by 1? Well, that's another thing I taught you in the lesson. If you divide by 1, you get the number back. So 146 divided by 1 is just 146. And again, thinking about this, how many groups of 1 can I make out of 146? Well, I can make 146 of them. If you sat there and drew out 146 circles and said, well, how many groups of 1 can I make out of this? Again, you get 146. So dividing a number by 1 leaves the number unchanged. All right, now we have 327 divided by 327. And this is another thing that we learned. When we divide a non-zero number by itself, we get 1. Okay, so 327 divided by 327 is 1. Okay, let's look at some problems where we're going to have a remainder. So 13 divided by 2 equals what? Equals what? So when I have something with a remainder, I'm still going to use the same process to kind of figure out my division answer. I'm going to use multiplication, but I have to know that there's an additional step involved. So when I think about going backwards here, question mark times 2 equals 13. Those of us that know our multiplication tables pretty well know that there's no whole number that you can multiply by 2 to get to 13. So what I'd have to do is think about something that's going to get me close, but not go over. Okay? So the number 6 times 2 would give me 12. 6 times 2 would give me 12. That's close to 13, and it doesn't go over. If I add 1 to 6 and go to 7, 7 times 2 is 14. 14 is over 13, so I've gone too far, so I can't use this. So 6 is going to be used as the answer, but the problem is I have something left over. If I take 13, my dividend, and split it up into equal groups of 2, I can only get 6 of them. I'm going to have 1 left over, right? I'm going to have 1 left over. So I say I have a remainder of 1. Now, how do I know that I had 1 left over? Well, it's the difference between this and this, right? 13 minus 12 gives me 1. That's how I figured that out. Now, when you go through and you check a division problem where there's a remainder, you have to do more than normal. You'll multiply this right here, this 6, that's still considered the quotient, by 2. Okay, so you're still doing that part, but when you're done, you have to add your remainder. Okay, you add your remainder, so that's 1. So 6 times 2 is 12, plus 1 gives me 13, which is my dividend. What about 18 divided by 4? Okay, 18 divided by 4. So again, we're going to work backwards. What number times 4 gives me 18? Well, again, if you know your times tables well, you're going to know that there's no whole number that when you multiply it by 4 is going to give you 18. So I'm going to try to get as close as I can without going over. So I know that 4 times 3 is 12. I know that 4 times 4 is 16. And I know that 4 times 5 is 20. 20 is too much. That's over 18. So we have to go with 4 times 4, which is 16. So my result here is going to be 4, but because I've only kind of used 16, I'm going to have 2 left over, right? 18 minus 16 is 2, so I'm going to have a remainder of 2. And let's practice checking this. You're going to take this, that 4, and multiply it by this, also a 4. When we're done, we add our remainder, and that should give us this back. 4 times 4 is 16. 16 plus 2 is 18. That's exactly what we started with. So we have 25 divided by 3. So what are we going to do here? Again, let's work backwards. So if I did this, question mark times 3 equals 25. What's going to get me close? I know there's no whole number times 3 that's going to get me 25, but what's going to get me close? I know that 8 times 3 is 24. I know that 9 times 3 is 27. So I have to use 8 because that's close without going over. So I'm going to put 8 down as the answer, but there's a problem because I'm going to have something left over. 8 times 3 is 24. So if I make 8 equal groups of 3, I haven't used everything from my dividend, right? Because I started out with 25. I've only used up 24. I basically have 1 left over. So the remainder is 1. Again, just subtract. 25 minus 24 is 1. And then if I wanted to check, I'm going to multiply this times this. So 8 times 3. When I'm done with that, I add the remainder. And I should get this back. 8 times 3 again is 24. And we add 1 to that, and we do in fact get 25 as our answer. Hello, and welcome to Pre-Algebra Test Section 1 on the properties of division. Okay, so for the problems we're going to look at today, we want to label each part of the division problem as dividend, divisor, or quotient. So we're going to begin with 20 divided by 2 equals 10. And so basically the leftmost number of your division problem, that 20 there, that's the number you're starting with. That's the number you're going to divide up or split up or cut up, however you want to think about it. That is called your dividend. That is your dividend. Now, the next number, this 2, that's what we're dividing by. So when we think about this division problem, it's 20 divided by 2. How many equal groups of 2 can I make out of the number 20? So the number we're dividing by is known as the divisor. Okay, the divisor. And then finally we have this 10. That is the result of dividing 20 by 2. This is known as the quotient. Okay, so your result is the quotient. All right, next we have 10 divided by 1 equals 10. Again, the left number here, the 10, is the dividend. This is the dividend. We're dividing by 1. 1 is the divisor. The divisor. And then 10 is the result, so that is the quotient. Okay, now we have 0 divided by 5 equals 0. So 0, the leftmost number, is the dividend. The 5 here, what we're dividing by, is the divisor. And then 0, which is the result of the division operation, is the quotient. Okay, now we have 100 divided by 25 equals 4. So this leftmost number, this 100, is the dividend. Then the 25, what we're dividing by, is the divisor. And then 4, which is the result of the division operation, is the quotient. We'll finish up with 300 divided by 10 equals 30. Again, the left number here is the dividend. Then the number 10 here is the divisor. And then 30 is the quotient. Hello and welcome to Pre-Algebra Test Section 2 on the properties of division. So for the problems today, we just want to perform each division. And we're just going to divide some whole numbers here. Going to be very, very simple. We start out with 16 divided by 8. So most of you will know this off the top of your head. And 16 divided by 8 is 2. But what if you don't know that? So I always start by just putting a question mark there and thinking about the related multiplication statement. So this times this, okay? This times this, we know the answer is 2. 2 times 8 would give us 16. So this times this will give us this. Question mark times 8 equals 16. And then most of you know your times tables well enough to say, okay, well, I know that 2 times 8 is 16, so my answer here is 2. If you didn't, you could just kind of fumble around with what times 8. So you could say, okay, well, 1 times 8 is 8. 2 times 8 is, oh yeah, it's 16. So you could do it like that as well. All right, next let's look at 3 divided by 1. So for 3 divided by 1, I don't need to look at any related multiplication statement. When you divide a number by 1, you get the number. So 3 divided by 1 is 3. If I did 568 divided by 1, I'd get 568. If I did 2073 divided by 1, I'd get 2073. Basically, dividing by 1 leaves the number unchanged. So that's how I know 3 divided by 1 equals 3. All right, let's look at one final problem. We have 14 divided by 2. Now, a lot of us know that that's 7. But if you didn't know, again, you could use a related multiplication statement. So we could go backwards. So we'd say question mark times 2 equals 14. And you might not know that that's 7, so you could just kind of fumble around and say, okay, well, I know 5 times 2 is 10. I know 6 times 2 is 12. Oh yeah, 7 times 2 is 14. So again, the answer is going to be 7. Right? 14 divided by 2 is 7. And again, we found that by using the related multiplication statement, that 7 times 2 is 14. Hello and welcome to Pre-Algebra Test Section 3 on the properties of division. So for our problems, we just want to perform each division. And we're going to start out with 0 divided by 17. So when we think about 0 divided by 17, we think about the fact that 0 divided by any non-zero number gives us 0. So this answer will be 0. Next, we're looking at 12 divided by 12. For this one, we think about any non-zero number divided by itself gives us 1. So 12 divided by 12 would give us 1. And of course, this makes sense because we're saying here that I want to take 12 and split it up into equal groups of 12 each. Well, I can only make 1. Okay, let's look at 20 divided by 10 now. And there's no special trick here. A lot of you will know that this is equal to 2. But if you didn't know that, you would use a related multiplication statement to figure it out. So you would say this times this gives me this. Right? We know it's 2. 2 times 10 gives us 20. But again, if we didn't, we'd say question mark times 10 equals 20. Well, just kind of looking at that, knowing the times table for 10, well, yeah, you could kind of see, okay, well, yeah, it would be 2. If you didn't, you could just kind of fumble around. Well, 1 times 10 is 10. 2 times 10 is, oh yeah, 20. So that's how we know that 20 divided by 10 is equal to 2. Okay, what about 15 divided by 6? So 15 divided by 6 equals what? Again, let's use multiplication to figure the answer out. So question mark times 6 equals 15. So can you think of a whole number that multiplies by 6 and gives you 15? I can't. So that means we must have a remainder involved, meaning we can't make a whole number amount where there's equal groups of 6. Right? We can't do it. So what we're going to do is we're going to think about what times 6 would get us close to 15 without getting over 15. So if I think about 1 times 6, that's obviously 6. 2 times 6, that's 12. 3 times 6, that's 18. That's too big. Okay, that's too big. So we have to go with this one. That's 2. So if I have the number 15 and I split it up into 2 equal groups of 6, 2 equal groups of 6, that's 12, right? As we just demonstrated that 2 times 6 was 12. I'm going to have 3 left over, right? Because 15 minus 12 equals 3. This amount right here is my remainder. It's what I couldn't form another group with. So the remainder is 3. Okay, that's what we had left over. And when you want to check your division and there's a remainder involved, you need to do a little bit more work. Usually we can just multiply this number by this and we get this. Here we can't do that because there's a little bit left over. So we multiply this by this, so 2 times 6. When we're done, we add that remainder. So we add that remainder. This should now get us to this. So 2 times 6 is 12. 12 plus 3 is 15. And that makes sense because I had 15 and I split it up into equal groups of 6. I could only do that twice, so I only used 12 out of the 15. And I had 3 left over. So 2 times 6 was 12, and then I add back in the 3 that I had left over, and I get back to 15. Hello and welcome to Pre-Algebra Test Section 4 on the properties of division. So for the problems today, we just want to perform each division. And we're going to start by looking at 9 divided by 0. So think about this kind of carefully. What is 9 divided by 0? If we said 9 divided by 0 equals what times 0 would give us 9? Well, think about it. When I multiply 0 times anything, I get 0. So this number doesn't exist. And so that's why I taught you in the lesson, when you have 0 as a divisor, okay, as a divisor, you put that the division here is undefined. Undefined. All right, so next let's think about 711 divided by 1. And in the lesson, I taught you that when you divide by 1, you leave the dividend unchanged. So this will just be 711. Okay, what about 23 divided by 7? So for something like this, again, you just work backwards using multiplication. So what times 7 would give us 23? Well, using the times tables, there's no whole number that multiplies with 7 and gives you 23. 3 times 7 will give you 21. 4 times 7 will give you 28. You can't use 4 because that's going to be too big, right? 28 is larger than 23. So the best we can do is put 3 here, but that's not the full answer. Again, think about what division is doing. If I take 23 of something and I split it up into equal groups of 7, I would have 3 of those groups using 21 out of the 23. Okay, and again, I got that by just multiplying 7 times 3. That's how I know I'm using 21 out of the 23. The difference between 23 and 21 is 2. That's what's just left over. You can't make that into another group of 7 because you just don't have enough. So that's called the remainder. That's what's left over. It's the remainder. So your answer here would be 3 with a remainder of 2. And again, how you check this is you multiply the quotient, this part here, this 3, times your divisor. 3 times 7 is 21. And then you add your remainder. So plus 2, that gives you 23. It brings you back to what you started with. Hello and welcome to Pre-Algebra Test Section 5 on the properties of division. Okay, for the problems we're going to look at today, we want to perform each division. And we'll begin with 9 divided by 2. So again, to think about these, we use a related multiplication statement. So I don't know what the answer is. So I'm going to take this unknown, just going to put a question mark here, and I'm going to multiply by 2, and I'm going to arrive at 9. So can we think of a whole number that multiplies by 2 and gives us 9? Well, I can't. So that means we must have a remainder involved here. So if I think about kind of multiplying by 2, I know that 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So it can't be 5 because, again, 5 times 2 is 10. That's too big. That's more than 9. So we're going to have to go with 4 times 2, which is 8. Now think about what this is saying. I start out with 9 of something. Doesn't matter what it is. Let's say I have 9 pennies. And I want to split up or separate the 9 pennies into equal groups of 2. Well, what's going to happen is I can only separate it into 4 equal groups of 2. 4 equal groups of 2 using only 8 out of the 9 pennies. So I have 1 that's left over. That's called by remainder. Okay, I have 1 that's left over. I don't have enough to make another group of 2, so it's just kind of hanging out by itself. So the answer to this problem would be 4 with a remainder of 1. And remember, when we check these problems and they have a remainder, you have to do a little bit more work. Normally, you can just multiply your quotient times your divisor, so 4 times 2, and that will give you your dividend back. Because we have a remainder, that's not the case. I have to add this back in to get to this. And you'll see that 4 times 2 is 8. Then if we add 1, we do in fact get to 9, which was our starting value or our dividend. All right, what about 11,572 divided by 0? So can we start this problem and say, what times 0 equals 11,572? Is that what we would do? Think about it for a second. Do you know of a number that when you multiply it by 0 would give that to you? No, you don't, because when you multiply by 0, you get 0. So for this reason, I told you in the lesson that when you see 0 as a divisor, okay, when you are dividing by 0, you stop. You do not attempt to solve that problem. This is undefined. We do not divide by 0. All right, for the last one, we're going to look at 14,372 divided by 1. And again, I told you in the lesson, when you divide by 1, you leave the number unchanged. So this is just going to be equal to 14,372. Hello and welcome to Pre-Algebra Practice Set number 14. And in this video, we're going to look at some additional practice problems for the lesson that we did on long division. Okay, so let's take a look at 30 divided by 3. So remember how to set this up. You're going to take 30 and put it underneath that long division symbol that we use, and 3 goes out to the left. Now, we have some steps for long division, and I taught you a little trick to remember it. You have divide, which we use dad to remember that. We have multiply. We use mom for that. We have subtract. Okay, subtract. We have sister for that. Then we have bring down. Okay, bring down. And we used brother for that. Then lastly, we have repeat, repeat, or remainder. And we use the family dog Rover for that. Okay, Rover. And just something you can use again to remember the steps. It's divide, multiply, subtract, bring down, and then repeat or remainder. And again, use the family for that. Dad, mom, sister, brother, and then the family dog Rover. Okay, so with that being said, let's start our division. Now, with long division, you're breaking up your division into a series of steps. So you're basically attacking your dividend one digit at a time. You're going to start with the leftmost digit of the dividend, and you're going to ask how many times will the divisor go into the leftmost digit of the dividend. So 3 goes into 3 how many times? Meaning, what is 3 divided by 3? Well, that's easy. Any non-zero number divided by itself is 1, so the answer there would be 1. And again, in the lesson, I taught you about maintaining your place value when you're writing in your answers. So make sure you put that 1 directly over the number that you were working with. So we're working with 3. We put the 1 there, and then we multiply. So 1 times 3 is 3. Again, make sure to line up your answer with what you were working with. Then we want to subtract. 3 minus 3 will give us 0. Then we bring down. So we're always bringing down the digit to the right. So we're bringing down a 0. And this is going to be our number that we're working with now. 0, 0 is the same thing as just 1, 0. So this is just 0 in the end. And then we repeat or remainder. So we're going to repeat if we brought a digit down. If we didn't bring a digit down, meaning we had no more digits left to bring down, we would then stop and say, okay, if it's 0, there's no remainder. If it's not 0, then that's the remainder. So now we would ask the question, how many times does 3 go into 0? Meaning, what is 0 divided by 3? Well, 0 divided by any non-zero number is 0. So that's going to be our answer there. And when you write your answer, again, once I've put something there, all the answers in the future just go to the right. Okay, you just line them up to the right of that first digit that you put down. Now we multiply. 0 times 3 is 0. Then we subtract. 0 minus 0 is 0. And then we bring down, but there's nothing else over here. Okay, nothing else over here. So we get to the step that says repeat or remainder. We don't repeat because there was nothing else to bring down. So we would have a remainder if this wasn't 0. But because this is 0, basically 30 divided by 3 is 10 with no remainder. And we know that's true because these are relatively small numbers. We can kind of check them in our head. We know that 3 times 10 is 30, right? If I had 30 of something, I split it up into equal groups of 3, I would get exactly 10. Okay, let's take a look at 715 divided by 5. Again, your steps will be to divide. I'll just abbreviate these with the first letter. So divide, multiply, subtract, bring down, and then repeat or remainder. And again, dad, mom, sister, brother, and then Rover. So 715 divided by 5. And again, we're just going to start by asking the question, how many times will 5 go into the leftmost digit of that dividend? Again, we're going to attack the dividend one digit at a time. So 5 goes into 7 just once. Okay, just once. Again, just thinking about 7 divided by 5. I have 7 of something. I want to split it into equal groups of 5. I would get 1 with a remainder of 2. Now, when you're doing long division, you don't think about the remainder until the end. So you just put the quotient part. You don't think about the remainder part. So I would put 1 there. And it's important where I put the 1. notice how I put the 1 directly on top of that 7. You got to think about place value when you're using the long division process. Okay, so the 1 goes directly over the 7, which is what we were working with. Then we multiply. 1 times 5 is 5. That 5 is going to go directly underneath that 7 we were working with. And then we're going to subtract. 7 minus 5 is 2. Then we're going to bring down. And we're always bringing down the next digit to the right. So we bring down that 1. And then this R stands for repeat or remainder. So because we brought something down, we're going to just repeat the process and start dividing over. So now we would say, what is 5 into 21? What is 5 into 21? So basically, 21 divided by 5 equals what? What times 5 equals 21? Well, I know that 4 times 5 is 20, and I know 5 times 5 is 25. 25 is too big, so I'd have to go with 4. I'd have to go with 4. And again, I know that that would produce a remainder, but we don't worry about that until the end. So we put the 4 there, and we multiply. 4 times 5 is 20, and I want to put the 20 directly underneath the 21, and then I want to subtract. So 21 minus 20 is 1. Then bring down. Okay, bring down that 5. And then we're going to repeat the process. So 5 goes into 15 how many times? You're basically asking, what is 15 divided by 5? I think all of us know at this point that that is 3. Again, because 3 times 5 is 15. So that is 3. And now we multiply. 3 times 5 is 15. And I'm going to scroll down a little bit. That's 15. We subtract. 15 minus 15 is 0. And then we bring down. But there's nothing else over here to bring down. So we've come to our termination step, where it would say repeat, which we didn't bring anything down, so we're not going to repeat. Or remainder, which in this case we have a 0, so there is no remainder. We get 143. And essentially what this division problem, again, is telling us is that I had 715 of something. Let's say I had 715 boxes. I keep using that as an example. I split it up into equal groups of 5. I got 143 of those groups. And to check this is easy. You just take 143, which was the quotient, and multiply it by 5. 5 times 3 is 15. 5 times 4 is 20, plus 1 is 21. 5 times 1 is 5, plus 2 is 7. So we end up with 715, which is our dividend. All right, let's take a look at one with a remainder. So we have 291 divided by 4. And again, our steps are to divide, multiply, subtract, bring down, and then repeat or remainder. All right, so we would start by asking the question, how many times will 4 go into 2? Right, the leftmost digit of that dividend. 4 goes into 2. You could put a 0 here if you want, because technically if you do 2 divided by 4, you would get 0, remainder 2. So you could put a 0 there, and you could multiply and go, okay, well 0 times 4 is 0. You could subtract and get 2, and then bring down the 9, and then repeat. But I can get the same result if I just didn't put a 0 there, and I just kind of expanded my selection to just say, okay, well it doesn't go into 2. It's going to go into 29 how many times? So that's what we do. We just simply expand the selection when it doesn't go into the first or the second or the third number, so on and so forth. So now we can just ask the question, how many times will 4 go into 29? So 29 divided by 4 equals what? Well, what times 4 equals 29? Well, I know 7 times 4 is 28. 8 times 4 is 32. That's too big. So it's going to have to be 7. Now, what's important is, where am I going to put the 7 at? Am I going to put it over here? No, I'm not. Remember that we should have had a 0 there, but we just made the problem simpler, right? We would have had a 0 there, and then we would end up putting the 7 there. The reason you put the 7 here is because you're lining it up with the ones place of 29. That's the number we were working with. So the 7 is going to go there. Now, the next thing I'm going to do is I'm going to multiply. 7 times 4 is 28. And notice how I line the 28 directly underneath the 29. Then I'm going to subtract. Okay, so 29 minus 28, we all know that's 1. And then I'm going to bring down. So I'm going to bring down this 1. And I'm going to then repeat the process. So now I'm going to ask, how many times will 4 go into 11? So what is 11 divided by 4? Well, what times 4 gives me 11? I know 2 times 4 is 8. 3 times 4 is 12. So 2 is as big as we can go. So I'm going to put a 2 there. and I'm going to multiply. So 2 times 4 is 8, and then I'm going to subtract. 11 minus 8 is 3. And then I'm going to try to bring down, but there's nothing else over here. So then I've come to my last step, which is to repeat, which we didn't bring anything down, so we're not going to repeat, or remainder. And in this case, this is not a 0, so we do in fact have a remainder, an amount that's left over. And a lot of times we'll drag this back up here and put, okay, well, 72 remainder of 3. And again, if you want to check something like this, when you have a remainder involved, it's a little bit of extra work, because essentially what you said was, okay, I took 291 of something, I divided it into equal groups of 4, I found that I had 72 of those groups, and then I had 3 left over, right? I would need 1 more to get an additional group of 4. I don't have it. I just have 3 that are hanging out that are kind of, can't be made into another group of 4. So to check this, we would take 72 and multiply it by 4. This is basically what we used when we made the groups. So 4 times 2 is 8. 4 times 7 is 28. But we're not done because there's a difference here of 3. So the amount that was left over, the remainder, you have to add to that. So 288 plus 3, and 8 plus 3 is 11. 1 plus 8 is 9, bring down the 2. And in fact, you do get back to 291. So you multiply the quotient by the divisor, and then you add your remainder to that result. Okay, let's look at 1,275 divided by 12. So 1,275 divided by 12. So again, the steps are to divide, multiply, subtract, bring down, and then repeat or remainder. So just because we have a 2-digit number over here doesn't change our process. We're still going to ask how many times will the divisor go into the leftmost digit of the dividend. Well, we could put a 0 here, or we could just expand our selection. We're going to expand it to include the 1 and the 2. So basically I'm asking how many times will 12 go into 12 now? And the answer is once, right? If I have 12 of something, I want to make equal groups of 12, I can just do that once. So I'm going to put the 1 directly over the 2, right? If I think about the number 12, where's the 1's place? Well, it's where the 2 is, so that's where the 1 is going to go. And again, you can verify or think about, well, I would have had a 0 here anyway, so that 1 would have been to the right of the 0, so that's where it belongs. Okay, now we're going to multiply. 1 times 12 is 12. And again, line that up. Subtract. 12 minus 12 is 0. Then bring down. So the 7 comes down, and we repeat, right? We repeat. So 12 goes into 7 how many times? Well, it goes in 0 times, right? If I have 7 divided by 12, and think about this just using whole numbers. I have 7 of something. I want to make equal groups of 12. I can't even make 1. I can't do it. So the answer would be 0 with a remainder of 7. Again, we don't think about remainders until the very end here, so we're just going to put a 0 in. Now we multiply. 0 times 12 is 0. We subtract. 7 minus 0 is 7. We bring down. We bring down the 5. And then we repeat. 12 goes into 75 how many times? Well, we don't work with 12 that often. 12 times what would give us 75? That's what we're trying to figure out. So I know that 12 times 5 is 60. I know that 12 times 6 is 72. That's as close as we're going to get, right? Because 12 times 7 is 84. So I would put 6 here, and then I would multiply. 6 times 12 again is 72. Then we're going to subtract. 75 minus 72 is 3. Then we would bring down. But when we look up here, there's nothing else to bring down. So that brings us to our kind of termination step where we say, okay, repeat, which we're not going to do. We didn't bring anything down, or remainder. So this 3 is going to be your remainder. So we get 106 with a remainder of 3. Again, let's check it. So 106 times 12. When we're done, we add the remainder back in to get this dividend. So 2 times 6 is 12. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. 1 times 6 is 6. 1 times 0 is 0, and 1 times 1 is 1. Bring down the 2. 1 plus 6 is 7. 2 plus 0 is 2. Bring down the 1. So I get 1,272. And if I add the 3 to that, my remainder, my amount left over, I'm going to get 1,275. All right, let's take a look at one final problem. So we have 72,900 divided by 180. So 72,900, and that's divided by 180. So we've never worked with a divisor that's 3 digits, even in the lesson. So it's no different. Essentially what I'm going to do is I'm just going to expand my selection more. Because I'm going to start out, again, the steps are D, M, S, B, R. Divide, multiply, subtract, bring down, repeat, or remainder. Again, I'm going to start out with asking the question, how many times will the divisor go into the leftmost digit? I'm going to just remove that comma just for now. It's not going to, right? It's going to give me a result of 0, and so I can just kind of expand my selection. So then I would ask, how many times will it go into 72? Well, it's not going to. So I would expand my selection again. So how many times will it go into 729? Well, that it's going to go into, but I just don't know how many times. So 729 divided by 180 equals what? When we get large numbers like this that we're not used to working with, we have to make educated guesses. What times 180 would give me 729? If I think about 10 times 180, that's going to give me 1,800. That's way too big. But if I cut that in half, it's going to give me 900. So I know that 5 times 180, 5 times 180 is going to give me 900. Now we're trying to get 729, so this is still too big. But I can kind of use it for a basis to say, okay, I can mentally subtract away 180 from this, and I can see that that would work out, right? That would work out because that would put me at exactly 720. So 4 times 180 is 720. And again, check that using vertical multiplication if you don't believe that. So let's do that real quick. So 180 times 4. 4 times 0 is 0. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. Okay, 720. So that's as close as I can get to 729 without going over. So I put a 4 directly over that 9. Again, think about your place value. The 9 is in the ones place for 729. That's where the 4 is going to go on top of. Again, think about the fact that when we expanded our selection, we would have had a 0 here and here until we got there to put the 4. Now, we continue the normal way that we would have. And let me go ahead and just put the comma back in the number. We multiply. 4 times 180, again, is 720. We subtract. We know that 729 minus 720 is 9. Then we bring down, and then we repeat. So now we have 180 goes into 90 how many times? Well, again, using whole numbers, we can't do that. So we're going to end up with a 0. So again, 90 divided by 180 would give me 0, remainder of 90. So I put a 0 here. So we multiply. 0 times 180 is 0. We subtract. 90 minus 0 is 90. We bring down. So we bring down this 0 here. And then we're going to repeat, or again, remainder. So in this case, we brought something down. So we're going to repeat. So what is 180 into 900? Into 900. Well, if you remember back from when I did 180 times 10, I said that was 1800 or 1800. Then I kind of mentally just cut that in half in my head and said, okay, well, that's 900. Half of 10 is 5. So 180 times 5 is 900. So I already have my answer there. I already know that it's going to be 5. And again, you can use kind of tricks like this to make educated guesses quickly. Use your trick for multiplying with trailing zeros. I'll always start out with something like 10 or 20 or something like that, and then maybe cut it in half. There's a lot of good mental tricks that you can use to speed this up, especially if you get a test where you're not getting a calculator. Okay, so we know the answer is 5. Let's write that back in. That's going to go right here, and then we're going to multiply. 5 times 180, we know is 900. We subtract, that's 0. And then we'll bring down, but again, when we go up here to try to bring down, there's nothing else up here to bring down. So we know we've finished because it says repeat, which we're not going to do. We didn't bring anything down, or remainder. And we have a 0 here, so there's basically not a remainder. So when we think about 72,900 divided by 180, you get exactly 405. Hello and welcome to Pre-Algebra Test Section 1 on long division. So for our problems, we just want to find each quotient. Okay, for the first one, we're going to do 70 divided by 5. So we're going to start out by setting this up in long division format. So 70 divided by 5. Okay, now what are our steps for long division? So I taught these to you in the lesson. So the first thing you do is you divide, then you multiply, then you subtract, then you bring down, and then you're going to repeat, meaning go back up to division and go down, or you're going to have a remainder. You're going to have a remainder. And sometimes you won't have a remainder. Sometimes it'll be 0, and basically this just tells you, hey, we're done with the problem. So let's start out. We're going to start out at step number 1 where we divide. So we're always taking long division. Basically, you're thinking about the dividend by breaking it up into a digit at a time. So you're going to ask, how many times will 5 go into the leftmost digit of that dividend? In this case, it's the 7. So basically, 5 goes into 7 is the same thing as saying, what is 7 divided by 5? Well, 7 divided by 5 would be 1. Okay, would be 1 with a remainder of 2. Okay, 1 with a remainder of 2. But when we're working with long division, we don't think about the remainders until the very end. So you just put the quotient part. So we would say 5 goes into 7 just once, and then we multiply. So we're going to multiply the 1 times the divisor. So our answer times the divisor, 1 times 5 is 5, and we put it directly beneath that 7 that we were just working on. Now we're going to subtract. 7 minus 5 is 2, and then we bring down. And when we say bring down, we bring down the next digit to the right. So now we have the number 20, and this is what we're going to work with when we say repeat or remainder. We're not going to have a remainder yet because we're not done, so we're going to repeat. So we basically just go back up and we divide. So now we're looking at 5 goes into 20, okay? And that's basically the remainder from our first division, and then we tacked on the 0 to get that number 20. So 5 goes into 20 how many times? Well, it's going to go in exactly 4 times. Now we multiply. 4 times 5 is 20. Then we subtract. 20 minus 20 is 0. We go to bring down, but there's nothing else over here. So now instead of the repeat, we go to remainder. And the remainder is basically 0, meaning we just don't have one. So we're done with our problem. 70 divided by 5 is 14. And again, to check your division, use multiplication. Remember, you can go backwards. So if 70 divided by 5 equals 14, that means 14 times 5 should equal 70. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7, and we do get 70. All right, next let's look at 312 divided by 4. So 312, and we're dividing this by 4. And again, our steps would be to divide, and I'm just going to put the first letter of the word. So D, multiply, M, subtract S, bring down B, and then repeat or remainder R. And again, a lot of people just remember this using the family. Dad, mom, sister, brother, and then Rover is the dog. Okay, so we will start our division by dividing. So we'll say, how many times does the divisor go into the leftmost digit, 3? So essentially, I taught you in the lesson, if the answer is going to be 0, you can just expand your selection. Because if you say, what is 3 divided by 4, you get 0 remainder of 3. Okay? In other words, thinking about this with the boxes, if I had 3 boxes, and I said, how many equal groups of 4 can I make? Well, if I'm not using fractions or decimals, I can't make any, right? I can't make any. I don't have enough to make a group of 4. So the answer would be 0. And so what we do is we expand this to include the 3 and the 1. So now we're going to ask the question, how many times does 4 go into 31? So 31 divided by 4 equals what? Again, turn that around. What times 4 equals 31? 8 is going to be too big, so we're going to go with 7. Okay, we're going to go with 7. Now, where do I put my answer? Do I put the 7 here? No, I do not. Remember, we should have had a 0 here, but we kind of used a shortcut, so we got to make sure that we put the 7 on top of that 1. Just think about this number 31. Where's the 1's place? The 1's place is here, where that 1 is. So we're just lining the 7 up with the 1's place from 31. Okay, now we're going to go through and multiply. And we take the answer here that we got, and we're going to multiply it by the divisor. 7 times 4 is 28. line that up with the 31 we were just working with, and then we subtract. 31 minus 28 is 3. Now we're going to bring down, so we bring down that 2 there. And basically we repeat, so we go back up to the top. So now we're going to divide. 4 goes into 32 exactly 8 times. 8 times 4 is 32. Subtract, you get 0. And at this point, there are no more numbers to bring down. So this would be our remainder if we had one. It's 0, so there is no remainder, and we stop. So 312 divided by 4 is exactly 78. And again, if you want to check that, just use multiplication. So 78 times 4 should give us 312. 4 times 8 is 32. 4 times 7 is 28, plus 3 is 31. And of course, we do get 312 as our result. Okay, for the last problem, we look at 121 divided by 11. So 121 divided by 11. And again, our steps are going to be to divide, multiply, subtract, bring down, and then repeat or remainder. Dad, mom, sister, brother, Rover. So 11 goes into 1 how many times? Well, it's going to be 0. So we're going to move on, and we're going to expand our selection to include the 1 and the 2. So we're going to ask, how many times will 11 go into 12? It goes in just once. So where we're going to put the 1 at? Are we going to put it right here? No, of course not. Because remember, we would have had a 0 here if we would have went through and said, okay, 11 goes into 1 0 times, went through the multiplication, all that stuff. We'd ended up asking, how many times does 11 go into 12 anyway? So we make a shortcut and we just say, okay, how many times does 11 go into 12? It goes in once. So we put that 1 into the ones column for 12. Okay, it's got to line up there. Now we multiply. 1 times 11 is 11. And line that guy up underneath the 12 that you're working with and subtract. 12 minus 11 is 1. Then we bring down. Okay, bring down that 1. And then we're going to repeat. So we go back up to division. 11 goes into 11 how many times? Well, any number divided by itself, except for 0, is going to be 1. So I'm going to put a 1 there. Then I'm going to multiply. 1 times 11 is 11. Subtract, you're going to get 0. Nothing else to bring down. And so our remainder is 0. So we know that 121 divided by 11 is 11. So again, we can check this. 11 times 11. 1 times 1 is 1. 1 times 1 is 1. Move over. 1 times 1 is 1. 1 times 1 is 1. Just do some addition. This comes down. This will be 2. And this is 1. So we do, in fact, get 121 as our answer. Hello, and welcome to Pre-Algebra Test Section 2 on long division. Okay, for the first problem, we have 197 divided by 12. So set this up in long division format, 197 divided by 12. And remember your steps. You're going to divide. You're going to multiply. You're going to subtract. You're going to bring down. Then you're going to repeat, meaning go back up to divide and start over, or you're going to have a remainder. And including that would be, if you didn't have a remainder, let's say the remainder is 0. Basically, this part just tells you, hey, I didn't have anything else to bring down, so I'm done with the problem. Okay, so remember, there's a trick to remembering that, and you basically just use your family members. Divide, we would say dad. Multiply, we would say mom. Subtract, we'd say sister. Bring down, we'd say brother. And then repeat or remainder, you use the family dog Rover. All right, so let's start out with divide, our first step. And we look at 12, our divisor, and we ask how many times will it go into this leftmost digit of the dividend. Okay, we're taking this basically 1 digit at a time. So 12 goes into 1 0 times. So essentially I can put a 0 here, or as I told you in the lesson, I can just expand my selection to 19. Now I would ask, how many times does 12 go into 19? Well, it's going to go in only once. Okay, only once. Because if I think about 12 times 1, I would get 12. 12 times 2 would be too large. It would be 24. That's bigger than 19. So it has to be 1. Now I want you to notice where I wrote that 1 at. I wrote it directly above the 9 because remember, this is the ones place for the number we're working with, which is 19. So you got to line that 1 up. Another thing you can think about is I would have had a 0 here if I wouldn't have used my shortcut. when I said 12 goes into 1 0 times, I would have put a 0 there. Remember, a 0 to the left of this 1 doesn't change the value of the number. So I can just erase it. I don't need it. Now, let's go through our steps. We've done the division. Now we want to multiply. So we take our answer, multiply by the divisor. 1 times 12 is 12. And we're going to write it underneath the 19 that we were working with. So now we're going to subtract. 19 minus 12 is 7. Then we bring down. So bring this 7 down. And now we're going to repeat. Right? We're going to repeat. So bring this back up here and think about, okay, now I have 12 goes into 77. How many times? So 77 divided by 12 equals what? What times 12 equals 77? So some of you know the times tables for 12. Some of you don't. A lot of you will know that 5 times 12 is 60. So 6 times 12, if you just added 12 more to 60, would be 72. That's going to be as close as we can get. So we're going to put a 6 here. And then we're going to just follow our steps. We're going to multiply. 6 times 12, as we just said, is 72. We're going to subtract. 77 minus 72 is going to be 5. And then we're going to bring down. But there's nothing else over here to bring down. So we come to our last step where normally we would repeat. But in this case, we can't repeat because we didn't bring anything down. So we go to this remainder. So 5 is what's left over. And again, just think about what's happening when you perform a division. You're taking 197 and you're saying, hey, split this up into equal groups of 12. Well, I made 16 of those. So let's think about 16 times 12. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. Then moving to the left, 1 times, basically think about this 1 times 16, because 1 times anything is just itself. I can just write a 6 and then a 1 here. Bring the 2 down. 3 plus 6 is 9. Bring down the 1. So I only used 192 out of the 197 items that I had, okay, when I split it up in equal groups of 12. What happens is this 5, the difference between 197 and 192, is just what's left over. I have 5 more items just hanging out. And to make another group of 12, I would need another 7. I don't have it, so this is just a remainder. Okay? So again, if you were to check something like this, you'd go through a multiply, then add your remainder back in, and you get back to the dividend. Okay, for the next one, we have 1,505 divided by 301. So 1,505 divided by 301. Again, your steps: divide, multiply, subtract, bring down, and repeat or remainder. Dad, mom, sister, brother, Rover. So take the 301 and ask how many times will it go into the leftmost digit. It's not, so we can put a 0 here if we want and go through all the steps, but essentially the shortcut is just to expand the selection. So we can say, okay, well, how many times will it go into 15? It's not going to. How many times will it go into 150? It's not going to. So we have to go all the way out and use the entire dividend and say how many times will 301 go into 1,505 or 1,505? Well, to answer that question, since these are relatively large numbers, we kind of have to take an educated guess. So 1,505 divided by 301 equals what? Now I can eyeball this and see the answer, but you might not be that good at mental multiplication. So if you think about what times 301 equals 1,505, just kind of estimate, okay? Just think about 301 as 300. Now we've got some trailing zeros going, and I can say, okay, well, so what times 300 would get me close to 1,500? Well, 5 would. 5 times 3 is 15, and then just attach 2 zeros to the end. Now, one thing you can see if you eyeball, 5 times 1 is 5, so it looks like that's going to work out perfectly. Right? If we do 301 times 5, 5 times 1 is 5, 5 times 0 is 0, 5 times 3 is 15, so we do in fact get 1,505. So we come back up here, and we think about what goes here. Well, we're going to put a 5, and notice where I put it. I put it, since we use the entire number here, I'm thinking about the ones place for the entire number, which is the 5, and I'm lining it up there. And alternatively, you could have think about, okay, well, I would have had a 0, a 0, and a 0 here if I didn't use the shortcut. So make sure you line that up correctly. Now we're going to multiply. 5 times 301 is 1,505. We're going to subtract. We get 0, nothing to bring down. So we have no remainder. Essentially, 1,505 divided by 301 is 5. And again, we could check that with multiplication, but we basically just did the problem. So we know we have the correct answer here. Hello and welcome to Pre-Algebra Test Section 3 on long division. So we want to find each quotient, and we just have one problem to do. We're looking at 1,444,014 divided by 7,722. Let's look at our steps for long division. Again, we want to start out by doing some division. So I put divide. Then we want to multiply. Then we want to subtract. Then we want to bring down. Okay, bring down. Then we want to repeat the process, meaning go back up to divide, or remainder. All right, so let's set up the long division here. 1,444,014, and then 7,722. I'm going to remove these commas just for a second. We would start by asking, how many times will this divisor go into this leftmost digit? It's not going to go. So we could put a 0 here and go through all the steps. But essentially what's going to happen is the shortcut is just expand the selection until you find something that it's going to go into. Not going to go into 14, not going to go into 144, not going to go into 1,444. It will finally go into this number right here, 14,440 divided by 7,722. We can do that. Okay, so how do we guesstimate something like this? Well, I could take 7,722 and just kind of eyeball and look at it and say, okay, well, at most, this is going to go in to 14,440 twice, at most. So we'll multiply this by 2 and see what we get. If it's more than this, we're just going to use 1. 2 times 2 is 4. 2 times 2 is 4. 2 times 7 is 14. 2 times 7 is 14 plus 1 is 15. So we get a number or a value that is larger than this. So we're going to have to use 1 because that will not go over. Okay, so we're going to use 1. Now again, where are we going to write the 1 at? We're going to write it directly over the 0, which is in the ones place for this number that we have, 14,440, right? The one that we are using for our division. Now, let's erase this real quick and we'll put our commas back into the number. And let's go through the steps. We want to multiply. 1 times 7,722 is 7,722. Now you have to line this up properly. So the 2 is in the ones place. This 2 is in the tens place. This 7 is in the hundreds place. And this 7 is in the thousands place. And again, we're just thinking about this number right here. Everything is relative to that, which we created right now. Okay, so we're going to subtract. 0 minus 2, we need to borrow. So this becomes 3. 10 minus 2 is 8. 3 minus 2 is 1. We'll borrow here. This will become 14. Then we'll take 1 away and it'll become 13. So then this will become 14. 14 minus 7 is 7. And then 13 minus 7 would be 6. So we get 6,718. Okay, so now we're going to bring down. And we're going to repeat. So now we're going to divide. We have 7,722 going into 67,181. So these are big numbers. So again, you have to use some guesstimation. So let's scroll down a little bit and just think about 7,722 times what would give me this number. Well, if I drop the 22 off and just kind of think about this number as 7,700, I have some trailing zeros here, so it becomes easier to multiply by some numbers to get close. So let's think about if I multiply this by 6, what would that give me? 6 times 0 again is 0. 6 times 0 is 0. 6 times 7 is 42. 6 times 7 is 42 plus 4 is 46. So we get 46,200. That's pretty low. So we're going to adjust our guess. And I'm going to adjust it to 9. So 9 times 0 is 0. 9 times 0 is 0. 9 times 7 is 63. 9 times 7 is 63 plus 6 is 69. So we get 69,300. That's too big. So I'm going to adjust my guess again down to 8. And that's in fact going to work. Right? So 8 times 0 is 0. 8 times 0 is 0. 8 times 7 is 56. 8 times 7 is 56 plus 5 is 61. So we get 61,600. That's as close as we can get to this without going over. So we're going to use 8 as our answer. Put an 8 right there. And let me kind of erase all this stuff. So we do our multiplication. 8 times 7,722, as I just showed you, was 61,776. Now we're going to subtract. So borrow from the 8. 11 minus 6 is 5. 7 minus 7 is 0. Borrow from the 7. 11 minus 7 is 4. 6 minus 1 is 5. So we end up with 5,405. 5,405. And now we're going to bring down. Bring this 4 down to give us 54,054. And then one more time, we're going to repeat this and do a division. So 54,054 divided by 7,722. What would that give us? Well, looking at this, which is the result of multiplying 7,722 by 8, it looks like I can get away with multiplying it by 7. Seems like that would be close without going over. So let's check that out. So we would have 7,722 times 7. 7 times 2 is 14. 7 times 2 again is 14, plus 1 is 15. 7 times 7 is 49, plus 1 is 50. 7 times 7 is 49, plus 5 is 54. So we actually end up with the exact amount, 54,054. And so 7 will go up here. We'll multiply. 7 times 7,722, as I just told you, is 54,054. We'll subtract. We get 0. Nothing else to bring down, and basically we're done. Our remainder here is just 0. We don't have our remainder. So 1,444,014 divided by 7,722 is exactly 187. And if you want to check this, just go through and do a vertical multiplication. Do 187 times 7,722, and you will get this back, the 1,444,014. Hello and welcome to Pre-Algebra Test Section 4 on long division. Okay, we just want to find each quotient, and we're only going to have one problem here. We're going to take a look at 996,325 divided by 703. So let's set this up in long division format. 996,325 divided by 703. So the steps for doing a long division, as I've told you, you have divide, multiply, subtract, bring down, and then repeat or remainder. And a lot of people say dad, mom, sister, brother, and then rover, kind of thinking about the family, to remember the steps. All right, so we're going to start out by asking how many times will the divisor, which is 703, go into the leftmost digit of this number? Well, it doesn't, right? So you can put a 0 here and go through the steps, or you can kind of just expand your selection. Either way, you're going to get the same answer. You're going to end up with zeros to the left of your first non-zero number, and it wouldn't change the value. Meaning if I had something like 001, that's still 1, right? I can just drop the zeros off. So kind of the shortcut would be just expand the selection and just say, okay, well, how many times would 703 go into 99? Well, it wouldn't. So I would expand my selection again and say, well, how many times would 703 go into 996? Well, just once. Okay, just once. All right, so and think about why I put that 1 directly over the 6. Well, I would have had a 0 here and a 0 here, so my 1 would have laid there. But another way to think about it is, you're working with the number 996. Where's the 1's place for that number? It's going to be the 6 there. So you're going to line up the 1 with the 1's place, so it will go over that 6. Okay, so now let's go through and do the steps. We're going to multiply. So we take 1 and multiply it by 703. That gives us 703. And then we subtract. So 996 minus 703. 6 minus 3 is 3. 9 minus 0 is 9. 9 minus 7 is 2. So now we're going to bring down. So you always bring down your next digit to the right. So you bring down this 3. And basically the R tells you repeat or remainder. In this case, we have something new to work with. So we're going to repeat. We basically go back up to the top and we start dividing again. So we say, how many times will 703 go into 2,933? So 2,933 divided by 703 is equal to what? Well, working backwards, think about what would get me close. What times 703 would get me close to 2,933 without going over? But when we work with larger numbers than say single digit or 2-digit numbers, we kind of have to guesstimate a little bit. So if I think about what 5 times 700 would be, that's 3,500, that's too big. So what about 4 times 700? That's 2,800. So if I think about 703 times 4, I think that would work. 4 times 3 is 12. 4 times 0 is 0, plus 1 is 1. 4 times 7 is 28. So 2,812. So we're going to use a 4 as the answer because 5 would be too big. Okay, let's go up here. So we're going to put a 4 here. Then we're going to follow the steps again. We're going to multiply. 4 times 703, because I just showed you was 2,812. Then we subtract. 3 minus 2 is 1. 3 minus 1 is 2. 9 minus 8 is 1. So now we're going to bring down. We have this 2 to bring down. And we have 1,212. And we're going to repeat the process now. So we go back up to division. And we say, how many times will 703 go into 1,212? Now, just from estimation, I know that if I double 700, I get 1,400 or 1,400. That's too big, okay? So this will only go into this one time, just once. 1 times 703, following the steps, would give me 703. Then subtract. This will become 12. 12 minus 3 is 9. 0 minus 0 is 0. Borrow here. 12 minus 7 is 5. So we get 509. Now we want to bring down. And for one last time, we're going to repeat. And we're going to ask, how many times will 703 go into 5,095? So how many times will 703 go into 5,095? I'm going to just think about 703 as 700, so I can kind of guesstimate a little bit. So 5 times 700 is 3,500. And again, you can do that in your head by thinking about the trailing zeros. 5 times 7 is 35. Put 2 trailing zeros in the end, it's 3,500. So that's too small. Let's say I go with 7. 7 times 7 is 49. Put 2 zeros at the end, it's 4,900. That's about as close as I'm going to get to this. So let's think about 7 times 703. 7 times 703. 7 times 3 is 21. 7 times 0 is 0, plus 2 is 2. 7 times 7 is 49. So 4,921. 4,921. Let's come back up here and write a 7, and then multiply. 7 times 703, as I just showed you, was 4,921. And then we're going to subtract. 5 minus 1 is 4. 9 minus 2 is 7. We'd borrow here. 10 minus 9 is 1. And we go back up here to bring down. Nothing else over here. So remember, the last step says repeat or remainder. So if we had something else to bring down, we would repeat. But there's nothing else to bring down, so we just consider this last amount here the remainder. So we have 174 left over. So again, think about what this is saying. I had 996,325 of something. Let's say there were boxes. I keep saying that. We split it up into equal groups of 703. What I was able to form is 1,417 of these groups. And then essentially I had 174 of them. I had 174 boxes just left over. I can't make another group of them because I need a 703 to make a total group. So that is just my remainder. Now, if we wanted to check this, what we do is we take 1,417, we'd multiply it by 703. And then once we have that result, we'd add the remainder to it. So plus 174, and that would get us back to this dividend here. Hello and welcome to Pre-Algebra Test Section 5 on long division. All right, so we want to just find each quotient. And we have 13,576,282 divided by 111. All right, so let's set this up in long division format. So 13,576,282. Again, we're dividing this by 111. Now remember your steps when you're doing a long division. You have divide, multiply, subtract, bring down, and then repeat or remainder. Again, kind of the trick that everyone uses is dad, mom, sister, brother, rover. Right? So you think about the family. Okay, so we begin by looking at the divisor and asking how many times will it go into the leftmost digit of the dividend. So as I've told you in probably every video, you could put a 0 here if you wanted to, because 111 is not going to go into 1, okay, when we think about using whole numbers. So you could put a 0 there and you could multiply and subtract it, but what's going to happen is you're going to end up with all that, a 13 here, just the same thing as if you expanded that. So you can kind of use a shortcut and just say, okay, well, it's not going to go into 1, so we just expand and say, will it go into 13? Not going to go into 13. Will it go into 135? Well, the answer is yes. It will go into 135 just once, though. So I put a 1 here directly above the 5. Again, thinking about the number 135, the 5 is in the 1's place. That's where we want to put our 1. Alternatively, you could say, well, I skipped this over. This should have been a 0. I skipped this over. This should have been a 0. So my 1 would have been right there. Either way, again, you put the 1 directly on top of that 5. Okay, now we multiply. 1 times 111 is 111. Then we subtract. 5 minus 1 is 4. 3 minus 1 is 2. And then we bring down. So bring down this 7 here. And then we repeat. So we go back up and we divide. So now we're going to ask how many times will 111 go into 247? That's going to be twice, right? You think about 111 times 2. It's all ones up here, so it's pretty easy to do. You're going to end up with 222. Right? You can kind of do that in your head. 2 times 1 is 2, 2 times 1 is 2, 2 times 1 is 2. 222. Okay, so we go through and we multiply. 2 times 111 is, again, 222. We subtract. 7 minus 2 is 5. 4 minus 2 is 2. And then we bring down. So now we're going to bring down a 6. So we have 111 goes into 256. Again, that's going to be twice. Because I can eyeball this and say, okay, I know 3 times 111 is 333. Again, you're multiplying by a 1, a 1, and a 1. So if I multiplied by 3, I get 333. Now, again, using this, I know that the answer is going to be 2. 2 times 111 would give me 222. We subtract. 6 minus 2 is 4. 5 minus 2 is 3. And then we bring down. So bring down this 2. And I'm going to be scrolling back and forth, so I apologize if anything gets cut off. Hopefully you have this written down on your paper and you can keep up. So 111 now is going to go into, and let me scroll down, 342 how many times? So 342 divided by 111 equals what? Well, as I just showed you, 111 times 3 would be 333, right? 3 3s in a row. That's as close as we can get to 342 without going over, because 111 times 4 is going to be 444. So we're going to put 3 as our answer. Come back up here, put a 3, and we multiply. 3 times 111, as I just said, was 333. Subtract. We're going to borrow here. 12 minus 3 is 9. And then these would both be 0. 3 minus 3 is 0. 3 minus 3 is 0. So we have a 9 there. So now we're going to bring down again. So we have this 8 that's coming all the way down here. All the way down here. And then we want to repeat. So 111 goes into 98 how many times? Well, it's going to be 0. If I have 98 of something and I try to split it up into equal groups of 111, using whole numbers, I can't do that, right? So the answer would be 0. So I put a 0 here, and then I go through the steps. I multiply. 0 times 111 is 0. So this is 0. And I know it's cut off, but the next step is to subtract and then bring down. So this will be 98. And then we bring down. So I have this 2 here to bring down, all the way down here. All the way down here. So we have a 2 there. And basically the next step is to repeat, right? The R. So how many times will 111 go into 982? Well, that's pretty easy. I know that 111 times 9 is 999. 9 times 1 is 9, 9 times 1 is 9, 9 times 1 is 9. Again, you can do that in your head. So that's too big. That's bigger than 982. So it has to be 8, right? It has to be 8. So we'll put an 8 as our answer right here. And then we multiply. 8 times 111 is 888. 888. Again, easy to do that in your head because you're just multiplying by 1. 8 times 1 is 8. 8 times 1 is 8. 8 times 1 is 8. So subtract here. We'll borrow from the 8 and get a 7. This becomes 12. 12 minus 8 is 4. Borrow from the 9 and get an 8. 17 minus 8 is 9. So we end up with 94. And when we look back up here, there's nothing else to bring down. So we get to our final step, which says repeat or remainder. There's nothing to repeat because I didn't bring anything down. So remainder is just 94. Okay, the remainder is 94. Let me erase this real quick, and I'll write the remainder up here. So essentially what happens is I took 13,576,282. I split it into equal groups of 111. I got 122,308 of them, and then I had 94 left over. Now again, to check this, you would multiply the 122,308 by 111. Then when you get that result, you would add your remainder back to that, and that will give you the original dividend, which is 13,576,282. And go ahead and try that for yourself at home. Hello and welcome to Pre-Algebra Practice Set number 15. In this video, we're going to look at some additional practice problems for the lesson that we did on the Introduction to Exponents. Okay, so we're going to start out with some pretty easy problems. We want to just identify the base and exponent in each. So remember, when we're talking about a number like 9 to the 7th power, the number 9, this bigger number, is referred to as the base. The number 7, this smaller number, is referred to as the exponent. Remember what this is telling me. It's telling me that 9 is multiplied by itself 7 times. So 9 to the 7th power is 9 times 9 times 9 times 9 times 9 times 9 times 9. Again, 7 factors of 9. So this number right here, the 9, is the base. That's the number we're multiplying by itself. And then again, 7, the exponent, tells me how many factors of the base that we have. So what about 6 to the 3rd power, or as I told you in the lesson, we say this is 6 cubed. The 6 is the base. This is the base. Again, that's always the bigger number. And then the smaller number is the exponent. Again, this tells me I have 3 factors of 6. Okay, what about 8 to the 4th power? So again, the bigger number, 8, is your base. That is the number that's being multiplied by itself. And then 4, the smaller number, is the exponent. This is the exponent. So this would be 8 times 8 times 8 times 8. Right, that would be 8 to the 4th power. Again, the base is 8 because that's what's being multiplied by itself. And 4 is the exponent. That tells you how many factors of 8 that you have. Okay, now we want to write each in exponent form. So we have 9 times 9 times 9. So the number that's being multiplied by itself is 9. Again, that's the base. So I'm going to write that as the bigger number. Then the number of factors we have 1, 2, 3. That's our exponent. That's the little small number up in the top right corner. So this would be 9 to the 3rd power, or 9 cubed. What about this one? 3 times 3 times 3 times 3 times 3 times 3 times 3. So my base here, the number that's being multiplied by itself, is 3. Right? That's your bigger number. Then how many factors of 3 do I have? I have 1, 2, 3, 4, 5, 6, 7. So this is going to be 3 to the 7th power. Again, the exponent, the smaller number, is telling you how many factors of 3 that you have. Okay, for the next one, we have 7 times 7 times 7 times 7. And again, it's really simple. The base is the number that's being multiplied by itself. So that's 7. That's your bigger number. Then the small number is the number of factors you have. So you have 1, 2, 3, 4. 4 is the exponent. So we have 7 to the 4th power. Okay, now we're looking at 4 times 4. So the number that's being multiplied by itself is 4. And we have just 2 factors. So the exponent is 2. So this is 4 to the 2nd power, or as we refer to it as, 4 squared. Okay, now let's look at 6 times 6 times 6 times 6 times 6. So again, the bigger number is going to be 6, right? That is the number that's being multiplied by itself, called the base. And then we have 1, 2, 3, 4, 5 of these. So that's going to be your exponent. Right? Your exponent is going to be 5. That's telling me how many factors of 6 that I have. Okay, now we want to write each as a repeated multiplication. And so we're going to start out with 1 to the 9th power. So what would this be? The base tells me what I'm multiplying by itself. So I know I'm going to be multiplying 1 by itself. And then the exponent tells me how many times. So 9 tells me how many times. So I'm going to have 9 factors of 1. So that's 3, 4, 5, 6, 7, 8, and then 9. Let me make sure I did that right. I got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 factors of 1, that's 1 to the 9th. What about 7 to the 2nd power, or 7 squared? Well, that's going to be 2 factors of 7, right? So 7 times 7. What about 2 to the 4th power? 2 to the 4th power. Again, 2 is the number that I'm multiplying by itself. 4 is the number of times I'm doing that. So we'd have 2 times 2 times 2 times 2. What about 15 to the 3rd power, otherwise known as 15 cubed? Well, again, I'm just going to take this number, the base, and multiply it by itself this number of times. So 15 times 15 times 15, and we're done. What about 18 to the 5th power? Again, I'm just going to take the base, which is 18, multiply it by itself 5 times. So 18 times 18 times 18 times 18 times 18. So now we want to evaluate each. That just means find out the value. So how do we find the value for 2 to the 5th power? Well, basically all we need to do is write this using multiplication. 2 to the 5th power is 5 factors of 2. So 2 times 2 times 2 times 2 times 2. And then we just multiply. And a lot of these, especially with 2 as the base, you'll memorize those very quickly because you use them all the time. 2 to the 5th power is 32. And I know that from memory, but you can go through and multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. What about 3 to the 3rd power, or 3 cubed? So again, this is 3 factors of 3. 3 times 3 times 3. And just multiply. 3 times 3 is 9. 9 times 3 is 27. What about 4 squared? 4 squared is 4 times 4, which is 16. What about 5 to the 4th power? So this is 5 times 5 times 5 times 5, right? 4 factors of 5. 5 times 5 is 25. 25 times 5 is 125. And then for memory, I know that 125 times 5 is 625. But if you don't know these things, you can always go through and just do the vertical multiplication. It takes a little bit of time, but over time, things like this, like 5 cubed, 5 to the 4th, 2 to the 5th, 2 to the 6th, these things that come up over and over and over again, you're going to memorize them very, very quickly. What about 10 to the 9th power? Well, I told you a little trick for this in the lesson. If I have 10 as a base, and I have a whole number exponent that is larger than 1, so meaning 2, 3, 4, 5, 6, so on and so forth, basically all I need to do is write down a 1 and follow it with this many number of zeros. So my exponent is a 9, so I would follow that one with 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Comma, comma, comma. So you end up with 1 billion as your answer. Okay, final problem. Again, we're using the same trick. We have 10 to the 13th power. So all I need to do here is write a 1 and follow it with this many number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. Put in my commas. And we end up with 10 trillion. Hello and welcome to Pre-Algebra Test Section 1 on the Introduction to Exponents. Okay, so we want to just identify the base and exponent in each. Okay, so we're going to start out with 1 to the 4th power. So for 1 to the 4th power, this bigger number here is known as the base. This smaller number here, the 4, is known as the exponent. The exponent. And remember the definition. If I have something like 1 to the 4th power, it's telling me I have 4 factors of 1, or 1 multiplied by itself 4 times. The base, again, the bigger number, is the number that's being multiplied by itself. And the 4, the exponent, is how many times I'm doing that, right? How many factors of 1 do I have? I have 1, 2, 3, and then 4. Next, we're going to look at 2 to the 15th power. Again, the bigger number is known as the base. This is the number we're multiplying by itself. And then 15, that smaller number, is the exponent. So for this one, it's telling me that I have 2 being multiplied by itself 15 times. So if we were to write that out, you'd have 2 times 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 2. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. So that would be 15 factors of 2, or 2 to the 15th power. And you can see where exponents help us. It's a lot more convenient to write this than to have to go through and write all of that. Okay, what about 8 to the 7th power? Again, 8, this big number, is known as the base. That's the number we're multiplying by itself. And then 7, the smaller number, is the exponent. This is how many factors of 8 we're going to have. What about 9 to the 19th power? Again, 9, the bigger number, is the base. And then 19, that smaller number, is your exponent. So I would have 19 factors of 9. Okay, last one. We have 10 to the 12th power. And the bigger number here, the 10, is the base. And the smaller number, the 12, is the exponent. So this is telling me I have 12 factors of 10. Hello and welcome to Pre-Algebra Test Section 2 on the Introduction to Exponents. Okay, so for the problems today, we want to write each in exponent form. So we begin with 2 times 2 times 2. And so to write this using exponents, the big number, or the first number we're going to write, is 2. That is called the base, and this represents the number that's being multiplied by itself. In this case, it's 2 times 2 times 2. 2 is being multiplied by itself, so that's our base. The second number we're going to write is the exponent. That's going to go in the top right corner. It's going to be a small number, and it's going to tell us how many factors of the base we have. We have 1, 2, 3 of them. So I'm going to put a little small 3 right there. This is my exponent. Okay, so we read this as 2 to the 3rd power, or 2 cubed, and that's 2 times 2 times 2. Okay, let's look at 15 times 15 times 15 times 15 times 15. So the base here will be 15. That's the number that's being multiplied by itself. And then we have 1, 2, 3, 4, 5 factors of 15. So 5 will be the exponent. Again, this is the base. That's the number we're multiplying by itself. That's 15. And then we have 5 of these, right? We have 5 factors of 15. So 5 is our exponent. What about 7 times 7? Well, the number that's being multiplied by itself is 7. And we have 2 factors, right? We have 7 times 7, so the exponent is 2. Again, 7 would be the base, and 2 would be your exponent. What about 8 times 8 times 8 times 8 times 8 times 8? Well, again, the number that's being multiplied by itself is 8, so that is going to be our base. That is our base. And then we do this 1, 2, 3, 4, 5, 6. We have 6 factors of 8, so 6 is the exponent. 6 is the exponent. Okay, so I had to shrink down the font a little bit just to show this to you. We have 10 times 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 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors of 10. So to write this using an exponent, the base is 10, right? The base is 10. That's the number we're multiplying by itself. And then the exponent is 10, right? Because we have 10 factors of 10. So the exponent is also 10. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Exponents. All right, so for the problems today, we want to write each as a repeated multiplication. And we start out with 215 to the 3rd power, otherwise known as 215 cubed, right? When we have something to the 3rd power, we generally say it's cubed. So what do we want to do here? Well, we're just going to write this using multiplication. So the 215, the base, is the number that we're multiplying by itself. And the 3, the exponent is the amount of times that 215 is going to be a factor. So we have 215 times 215 times 215, right? 3 factors of 215. And that's what 215 to the 3rd power, or 215 cubed, is telling me I have. What about 100 squared? Well, that's just 2 factors of 100, right? It's this number here, the 100, the base, times itself. 100 times 100. 2 factors, again, that's what the exponent's telling me, 2 factors of 100. What about 9,000 to the 5th power? Well, that's just 5 factors of 9,000. So 9,000 times 9,000 times 9,000 times 9,000 times 9,000. And that's 5 of them, right? I got 9,000 times 9,000 times 9,000 times 9,000 times 9,000. So 5 factors of 9,000. What about 14 to the 7th power? So that's just going to be 7 factors of 14. So 14 times 14 times 14 times 14 times 14 times 14, and then times 14. Again, 7 factors of 14. Okay, last one. We have 19 to the 4th power. So this is, again, is just telling us we have 4 factors of 19. So we write this as 19 times 19 times 19, and then times 19. 1, 2, 3, 4 factors of 19. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Exponents. Okay, so for the problems today, we just want to evaluate each, which means we're just going to find the value. So we're going to start out with 10 to the 4th power. So normally what we do is we just go through and we write this using multiplication, and then we solve the multiplication. But when we have 10 as a base, and we have a whole number exponent that's larger than 1, we can use a little trick. And I taught you this in a lesson. Basically, what you want to do is write the number 1 and follow it with the exponent number of zeros. So if I have a 4 as an exponent, I would put 1, 2, 3, 4 zeros, and I'm done. I end up with the number 10,000 as a result. And if you want to go through and prove that to yourself, you can do it the long way. 10 to the 4th power tells me I have 4 factors of 10. So 10 times 10 times 10 times 10. And using our trick from the lesson where we learned about multiplying with trailing zeros, we would have 1, 2, 3, 4 factors of 1. So that would just be 1, right? 1 times 1 times 1 times 1 is just 1. And then you would attach 1, 2, 3, 4 trailing zeros. 1, 2, 3, 4. And again, you end up with 10,000. Okay, what about 3 to the 3rd power, otherwise known as 3 cubed? Well, basically all I'm going to do is multiply 3 by itself 3 times. So 3 times 3 times 3, right? 3 factors of 3. 3 times 3 is 9. 9 times 3 is 27. What about 9 to the 2nd power, or otherwise known as 9 squared? This is just 2 factors of 9. So 9 times 9, and that's 81. Okay, let's look at 13 squared. So this is going to be 13 times 13, right? 2 factors of 13. And you can do this using vertical multiplication. I happen to know the answer is 169 off the top of my head, just through memorization. But if you were to do this with a vertical multiplication, again, pretty simple. 3 times 3 is 9. 3 times 1 is 3. Then I'm multiplying 1 times 13. I'm just moving it over. So 1 times 3 is 3. 1 times 1 is 1. And you just bring down the 9. 3 plus 3 is 6. Bring down the 1. And of course, you get 169. Okay, last one is 2 to the 5th power. And this one's pretty easy. I've memorized this. I know it's 32. And you'll memorize this one pretty quickly too. But again, it's 5 factors of 2. So 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 16 times 2 is 32. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Exponents. Okay, for the problems today, we just want to evaluate each. And again, that just means to find the value for. Okay, so we start with 10 to the 15th power. And again, I've shown you a trick for this in the lesson and in a couple other videos that we did in this series. Essentially, if you have 10 as your base, and you're raising it to an exponent that's a whole number that is larger than 1, so 2, 3, 4, 5, 6, so on and so forth, you can use a little trick. Basically, you just write a 1 followed by this number of zeros. Okay, so whatever the exponent is, you follow it with that number of zeros. So you'd have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can't fit that way. Let me kind of start this over. A 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros. So comma, 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 comma. That is a really big number. And this trick saves you a lot of time. You don't have to go through and write out 15 factors of 10, then try to multiply them. Obviously, you can multiply them using the trick for multiplying with trailing zeros, but still writing all that stuff out is time consuming. So in case you don't know what this number is, you can kind of look here. This is the hundreds place. This is the hundred thousands place. This is the hundred millions place. This is the hundred billions place. This is the hundred trillions place. So what comes to the left of that? It's called the quadrillions place. So this would be 1 quadrillion. Okay, now we have 3 to the 4th power. So again, the exponent tells me how many factors of 3 I have. So 3 to the 4th power tells me I have 4 factors of 3. 3 times 3 times 3 times 3. And I just go through and multiply. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. What about 2 to the 7th power? This is 7 factors of 2. So 2 times 2 times 2 times 2 times 2 times 2 times 2. So 7 factors of 2. And I happen to know this is 128 off the top of my head. But again, you can go through it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And like I keep telling you, it's very useful for you to memorize, especially with 2 as the base. Say like 2 squared kind of through, let's say, 2 to the 10th power. They come up pretty often in your exams, and especially when we get the standardized test, you'll see 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th all the time. So it's helpful to memorize those so you can just shoot out the answer right away. What about 15 squared? So this is 15 times 15. And we looked at this in one of the videos. We know the answer already should be 225. Right? But if you didn't know that, you can go through and do a vertical multiplication. Right? 15 times 15. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Then you'd have 1 times 15. You just have to scoot that to the left, right? So I'm going to write 15, a 5, and then a 1. Kind of think about writing it backwards. And then I'm going to add. Bring down the 5. 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. And of course, I get 225. But I know this from memory, and over time you will as well, because another thing you're going to memorize is you're going to know all from basically 2 squared down through 20 squared. You'll have those memorized by the time you leave 10th grade. You'll know that for sure because it just comes up so frequently. All right, for the last one, we're going to look at 10 to the 6th power. And again, use my trick for this. So you're just going to write a 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. And so you're going to have 1 million as your answer. And again, use this anytime you have 10 as your base and you have a whole number for the exponent that's larger than 1. So again, 2, 3, 4, 5, 6, 7, 8, anything like that. Anything that's a whole number that's larger than 1, you can use this trick. Hello and welcome to Pre-Algebra Practice Set number 16. And in this video, we're going to look at some additional practice problems for the lesson that we did on the order of operations. Okay, so before we look at any examples, let's just go over the order of operations one more time. Now, the order of operations is something you want to write down, and as you're solving your problems, just kind of refer to it at first. Okay, this is 1, this is 2, this is 3. Go through the steps. After you do enough problems, you won't need that piece of paper anymore. You will just remember it. So the first thing that you always want to do when you work any problem is you want to start off inside of any grouping symbols that you might have. And a lot of people will just say parentheses, but this will include brackets, or you might get a set of curly brackets like that, or whatever you might come across. Any grouping symbols that you have, you need to start out by working inside of those first. So I'm just going to put this as parentheses. Then after you've taken care of what's inside of parentheses, you move on to the next step, which is to take care of any exponent operations you have. So I'm going to write exponents. Then your third step would be multiplication or division. So why do I have this or there? Well, it's because multiplication and division are technically on the same level. They're the same step. So when we come across multiplication and division in the same problem, we work left to right. Okay? We work left to right. And this is a big deal because a lot of students will get this wrong because They'll memorize stuff like PEMDAS, which we talked about in the lesson, right? The please excuse my dear Aunt Sally, and they'll say, well, hey, that M comes before the D, so I must multiply before I divide. No. Multiplication and division, I can't say this enough, are on the same level. You do them left to right. Okay, now the fourth step, or the fourth highest priority, or your lowest priority in any problem, is to add or subtract. Add or subtract. And again, this is on the same level, so we follow this same rule. We do it from left to right. Left to right. Okay? So that's the main thing that you need to remember. This is what trips students up the most. Multiplication and division occur on the same step, left to right. Addition and subtraction occur on the same step, left to right. Okay, let's look at some problems. And we want to evaluate each, and that just means we're going to find the value. So we're going to start with the quantity, 10 minus 6. And I guess I said the quantity because 10 minus 6 is inside of a set of parentheses, then divided by 2. So as you just heard me say, your highest priority in any problem is to work inside of any grouping symbols. In this case, those grouping symbols would be parentheses. So if I look inside the grouping symbols, I have an operation of subtraction. So I want to do 10 minus 6. This is my highest priority in this problem. So 10 minus 6 is 4. So what I'm going to do is I'm going to replace this right here, this 10 minus 6 inside of parentheses, with a 4. And then I'm going to copy the rest of the problem. So divided by 2. And now I have one single operation left, and I just crank that out, and I'm done. 4 divided by 2 is 2, and that's the answer to our problem. We have 8 divided by 4, then times 5. So a perfect example of where you have division and multiplication. And again, where students get confused is they memorize the PEMDAS, right? And you may have seen this, you might have no idea what I'm talking about, but this is kind of a way for you to remember the order of operations. You'd say, please excuse my dear Aunt Sally. Okay, parentheses, exponents, multiplication, division, addition, subtraction. That's what those letters stand for. And because students see multiplication here and division here, they assume that multiplication comes before division. No. These are on the same step, and these are on the same step. They work left to right. So when we see multiplication and division in the same problem, we work left to right. So that means because division occurs first or to the left, we do it before we do the multiplication. So we would do 8 divided by 4 to start. 8 divided by 4 is 2. So we're just going to replace this with this 2, and we copy the rest. And then times 5. And now we have one single operation left. 2 times 5 is 10. And we are done. Okay, now we have 6 minus 1 plus 3. Again, kind of the same situation we came across. We have subtraction and addition. Those are on the same step. We want to work left to right. So because the subtraction occurs to the left of the addition, we do that first. So 6 minus 1 will be our first operation. 6 minus 1 is 5. So I'm going to replace this with a 5. And then I just copy what's left. So plus 3. And one operation left. 5 plus 3 is 8. And we are done. Okay, for the next one we have the quantity, 3 minus 1. Then times 5. Then minus 2. So again, the highest priority would be to work inside of any grouping symbols. And here those grouping symbols are parentheses. So we want to do 3 minus 1 before we do anything else. So 3 minus 1 is 2. So I'm just going to replace this with a 2. Copy the rest of this problem. Times 5 minus 2. And now if we look at the problem, we have multiplication and we have subtraction. So the highest priority here is multiplication. We would do 2 times 5 first. 2 times 5 is 10. So I'm just going to replace this 2 times 5 with a 10. And what's left is minus 2. One final operation, 10 minus 2 is 8. And we are done. Okay, for the next one we have the quantity, 18 minus 6, divided by the quantity, 6 minus 2. So you'll notice that we're going to be working inside the parentheses first in each case, and then we're going to do this division. So in other words, the result of this divided by the result of this. So what is 18 minus 6? 18 minus 6 is 12. So I'm going to replace this with a 12. And then divided by, and then I'm going to copy this, the quantity 6 minus 2. Next, we'll work inside of these parentheses. What is 6 minus 2? That's 4. So I'm going to have 12 divided by, again, the result of this is 4. And one last operation, we just have division, right? 12 divided by 4 is 3. So that is our answer. Okay, let's look at another one. We have 2 times 2 inside of a set of parentheses, then divided by 2. So again, we always work what's inside of parentheses first. So we would do 2 times 2 first, so that's 4. And then we would be dividing by 2. And then we just crank this one out. 4 divided by 2 is 2. And so that's our answer. All right, let's look at one that's a little bit more challenging. Here we have 4 times. Remember, we're implied multiplication here because the 4 is next to a set of parentheses. Inside the parentheses, we have 2 cubed minus, and then another set of parentheses, an inner set of parentheses with 5 plus 1, then plus 1, and then outside these parentheses, we have plus 2. So whenever we work a problem, we always start inside of the parentheses that we have. So you kind of think of this as the first set of parentheses. This is where we look to. But when we get inside of here, we have another set of parentheses involved, right? Because we have multiple operations inside the parentheses. So essentially what we're doing is we're reapplying the order of operations. And that tells us to do parentheses first. So that's why we always say start with the innermost set. So we go to the innermost set, which is right here. So we'll begin with 5 plus 1. 5 plus 1 is 6. So all I'm going to do is I'm going to copy everything, and I'm going to replace the 5 plus 1 that's inside the parentheses with a 6. So 4 times, remember that's times because it's next to the parentheses. And then inside the parentheses we have 2 cubed minus, I'm replacing this with a 6, plus 1. Close the parentheses, then plus 2. Now, we're still working inside of the parentheses now. Okay, we just, so far, just dealt with the innermost set. Now we have to deal with this. So when I look inside the parentheses, I have an exponent, I have subtraction, and I have addition. So I need to deal with that exponent first before I do anything else. So we will have 4 times, and then inside the parentheses, this 2 cubed represents 2 times 2 times 2, right? 3 factors of 2. So 2 times 2 is 4, 4 times 2 is 8. So this will be replaced with an 8, and then I can copy everything else. Minus 6, plus 1, and then close the parentheses, plus 2. Now we're staying inside the parentheses. This is still our highest priority. And basically we just work left to right now because we have subtraction and addition. And so 8 minus 6 will be done first. 8 minus 6 is 2. So we can write this as 4 times, okay, inside of parentheses. The 8 minus 6 is now a 2, then plus 1, close the parentheses, then plus 2. Okay, so now looking at this, we're still not done inside the parentheses. We have one final operation to do. We need to do 2 plus 1. So we'll have 4 times, remember we're implying multiplication because the 4 is next to the set of parentheses. So 4 times the result of this, 2 plus 1 is 3. 3 and then plus 2, plus 2. Okay, so we have 2 operations left. We have multiplication and we have addition. Multiplication is the higher priority. So we're going to do 4 times 3 first. 4 times 3 is 12. And then we have plus 2. And then to finish this off, 12 plus 2 is 14. Okay, now let's look at 4 times, and then we have the quantity 2 plus 3. And then divided by 5 plus, and then we have a quantity 3 minus 1, then times 4. Okay, so again, we want to start inside of any parentheses we may have. So we have parentheses here and here. So let's take care of those first. So we have 4 times, okay, remember this implies multiplication. 2 plus 3 is 5. So I'm going to write this as 5, and then divided by 5, and then plus, inside of parentheses, 3 minus 1, and then times 4. Okay. Next, I'm going to deal with these parentheses here. So 3 minus 1 we know is 2. So I'm going to copy this, 4 times 5, divided by 5, plus, again, 3 minus 1 is 2. This is going to be 2, and then times 4. Times 4. Okay, so now we have multiplication, division, addition, and multiplication. So again, multiplication and division occur on the same step. They're on the same level. We work them left to right. So because this multiplication symbol appears to the left of this division symbol, we're going to multiply first. So what is 4 times 5? 4 times 5 is 20. So I'm going to replace this with a 20. then divided by 5 plus 2 times 4. Next, I'm going to do this division. I do this division first because it occurs to the left of this multiplication. So 20 divided by 5 is 4. So this will be 4, and then plus 2, and then times 4. So now I'm just left with addition and multiplication, and we need to multiply first. So we're going to do 2 times 4 before we do anything else. 2 times 4 is 8. So this will be 4 plus 8, and 4 plus 8 is 12. Okay, so we saved the best for last. So we have 6 divided by, and then inside of brackets, okay, you see these little brackets here, we have 4 minus, and then inside of parentheses, we have 2 squared minus 1, then plus 3 minus, and then inside of parentheses, 6 minus 5. So a lot of grouping symbols involved here. So obviously we want to start inside of the grouping symbols, and brackets are grouping symbols. Very important that you understand that. But once I look inside my kind of outer set of grouping symbols, the brackets, I see that I have parentheses here and I have parentheses here. Okay, so I need to work inside these parentheses first before I can do anything else. So I'm going to start with 2 squared minus 1. So even inside of this right here, this 2 squared minus 1, I have multiple operations. I have an exponent and I have subtraction. I know that I want to do the exponent first. 2 squared is 2 times 2, that's 4. So I'm going to say 6 divided by, and then inside of brackets, 4 minus. The 2 squared is going to be 4 now, so I'm going to put inside of parentheses 4 minus 1, then plus 3 minus, and then inside of parentheses 6 minus 5. Close those brackets. And now I'm going to do 4 minus 1. Okay, now I'm going to work on 4 minus 1. 4 minus 1 is 3. So I'm going to replace that. So 6 divided by, open these brackets, we're going to have 4 minus 3 plus 3 minus, and then inside of parentheses, 6 minus 5. So next we're going to work inside of this set of parentheses. So we have 6 minus 5 in here. 6 minus 5 is 1. So I'm just going to replace that. So we're going to have 6 divided by, open up these brackets, 4 minus 3 plus 3 minus, again, 6 minus 5 is 1. So what's left? Well, we still have grouping symbols, so we still need to stay inside of there. And once we look in there, now we just have subtraction and addition. So when we add and subtract, we go left to right. So essentially, I'm just going to go 6 divided by, and inside the brackets, I would start with 4 minus 3. 4 minus 3 is 1, so I'd have 1 plus 3 minus 1. Okay, so we have 6 divided by, and inside the brackets now, the next thing we're going to do is this addition operation because it's to the left of the subtraction. So 1 plus 3 would be 4. So I'm just going to replace that with a 4, and then minus 1. And then now inside the brackets, we do 4 minus 1, that's 3. So we're left with 6 divided by, and again, inside of here, the result is 3. And so now we finally have one operation left, and that's 6 divided by 3. And of course, that equals 2. Hello and welcome to Pre-Algebra Test Section 1 on the order of operations. Okay, so for the problems we're going to look at today, we just want to evaluate each. And obviously these problems are going to deal with the order of operations. So in case you don't know them, I'm going to briefly cover them real quick, and I'll do that in each video that I do. I want you to write them down as I do, and just use them as you solve your problems. And then after you've solved enough problems, you really won't need them anymore. So your first thing that you're going to do when you work a problem is work inside of any grouping symbols. And generally we just write parentheses for this step. So parentheses. But this would be any grouping symbols you have. You might have brackets, you might have curly brackets, something like that. Any grouping symbols, work inside of those first. The second thing you're going to do is perform any exponent operations. So I'm just going to put exponents. The third thing you're going to do is multiply, or divide. And I've talked about this in the lesson and in the practice set video. This occurs on the same step. You work them left to right. Left to right. And I know this is where a lot of students get confused. They say, oh no, you're supposed to multiply before you divide. That's not true. Multiplication and division occur on the same step. We work them left to right. So whichever one appears to the left of the other, we do that one first. Okay, The fourth step is addition and subtraction. So I'm going to put add or subtract. And this is also a left to right. This is left to right. Okay, so these occur on the same level. And again, we work them left to right. Okay, so go ahead and copy this down. Make sure that you have it. And then we're going to use them to work these problems. All right, so for the first problem, we have 6 times 2 minus 2. So if you think about what operations are involved here, I have multiplication and I have subtraction. So multiplication has a higher priority. If you were to go back and look at that list that I had, and I'll put it back on the screen for a second. If you look at this, you see that you multiply or divide before you think about addition or subtraction. That's why we're going to start this problem by doing 6 times 2. Okay, so 6 times 2 would give us 12. So I just replace this right here with a 12. And then I just kind of copy what's left. I just have a minus 2 left. And now I just have one single operation. I just have 12 minus 2. And 12 minus 2 is 10. So 12 minus 2 equals 10. And now we're done with that problem. Okay, the next problem is 2 plus 5 times 4. So again, 2 operations involved. We have addition and we have multiplication. So multiplication is done before addition. So that means we're going to do 5 times 4 first to begin this problem. So we would have 2 plus the result of 5 times 4. And 5 times 4 is 20. Let me kind of make that a little smaller. So I'm going to put a 20 there. And now I just have one operation. 2 plus 20, and that is 22. Okay, now we have 6 squared minus 1. 6 squared minus 1. So I have an operation with exponents here. I have that squared. And then I have subtraction. So exponents are the highest priority. So I want to do 6 squared first. That's 6 times 6, or 36. So just replace this 6 squared with a 36. And then we're subtracting away 1 from that. And now we just have one operation. 36 minus 1 is just 35. Okay, for the last problem, we have the quantity 9 minus 3 divided by 6 plus 1. So I'm going to always start out inside of any parentheses that I may have. So I have parentheses here. And the operation in there is just 9 minus 3. So 9 minus 3 is 6. So I'm just going to replace this with a 6. And just copy everything else. So divided by 6 plus 1. Now, what I have left is I have division and I have addition. Now, I want to divide before I add because division is a higher priority. So I would do 6 divided by 6 first. 6 divided by 6 is 1. So I'm going to replace this part of this problem with a 1 and then copy what's left. So I just have plus 1 left. And when I go to solve that, it's just 1 plus 1, and that's 2. Hello, and welcome to Pre-Algebra Test Section 2 on the order of operations. So for the problems we're going to look at, we just want to evaluate each. And kind of before we start, let me just briefly say a few things about the order of operations. And I know most of you have seen all the videos up to this point, and you want to just jump into the problems. But essentially, the order of operations, again, is a guide to tell us which operations to perform in which order when we have a problem with multiple operations. So, for example, in this first problem, we have 6 divided by 3 plus 2 minus 1. How do we know whether to divide first, to add, to subtract? What do we do? So let me just paste this. This is what I wrote in the last video. And basically, these are your steps. You kind of go through 1, then 2, then 3. It's a level of priorities that you can use to find the answer to your problem. So the first thing you do, your highest priority in any problem is to work inside of any parentheses. Then you want to deal with any exponents. Then you want to multiply or divide. And remember, I keep saying this, that is the same level. You work them left to right. So let me highlight that. So multiplication, division, same level, work them left to right. Then the same for addition and subtraction. Same level, you work them left to right. So meaning if I have 3 times 2 divided by 4, I would multiply before I divide because the multiplication is on the left. If I switch this and I put the division here and the multiplication here, I'm going to now divide first before I multiply because the division is on the left. So that's what we mean when we say work left to right. Whichever occurs on the left is done first. Okay, let me erase all of this. And we begin with a pretty easy problem. So 6 divided by 3 plus 2 minus 1. Again, look at your list and say, well, what's the highest priority here? I have division, I have addition, and I have subtraction. Division is the highest priority, so we would do 6 divided by 3 first. We would do this first. So 6 divided by 3 is 2. So all I'm going to do now is just replace this part of this problem with a 2 and just copy what's left. I have plus 2 minus 1. Now I have addition and subtraction. Those occur on the same level, so they have the same priority. But we work them left to right, so we kind of think about it going this way. Which occurs first? Well, the addition does. So that's why I'm going to do 2 plus 2 first before I think about the subtraction. So 2 plus 2 is 4. So I'm going to write a 4 down there, and then we're subtracting away 1 now. So now I have 4 minus 1, single operation, 4 minus 1 is 3, and we're done. Okay, now we have the quantity 5 plus 3. So when I say the quantity, that's because 5 plus 3 is inside of parentheses. Then we're multiplying by 3, and then we're adding 3. So what's our highest priority here? Well, we always look for parentheses or any grouping symbols whenever we start a problem. So the highest priority would be to work the operations inside of the parentheses, okay? Inside of the parentheses. So what is 5 plus 3? That's 8. So I would just replace this with an 8 and copy what's left. So times 3 plus 3. So now I have multiplication and I have addition. Okay, so I want to do multiplication before addition. It's a higher priority. So I would do 8 times 3 first. That's 24. And then we're adding 3, so plus 3. One operation left. 24 plus 3 is just 27. Okay, let's look at 5 times, and then we have 4 times 2 inside of a set of parentheses, and then divided by, and then we have 1 plus 3 inside of a set of parentheses. Again, the highest priority when you work a problem is looking at what's inside of parentheses first. Okay? So when we think about this, we would do 4 times 2. 4 times 2, that's 8. So I can write 5 times 8, and then divided by, and then 1 plus 3, this quantity, right? It's inside of parentheses. So we have these parentheses left. We still have to deal with those first before we can do anything left. So we'd have 5 times 8 divided by, I just copied this part, the result of this. 1 plus 3 is 4. So now we have multiplication and division only. Again, those have the same level of priority. We work them left to right. So going this way. Now, what occurs to the left? The multiplication does, right? So we're going to do that first. So 5 times 8 would give us 40. And then we're dividing by 4. So divided by 4. One operation left. 40 divided by 4 is 10. Okay, let's take a look at the last one. We have 5 squared minus, and then inside of parentheses, 6 divided by 3 plus 5. So again, whenever we work a problem, we want to start out by looking at, hey, do we have any parentheses or grouping symbols? And then we want to start inside of there. But if you look inside the parentheses, we actually face another problem because we have division and we have addition. So when you get inside of the set of parentheses or the brackets or whatever the grouping symbols are, you need to reapply the order of operations. So you just say, okay, this is my problem now, and what's the highest priority? Well, division is a higher priority than addition. So we do the division first. So I would do 6 divided by 3 before I think about adding anything. So 6 divided by 3 is 2. So I'm going to do 5 squared minus, and then the result of 6 divided by 3 again is 2. And then we'll have this plus 5. Okay, and so now we're going to continue inside the parentheses there. Inside the parentheses, we have 2 plus 5 now. So 2 plus 5 is 7. So we'd have 5 squared minus, again, this is 7. And now when we look at our problem, we have 2 operations left. We have this exponent here that we have to deal with, and we have the subtraction. So exponents are your next highest priority after you deal with parentheses. So 5 squared would be 5 times 5, that's 25. And then we'd be just subtracting away 7. So to finish this problem off, 25 minus 7 gives us 18. Hello and welcome to Pre-Algebra Test Section 3 on the order of operations. Okay, so for the problems we're going to look at, we just want to evaluate each. And before I kind of start with the first problem, let's just take a look at kind of the order of operations. And this is kind of handwritten, but I want you to write these down if you don't already have them written down and use it as we're solving the problems. As you work more and more problems, you'll get more and more comfortable with this, and eventually you'll have it memorized and you won't need to use it at all. Basically, the first thing that you want to do when you have a problem with multiple operations is work inside of any parentheses. And when I say parentheses, we also want to include in that brackets. So basically any grouping symbols that you come across, you need to work inside of those first. The next thing you want to do, or your next highest priority, would be to perform any operations involving exponents. Then when you're done with that, you want to look at multiplication and division. Now, multiplication and division occur on the same step, so they have the same level of priority. So what do we do if we have multiplication and division in the same problem? We work left to right. We work left to right. So whatever occurs to the left of the other is what we do first, okay? And the same thing goes for addition and subtraction. They have the same priority level, but again, we're going to work them left to right. So now let's look at the first problem. All right, so we're going to begin with 4 squared minus the quantity, 3 plus 6, minus the quantity, 4 minus 2, then plus 2. So we always want to start by working inside of any grouping symbols that we have. So we have parentheses here, and we have parentheses here. So we basically want to work inside of those before we do anything else, okay? So I'm going to copy 4 squared minus, what is 3 plus 6? We're doing that first. 3 plus 6 is 9. So I'm going to replace this with a 9. Then I'm just going to copy what's left. So minus, we have this quantity 4 minus 2, then plus 2. I'm not done with the parentheses. I still have this 4 minus 2 to deal with inside of parentheses. So let's do that. 4 minus 2 is 2. So let's copy this problem down as 4 squared minus 9 minus, again, the result of this is 2, then plus 2. Now if I look at what's left, I just have an exponent, subtraction, and addition. So addition and subtraction occur on the same level, but they're a lower priority than doing 4 squared, right? We want to do anything with exponents first. So 4 squared is 16, right? It's 2 factors of 4. It's 4 times 4. It's 16. So 16, and then minus 9, minus 2, plus 2. So just subtraction and addition. These have the same level of priority. We work them left to right. So kind of the first operation, or the leftmost operation, would be 16 minus 9, and that gives us 7. So I'm going to replace this with a 7, and then we have minus 2 plus 2. And let's just scroll down a little bit, get a little room going. And kind of the next thing we're going to do, we have 7 minus 2 plus 2. This is your leftmost operation, so we're going to do 7 minus 2. That's 5, and then plus 2. And then one final operation, 5 plus 2 is 7. Okay, the next one's a little challenging. It's actually a little challenging to read through too. So we have 3 times, remember when you have a 3 next to the parentheses there, that's telling us we have 3 times the result of the parentheses. Now, when you have multiple parentheses involved, like you do in this problem, it kind of helps to take and say, okay, where are the parentheses for? So this first set of parentheses that you come across is enclosing all of this. All of this is enclosed in that first set, okay? Let me erase that. Then once you get inside of there, you have more parentheses involved. Next, you have 3 times. Now we're going to come across another set of parentheses, and that's going to enclose this other set of parentheses with 10 minus 6. So you can say the quantity 10 minus 6 times 2. Okay, so let me highlight kind of this last set of parentheses here. So we always start, when we have parentheses, with the innermost set. And the reason for that is, once you get inside of your parentheses, you reapply the order of operations. So in other words, once we got inside of the highlighted in yellow parentheses, we looked for the highest operation. That was another set of parentheses, the ones that are highlighted in blue. Then once we got inside of there, we looked for the highest priority, which was another set of parentheses, the ones that are highlighted in green now. So we start with this innermost set, which contains 10 minus 6. And we're just going to replace 10 minus 6 with 4, right? 10 minus 6 equals 4. So we're going to copy this problem down, and the only thing we're going to change is that quantity 10 minus 6, we're going to put a 4 there. So 3, and then this will be a 4. And then we still have this times 2. Close that. Divided by 4 plus 4, and then close that. Okay. So now when we look at this problem, we still have an outer set of parentheses, and we still have an inner set of parentheses. So in other words, when you look at the outer set, you would reapply the order of operations once you got inside, and you'd look for parentheses again, and you find them right there. So we would do 4 times 2 before we tackle anything else. Okay? 4 times 2 before we tackle anything else. 4 times 2 is 8. So I'm going to put 3, and then we have parentheses, we have 3. 4 times 2 is 8. We know that, so I'm going to replace this with times 8. And again, the reason I said times 8 is because this 3 is standing outside of a set of parentheses that implies multiplication. So 3 times the result of this, 4 times 2, which was 8. Okay? Then divided by 4 plus 4. Now it's starting to look pretty easy because we just have one set of parentheses. And when we look inside of the parentheses, now we have multiplication, division, and addition. Pretty simple. So we know that multiplication and division are a higher priority than addition. And we know that multiplication and division occur on the same priority level. Okay? But we work them left to right. Left to right. So this operation, this multiplication, occurs to the left of this division operation. So we are going to multiply first before we do anything else. So 3 times 8 gives me 24. So I'm going to have 3, and then inside of parentheses, again, 3 times 8 is 24. And then we copy the rest. Divided by 4 plus 4, and close that off. Okay. Scroll down, get a little room going. Now, the next step, we're still inside these parentheses. We're still inside the parentheses. We have division and we have addition. So we know we want to divide first. That's the highest priority. So 24 divided by 4 is 6. So this will be 3 times, and now this will be the quantity 6 plus 4. All right, all I did was replace this with a 6. Now we're still inside the parentheses. So 6 plus 4 would give us 10. So I would have 3 times 10. So I could write it like this, right, if I wanted to. Or I can just write it the traditional way and put 3 times 10 like that. Doesn't really matter. Again, when you have that 3 outside of the set of parentheses, it implies multiplication. So let's finish this up. 3 times 10 is 30. Hello and welcome to Pre-Algebra Test Section 4 on the order of operations. So before we kind of get into our problem, let's just go over the order of operations real quick, just so that we're on the same page. Now, when you first start working with the order of operations, you want to write down the steps and then use that when you solve your problems. Eventually, after you work enough problems, you'll have it memorized. But for right now, make sure that you have it written down so that you can refer to it as you're working through your problems. So when we look at a problem that has multiple operations in it, we use the order of operations to tell us which operation to perform in which order. So kind of the first thing, or your highest priority, is to always look for parentheses or any grouping symbols like brackets that you might have in your problem. The next thing you want to do is perform any exponent operations. Okay, so that's your next highest priority. Then after that, you get into multiplication and division. And this one causes a lot of confusion among students. Multiplication and division have the same level of priority. When you have multiplication and division in a problem, when you have both of them, you want to work from left to right. Okay, you want to work from left to right. So that means if you had something like 5 times 3 divided by 7, you would do the multiplication first before the division because you're working left to right. Starting left, going to the right. If I flip the order of that and put the division symbol here, the multiplication symbol there, now you're going to divide first, right? Again, we're working left to right. So the same thing happens when you get to addition and subtraction. So after we've taken care of the multiplication and division, our lowest priority is addition or subtraction. So for addition and subtraction, it's the same level of priority. We work left to right. We work left to right. So in other words, if I had 5 plus 3 minus 7, I would do the addition first because it's on the left, and the subtraction last. If I flip that and put the minus here and the plus here, now the minus sign occurs to the left of the addition, so we would do the minus first. We would do 5 minus 3 first. Okay, now I think we're ready to look at our problem. So we just want to evaluate each, and we're just going to have one problem here. So we have this quantity, 3 plus 2, and it's squared, right? It's raised to the second power. Then we're subtracting away, and notice how you're going to have two sets of parentheses here. You have 10 squared divided by this quantity 6 plus 4, then minus 8, okay? Now, when we start working a problem, we're always looking for parentheses or any grouping symbols first. So let's look over here. We have a set of parentheses that we're going to work with first. We'll deal with this in a second. So I have 3 plus 2 inside of a set of parentheses. 3 plus 2 is 5. So I'm going to replace this with a 5, and now it's squared. And let me just copy the rest of this problem. Okay, now looking at this problem again, we need to reassess what's the highest priority. So I have parentheses. And I always want to work inside of those to start. Now, once I get inside of the parentheses, I reapply the order of operations, right? Because I have an exponent here, I have division, I have parentheses, I have a subtraction. What do? Well, I always go for parentheses first. So I start at the innermost set of parentheses. That's why they say that. Because once you get inside of the parentheses, you look for parentheses again. So that's what we have here. So we would do 6 plus 4 before we do anything else. 6 plus 4 is 10. So I'm just going to replace that with a 10. So 5 squared minus, let's copy the rest of this, 10 squared divided by, we're replacing the 6 plus 4 with a 10, minus 8. And now we're still working inside of the parentheses. We're still inside of this guy. We need to think about what's the highest priority. I have an exponent, I have division, and I have subtraction. So I need to take care of that exponent first. 10 squared is 100. Okay, 10 squared is 100. So 5 squared minus, the 10 squared will be 100, divided by 10 minus 8. We're still working inside of the parentheses. Now I have division and subtraction. Division is the higher priority, so we would do 100 divided by 10 next. So 5 squared minus, and then inside of the parentheses, again, 100 divided by 10 is 10, then minus 8. And one final operation to do inside the parentheses here. We just want to do 10 minus 8, and that's 2. So now we have 5 squared minus, again, this is 2. And so we're down to just two operations. We have this exponent and we have subtraction. So we know that the exponent has the higher priority. So we do 5 squared. 5 squared is 5 times 5, that's 25. So 25 minus 2. And one final operation that gives us 23 for our answer. Hello and welcome to Pre-Algebra Test Section 5 on the order of operations. Okay, so before we look at the problem, let's just cover the order of operations one last time. So when we look at the order of operations, again, this is something that gives us a guide to solve a problem with multiple operations in it. What do we do in what order? Well, this answers that for us. So the first thing we're going to do is work inside of any parentheses or grouping symbols like brackets that you may come across. Then the next thing you're going to do is perform any operations that involve exponents. Then after that, we have multiplication or division. Okay, so multiply or divide. Now, this is kind of confusing for people. This multiplication and division, this step right here, multiplication and division have the same level of priority. When you work through a problem where multiplication and division is involved, you work left to right. So if you have a problem like 10 divided by 2 times 6, you do your division before your multiplication because you're working left to right. You start on the left, the division occurs first before the multiplication. If this order was flipped and I put the multiplication symbol here, the division symbol there, well, now I'm going to multiply first, right? Because I'm working left to right. So you need to understand that. You need to write that down and put an asterisk next to it and say, hey, this is the same level of priority. We work left to right. The same thing goes when you get to addition and subtraction. It's your lowest priority, but it's the same level of priority. So addition and subtraction are the same level of priority. We work them left to right. So if I have 5 plus 7 minus 2, I would add first, working left to right. Start on the left, go to the right. if I have the minus sign over here and the plus sign over here, now I'm subtracting first, right? I'm subtracting first. Now let's take a look at our problem. So we want to evaluate each, and we just have one problem to work through. And it's going to be 8 times 12 divided by 3 times 2 plus 4 cubed plus 10 minus 11. So no parentheses involved, so immediately we can eliminate that step. And we look for any exponents. And we have this one right here. We have 4 to the third power, otherwise known as 4 cubed. So what I'm going to do is just copy everything. 8 times 12 divided by 3 times 2 plus 4 cubed. So I'm going to start with that. So 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So I just replace that with the 64, and I just keep copying the rest of the problem. Okay. Now I'm looking for the next highest priority. I have multiplication, division, multiplication, addition, addition, subtraction. So the highest priority would be to multiply or divide, and again we do this left to right. So I see that I have multiplication here all the way to the left, and it's to the left of this division. So I'm going to do that first. So what is 8 times 12? Well, that's going to be 96. Okay, that's going to be 96. And then divided by 3 times 2 plus 64 plus 10 minus 11. Now we still have division and multiplication as the highest priority, right? That comes before addition or subtraction. And again, we're working left to right. So now this division comes before this multiplication. So that's what we're going to do next. So we're going to do 96 divided by 3, and that's going to give us 32. Okay, that's going to give us 32. So then times 2 plus 64 plus 10 minus 11. So now we have multiplication, addition, and subtraction. We want to multiply first. So 32 times 2 is 64. So 64, then plus 64, then plus 10, then minus 11. Okay, now we just have addition and subtraction. And we basically just work left to right. So start all the way on the left, and 64 plus 64 is 128. 128, then plus 10, then minus 11. Then 128 plus 10 is going to be 138, then minus 11. And we'll finish this off with 138 minus 11, and that's 127.